Hi everyone, welcome to this fantastic natural language processing and machine learning course by Simplilearn. But before we begin, if you enjoy watching these videos and find them interesting, subscribe to our channel and hit the bell icon to never miss any updates from us. So let's get started. We will brief you the detailed introduction to machine learning, and moving forward we will introduce to you natural language processing. After that, we will see NLP engineer roadmap and NLP engineer salary. We will walk you through the fantastic concepts like AI versus ML versus DL, after which we will see text mining using NLP, what is generative AI, LLM models in artificial intelligence. After covering all these topics, we will see algorithms and projects like sentiment analysis and spam classifiers. Speaking of interviews, we have covered you along with the most frequently asked ML interview questions to help you crack the toughest interviews. But before we begin to understand what machine learning is, if you want to become an AI expert and gain handsome salary packages, look at the wide range of AI/ML courses by Simplilearn in collaboration with top universities across the globe. By enrolling in any of these certification programs, you will gain expertise in the skills like generative AI, prompt engineering, ChatGPT, explainable AI, machine learning algorithms, supervised and unsupervised learning, model training and optimization, and there is much more on the list. With hands-on experience in the tools like ChatGPT, DALI, Python, OpenCV, and TensorFlow, you will catch the eye of top recruiters. So what are you waiting for? Hurry up and enroll now. Find the course link in the description box. So without any further delay, over to our training experts.
Here we have our, it looks a little bit like Frankenstein, our Frankenstein-looking robot. Today, let me tell you what is machine learning. Machine learning works on the development of computer programs that can access data and use it to automatically learn and improve from experience. Watch a robot builder construct a house in 2 days. This was back in July 29th, 2016, so that's pretty impressive. This amount of time to continue to grow in its development. And it's smart enough to leave spaces in the brickwork for wiring and plumbing and can even cut and shape bricks to size. Amazon Echo relies on machine learning, and with more data it becomes more accurate. Play your favorite music, order pizza from Domino's, voice control your home, request rides from Uber. Have you ever wondered the difference between AI, machine learning, and deep learning? Artificial intelligence, a technique which enables machines to mimic human behavior. This is really important because this is how we are able to gauge how well our computations or what we're working on works, is the fact that we're mimicking human behavior. We're using this to replace human work and make it more efficient and make it more streamlined and more accurate. And so the center of artificial intelligence is the big picture of all of this put together. IBM Deep Blue Chess, electronic game characters. Those are just a couple examples of artificial intelligence. Machine learning, a technique which uses statistical methods, enabling machines to learn from their past data. So this means if you have your input from last time and you have your answer, you use that to help prove the next guess it makes for the correct answer. IBM Watson, Google search algorithm, email spam filters, these are all part of machine learning. And then deep learning, which is a subset of machine learning, composing algorithms that allow a model to train itself and perform tasks. AlphaGo, natural speech recognition. These are a couple examples. Deep learning is associated with tools like neural networks where it's kind of a black box. As it learns, it changes all these things that are, as a human, we would have a very hard time tracking. And it's able to come up with an answer from that. Now let's see how machine learning works. First, we start with training the data. Once we've trained the data, we go into the machine learning algorithm, which then puts the data into a processing, which then goes down to another machine learning algorithm. And then we take new data, because you have to test whatever you did and make sure it works correctly, and we put that into the same algorithm. Once we do that, we check our prediction, we check our results, and from the prediction, if we've set aside some training data and we find out it didn't do a good job predicting it, and it gets a thumbs down as you see, then we go back to the beginning and we retrain the algorithm. And a lot of times it's not just about getting the wrong answer, it's about continually trying to get a better answer. So you'll see the first time you might be like, oh, this is not the answer I want, depending on what domain you're working in, whether it's medical, economical, business, stocks, whatever. You try out your model, and if it's not giving you a good answer, you retrain it. If you think you can get a better answer, you retrain it. and you keep doing that until you get the best answer you can.
Now let's look into the types of machine learning. Machine learning is primarily of three types. First one is supervised machine learning. As the name suggests, you have to supervise your machine learning while you train it to work on its own. It requires labeled training data. Next up is unsupervised learning, wherein there will be training data but it won't be labeled. Finally, there is reinforcement learning, wherein the system learns on its own. Let's talk about all these types in detail. Let's try to understand how supervised learning works. Look at the pictures very carefully. The monitor depicts the model or the system that we are going to train. This is how the training is done. We provide a data set that contains pictures of a kind of a fruit, say an apple. Then, we provide another data set which lets the model know that these pictures were that of a fruit called apple. This ends the training phase. Now, what we will do is we provide a new set of data which only contains pictures of apple. Now here comes the fun part. The system can actually tell you what fruit it is. And it will remember this and apply this knowledge in future as well. That's how supervised learning works. You are training the model to do a certain kind of an operation on its own. This kind of a model is generally used into filtering spam mails from your email accounts as well. Yes, surprised, aren't you? So let's move on to unsupervised learning now. Let's say we have a data set which is cluttered. In this case, we have a collection of pictures of different fruits. We feed this data to the model and the model analyzes the data to figure out patterns in it. In the end, it categorizes the photos into three types, as you can see in the image, based on their similarities. So, you provide the data to the system and let the system do the rest of the work. Simple, isn't it? This kind of a model is used by Flipkart to figure out the products that are well suited for you. Honestly speaking, this is my favorite type of machine learning out of all the three. And this type has been widely shown in most of the sci-fi movies lately. Let's find out how it works. Imagine a newborn baby. You put a burning candle in front of the baby. The baby does not know that if it touches the flame, its fingers might get burned. So it does that anyway and gets hurt. The next time you put that candle in front of the baby, it will remember what happened the last time and would not repeat what it did. That's exactly how reinforcement learning works. We provide the machine with a data set wherein we ask it to identify a particular kind of a fruit, in this case an apple. So what it does as a response, it tells us that it's a mango. But as we all know, it's a completely wrong answer. So as a feedback, we tell the system that it's wrong, it's not a mango, it's an apple. What it does, it learns from the feedback and keeps that in mind. When the next time when we ask a same question, it gives us the right answer. It is able to tell us that it's actually an apple. That is a reinforced response. So that's how reinforcement learning works. It learns from its mistakes and experiences. This model is used in games like Prince of Persia or Assassin's Creed or FIFA, wherein the level of difficulty increases as you get better with the games. Just to make it more clear for you, let's look at a comparison between supervised and unsupervised learning. Firstly, the data involved in case of supervised learning is labeled. As we mentioned in the examples previously, we provide the system with a photo of an apple and let the system know that this is actually an apple. That is called labeled data. So the system learns from the labeled data and makes future predictions. Now, unsupervised learning does not require any kind of labeled data because its work is to look for patterns in the input data and organize it. The next point is that you get a feedback in case of supervised learning. That is, once you get the output, the system tends to remember that and uses it for the next operation. That does not happen for unsupervised learning. And the last point is that supervised learning is mostly used to predict data, whereas unsupervised learning is used to find out hidden patterns or structures in data. I think this would have made a lot of things clear for you regarding supervised and unsupervised learning.
Hey everyone, in this video we'll be talking about NLP in the next 10 minutes. So what can you expect from this video? What's in it for you? First, we'll give you a basic understanding of NLP. We'll tell you why we need NLP and we'll talk about what NLP exactly is. Next, we'll look at NLP pipelines. NLP pipelines cover the basic processes involved in text parsing in NLP, which means converting text to a form suitable for machines to understand as humans would understand it. And finally, we'll talk about some real-world applications of NLP which are all around us and a lot more common than you might have realized. So, let's get started. So what exactly is NLP? Before we talk about NLP, let's talk about how humans talk and interact with each other. Humans communicate with each other mostly via speech or text. To convey your intent to someone, you may directly talk to them or send them a message. The human way of communicating is known as natural language. Around the globe, many languages are spoken and messages are shared virtually every single day. All these conversations, feedbacks, and messages are data in themselves. This data is extremely valuable as it can give us customer information and insight into human sentiment. However, this data is not useful to computers as it is not in a form that can be understood by machines. Machines communicate using ones and zeros and not via words. They cannot understand English, French, or Spanish, only binary. And this is where NLP comes into the picture. NLP stands for Natural Language Processing. Natural language processing is a branch of artificial intelligence that deals with the interactions between humans and computers using the natural language. The ultimate objective of NLP is to read, decipher, understand, and make sense of human languages in a manner that is valuable, and to build systems that can make sense of text and perform tasks like translation, grammar checking, or topic classification. NLP basically is the task of processing written forms of languages and making a computer understand them. Companies are increasingly using NLP-equipped tools to gain insights from data and to automate routine tasks. A sentiment analyzer, for instance, can help brands detect emotions in text, such as negative comments on social media. NLP at the end of the day is nothing more than a accumulation of artificial intelligence, computer science, and the human language. The next topic that we'll be looking at are NLP pipelines. So what exactly are pipelines? A pipeline is a set of data processing elements which are connected in series, where the output of one element is the input of the next one. It basically represents the various steps which have to be taken in a computation and the order in which they occur. In this pipeline, we are going to be parsing our data. Parsing means converting our data from one form to another. In this case, we are parsing our input text data to a file which can be understood by a computer. The text is first broken into segments, and the segments are then converted into even smaller tokens. The word stems of all of these tokens are found, followed by finding the root words of these stems in a process known as lemmatization. We will then recognize which part of speech the word belongs to, which means if the word is a verb, a noun, or a pronoun. And finally, we will separate the instances of everyday popular entities from our words to better understand what the sentence is trying to convey. The final file that we'll get will be a file which will be understood by a computer. Segmentation. The first process of a pipeline is segmentation. Now, what exactly is segmentation? Sentence segmentation or text segmentation is basically dividing the given text into logically decipherable units of information. We divide the sentence into its constituent sub-sentences, usually along the punctuations like full stops or commas, or along line breaks and page components for HTML files. Dividing a document into its constituent sentences allows us to process it without losing its essence and the necessary information that it contains. In this case, let's consider a sentence, "The lemonade quenched her thirst but not her longing." After sentence segmentation, we are going to divide the sentence into two. The first sentence is going to be "The lemonade quenched her thirst," and the second one is going to be "but not her longing." The next step of our pipeline is called tokenization. Tokenization is nothing but the process of dividing a sentence into its constituent words. The sentence that is given to us will be separated and all the words in the sentence will be stored separately. This is done so we can understand the syntactic and semantic information contained in each sentence. Thus, we decipher the relevance of a sentence by analyzing it word by word, thereby making sure that no loss of information occurs. The computer does not understand punctuations and special characters, hence we can remove any punctuations and special characters which may occur. Let's take a part of our previously segmented sentence. Over here, let's consider the lemonade quenched her thirst. After tokenization, we are going to separate every single word in this sentence. So, after tokenization, we are going to get 5 different tokens: the, lemonade, quenched, her, and thirst. All of these are going to be treated as separate entities. After tokenization, we perform stemming. Stemming is a process of obtaining the word stems of a word. Word stems are also known as the base form of a word, and we can create new words by attaching affixes to them in a process known as inflection. Stemming is a process of recognizing the word stems of individual words. This is done by removing affixes such as ing, s, ed, etc. For example, consider our sentence jump. Jump is the word stem of various different words like jumping, jumped, and jumps. If we remove all of these affixes, we will get our basic word stem, which is jump. This is basically what we want at the end of stemming. The next process in our pipeline is called lemmatization. Lemmatization is the process of figuring out the root form or root word, which is nothing but the most basic form, also known as the lemma, of each word in the sentence. Lemmatization is very similar to stemming, where we remove word affixes to get the base form of a word. The difference is that the root word is always a word which is present in the dictionary, but the root stem may not be so. Lemmatization uses a knowledge base called WordNet. Let's consider 3 different words: went, going, and gone. At the end of the day, all of these words have originated from a single word, which is go. In this case, go is our lemma. All the other words which are derived from go can be traced back to it. The next part of our pipeline is called part of speech tagging. Part of speech tagging is a process of converting a sentence to different forms. It can be a list of words or a list of tuples. The tag in case of is a part of speech tag and signifies whether the word is a noun, adjective, verb, and so on. We are basically splitting our verbs into their grammatical components. To understand the meaning of any sentence or to extract relationships and to build a knowledge graph, part of speech tagging is a very important step, as the same word can have different part of speeches in different sentences. For example, let's consider the sentence, give me your answer. In this sentence, answer is a noun, but if we consider another sentence, answer the question, over here answer will be a verb. Using part of speech tagging, we can take our different tokens and find the different part of speech that it belongs to. In this case, the is a determiner, lemonade is a noun, quenched is a verb, her is a pronoun, and thirst is a noun. The final step in our NLP pipeline that we are looking at here is nothing but named entity recognition. Named entity recognition, also known as named entity identification, entity chunking, and entity extraction, is a subtask of information extraction that seeks to locate and classify named entities which are mentioned in unstructured text into predefined categories. Extracting the main entities in a text helps us sort unstructured data and detect important information, which is crucial if you have to deal with large data sets. The subcategories that we are considering are person, whether the named entity is a person, whether it's a quantity like kilograms, a location, an organization, the name of a movie, or whether it's a monetary value like dollars or euros. So far, we've looked at what NLP is and how we can perform natural language processing. But what are some applications of it and where is it used in the real world? One of the applications of NLP is in chatbots. Chatbots can help you solve issues while performing natural language generation. In other words, they can hold a conversation in plain English. A chatbot is nothing but a software application which can be used to conduct an online chat conversation. either through text or speech, in place of providing direct contact with a live human agent. You might have seen those "talk to one of our agents" section on websites. Those are usually chatbots. A lot of companies also use WhatsApp chatbots to make the process seem less mechanical. Another application of NLP is speech recognition. Probably the most popular example of NLP in action are virtual assistants like Google Assist, Siri, and Alexa. Natural language processing understands and translates the human language, like "Hey Siri, where is the nearest gas station?" into numbers, making it easy for machines to understand. They recognize when you are talking, converting speech to text, and understand what you requested. Over the years, virtual assistants have become streamlined enough to be able to emulate human speech patterns almost flawlessly. Another application of NLP is autocorrection. Autocorrection, also known as text replacement, replace as you type, or simply autocorrect, is an automatic data validation function commonly found in word processors and text editing interfaces for smartphones and tablet computers. It acts as a spell check and corrects any spellings or grammar mistakes which may arise as you are typing. Some language check softwares like Grammarly, Paperator, Reverso, and others can even check how unique and engaging your articles are. And all of this is done using NLP.
Hello everyone, welcome to this video on the Natural Language Processing Engineer NLP Engineer Roadmap by Simplilearn. To stay updated with our content, make sure to subscribe to our YouTube channel and hit the bell icon. So in this video, we will begin by examining the role of NLP engineer. Progressing further, our focus will shift toward the essential knowledge and skills required to excel as an NLP engineer. Having comprehensively explored these subjects, we will then proceed to explore the intricacies and constructing of a professional career roadmap tailored specifically for individuals aspiring to become accomplished NLP engineers. On that note, if you are an aspiring AI/ML engineer, then there is no better time to train yourself in the exciting field of machine learning. If you are looking for a course that covers everything from the fundamentals to advanced techniques like machine learning algorithm development and unsupervised learning, look no further than our Caltech program partnership with IBM. This AI/ML bootcamp in collaboration with Caltech will help you advance your career as AI/ML specialist. The AI/ML bootcamp includes live classes delivered by industry expert, hands-on lab, industry-relevant projects, and masterclasses by Caltech professor. Key features of this amazing machine learning course includes earn up to 22 CUs from Caltech CTME, online convocation by Caltech CTME program director. Simplilearn Career Service helps you get noticed by top hiring companies, earn a bootcamp certificate from Caltech CTME. Industry-relevant project in 3 domains, Caltech CTME Circle membership, 25 plus hands-on project across industry verticals with integrated labs. So why wait? Join now. Seats are filling fast. Find the course link from the description box below. So without any further ado, let's get started. So what is NLP engineer? A natural language processing NLP engineer is a professional responsible for crafting and constructing computer systems that can process, assess, and produce human-like language. NLP branches out into numerous captivating domains including semantic analysis, sentiment analysis, face recognition, machine translation, and speech recognition. The reach of NLP extends across a diverse spectrum of application, notably featuring virtual assistant, chatbots, sentiment analysis, customer service interaction, and language translation. The task of NLP engineer involves erecting these innovative applications and seemingly embedding them into the existing framework. The average salary for NLP engineer in India is 10 lakh per year, and in the US, average annual salary for NLP engineer is $120,000. So moving forward, let's see skills required as an NLP engineer. So becoming an NLP engineer entails the acquisition of a diverse set of application and knowledge. Some of these encompasses: first one is proficiency in programming. Mastery of at least one programming language such as Python, Java, or C++, coupled with a solid grasp of data structure, algorithm, and principle of software engineering. The second one is grasp of machine learning. Building a strong foundation in machine learning algorithm encompassing both supervised and unsupervised learning. Familiarity with advanced techniques like CNN and RNN is vital. The third one is NLP techniques. Cultivating a deep understanding of NLP techniques, which encompasses facets like text preprocessing, syntactic and semantic analysis, and the intricate domain of sentiment analysis. The fourth one is NLP libraries and frameworks. Navigate easily through NLP libraries and frameworks such as Natural Language Toolkit,
NLTK, SPECI, stand for Core NLP, and GenSim, harnessing their capabilities to streamline your NLP endeavors. The fifth one is data science acumen, developing a sound grasp of data science principles encompassing facets such as data visualization, statistical analysis, and the art of data manipulation. Armed with these multifaceted skill set, you will be primed to embark on a journey as an accomplished NLP engineer, ready to navigate the complexity of natural language processing and contribute to the exciting world of NLP innovation. Moving forward, let's see the professional NLP engineer roadmap. Here is a comprehensive professional trajectory for those aspiring to become NLP engineers. The first one is Educational Foundation. Embark on your journey by pursuing a degree in pertinent fields such as computer science, linguistics, or artificial intelligence. Many accomplished NLP engineers hold advanced degrees, either a master or PhD in these domains. The second one is Internship or Entry-Level Ventures. Considering immersing yourself in practical experience through internship or entry-level job within the industry. These opportunities not only equip with the hands-on expertise but also aid in constructing a robust portfolio. The third one on the list is skills and knowledge acquisition. Develop a comprehensive grasp of essential proficiency requests of NLP engineer. This encompasses programming processes and machine learning and NLP techniques and data science. The fourth one is portfolio development. Curate a diverse portfolio teaming with projects that illuminate your capabilities and expertise. Projects like sophisticated chatbot, a sentiment analysis tool, or a language model can sustain your aptitude for solving real-world NLP challenges and validate your skill set for potential employers. The fifth one is networking endeavors. Engage in conference, meetups, and industries events to forge connection with fellow NLP professionals. The sixth one is specialization consideration. Ponder the prospect of specialization in a specific NLP realm, be it machine translation, speech recognition, or conversational agents. This specialization not only differentiates you in the job market but also enables you to attain expertise within a particular niche. In summation, the path toward becoming an NLP engineer entails a fusion of educational attainment, hands-on experience, and the mastery of electric array of skills and knowledge domains.
Hello everyone and welcome to this new video on NLP engineer salary. With the world advancing towards a more informed and database, future learning skills that help us to be relevant in the job market is crucial. One such skill in the field of data and AI is natural language processing. Let us start by understanding what NLP is. Natural language processing, or NLP, is a branch of artificial intelligence, or AI, that deals with understanding and manipulating human language. It seeks to develop algorithms and systems that can understand and process both structured and unstructured language data to support decision-making processes. NLP is a field that has been gaining momentum in recent years thanks to advance in machine learning algorithms and the availability. So before we move ahead, consider subscribing to Simplilearn and hit the bell icon to never miss any updates from us. So let's move ahead by knowing what does NLP include. At its core, NLP involves a series of steps. Number one is preprocessing. The first step in NLP is to prepare the language data for analysis. This involves activities such as cleaning, tokenization, and normalization of the text data. Step 2 involves feature extraction. The next step is to extract relevant features from the prepared data. This involves identifying keywords, stems, and parts of speech tags that are important for the task at hand. Step 3 involves model training. The extracted features are then used to train a machine learning model such as neural networks or a support vector machine to predict the target variable. And the last step is model evaluation. Once the model is trained, it needs to be evaluated to ensure it performs well on new data. Now let's move ahead by knowing NLP job roles and responsibilities. Several job roles that involves NLP and each role is focused on different aspects of NLP. Here are some most common NLP job roles. The number one is NLP engineer. This role involves developing and implementing NLP solutions, including building machine learning models, designing pipelines, and developing APIs. NLP engineers typically have a background in engineering or computer science and have knowledge of machine learning algorithms, software development, and data structures. The next we have is text analytics specialist. This role involves analyzing large amount of text data to extract useful information. Text analytics specialists typically have a background in data analysis, statistics, and machine learning, and they use NLP tools and techniques to process and analyze text data. Language model engineer. This role involves developing and improving natural language processing models such as language models and machine translation models. Language model engineers typically have a background in computer science, machine learning, and natural language processing. On number 4, we have NLP researcher. This role involves conducting research into new NLP methods and techniques. NLP researchers typically have a background in computer science, machine learning, and natural language processing, and they publish their research in various academic journals and conferences. And the most awaited, let's start with salary of NLP engineers. Let us now discuss the salary of NLP engineers in India and USA. For the sake of better understanding, we will split up the salary ranges based on the experience level of a professional. So let's start with entry-level NLP engineers. In India, the salary ranges from 2.5 million rupees to 5 million rupees. However, in US, the salary ranges between $60,000 to $90,000 per year. Entry-level NLP engineers typically have background in computer science, engineering, or a related field and have some experience with NLP, but may not have yet worked on large-scale enterprise projects. Moving towards mid-level NLP engineers. These engineers earn 5 million to 8 million rupees per year. However, in United States, they earn between $90,000 to $120,000 per year. Mid-level NLP engineers have few years of experience working on NLP projects and are typically comfortable working on both technical and business-related aspects of NLP projects. They may have some leadership responsibilities and are often responsible for ensuring that NLP projects are completed on time and to spec. Next, we have senior level NLP engineers. These engineers earn up to 8 million rupees to 15 million rupees in India per year. However, in United States, they earn between $120,000 to $165,000 per year. Senior level NLP engineers have extensive experience working on enterprise level NLP projects and are often considered authorities in NLP technologies, methods, and tools. They may serve as subject matter experts, lead teams of engineers and other NLP professionals, and be responsible for ensuring the long-term success of NLP projects.
Human versus artificial intelligence. Humans are amazing. Let's just face it. We're amazing creatures. We're all over the planet. We're exploring every niche and nook. We've gone to the moon. We've gone into outer space. We're just amazing creatures. We're able to use the available information to make decisions, to communicate with other people, identify patterns in data, remember what people have said, adapt to new situations. So let's take a look at this. So you can get a picture. You're a human being, so you know what it's like to be human. Let's take a look at artificial intelligence versus the human. Artificial intelligence develops computer systems that can accomplish tasks that require human intelligence. So when we're looking at this, one of the things that computers can do is they can provide more accurate results. This is very important. Recently I did a project on cancer where I was identifying markers. And as a human being, you look at that and you might be looking at all the different images and the data that comes off of them and say, I like this person, so I want to give them a very good outlook. And the next person you might not like, so you want to give them a bad outlook. Well, with artificial intelligence, you're going to get a consistent prediction of what's going to come out. Interacts with humans using their natural language. We've seen that as probably the biggest development feature right now that's in the commercial market that everybody gets to use, as we saw with the example of Alexa. They learn from their mistakes and adapt to new environments. So we see this slowly coming in more and more. And they learn from the data and automate repetitive learning. Repetitive learning has a lot to do with the neural networks. You have to program thousands upon thousands of pictures in there, and it's all automated. So as today's computers evolve, it's very quick and easy and affordable to do this. What is machine learning and deep learning all about? Imagine this. Say you had some time to waste. Not that any of us really have a lot of time anymore to just waste in today's world. And you're sitting by the road, and you have a whole lot of time passes by. There's a few hours, and suddenly you wonder, how many cars, buses, trucks, and so on passed by in the 6 hours. Now, chances are you're not going to sit by the road for 6 hours and count buses, cars, and trucks unless you're working for the city and you're trying to do city planning and you want to know, hey, do we need to add a new truck route? Maybe we need a bicycle lane because we have a lot of bicyclists here, that kind of thing. So maybe city planning would be great for this. Machine learning. Well, the way machine learning works is we have labeled data with features. Okay, so you have a truck or a car, a motorcycle, a bus, or a bicycle, and each one of those are labeled. It comes in, and based on those labels and comparing those features, it gives you an answer. It's a bicycle, it's a truck, it's a motorcycle. Let's look a little bit more in depth on this. In the model here, the features we're looking at would be like the tires. Someone sits there and figures out what a tire looks like. It takes a lot of work. If you try to figure the difference between a car tire, a bicycle tire, a motorcycle tire, so in the machine learning field, this could take a long time if you're going to do each individual aspect of a car and try to get a result on there. And that's what they did do. That was this is still used on smaller amounts of data where you figure out what those features are and then you label them. Deep learning. So with deep learning, one of our solutions is to take a very large unlabeled data set and we put that into a training model using artificial neural networks. And then that goes into the neural network itself when we create a neural network. And you'll see the arrows are actually kind of backward, but which actually is a nice point because when we train the neural network, we put the bicycle in and then it comes back and says, if it said truck, it comes back and says, well, you need to change that to bicycle. And then it changes all those weights going backward, they call it back propagation, and let it know it's a bicycle, and that's how it learns. Once you've trained the neural network, you then put the new data in, and they call this testing the model, so you need to have some data you've kept off to the side where you know the answer to. And you take that and you provide the required output, and you say, okay, is this neural network working correctly? Did it identify a bike as a bike, a truck as a truck, a motorcycle as a motorcycle? Let's just take a little closer look at that. Determining what objects are present in the data. So how does deep learning do this? And here we have the image of the bike. It's 28 by 28 pixels. That's a lot of information there. Could you imagine trying to guess that this is a bicycle image by looking at each one of those pixels and trying to figure out what's around it? And we actually do that as human beings. It's pretty amazing. We know what a bicycle is, and even though it comes in as all this information. And what this looks like is the image comes in, it converts it into a bunch of different nodes. In this case, there's a lot more than what they show here. And it goes through these different layers and out comes and says, okay, this is a bicycle. A lot of times they call this the magic black box. Why? Because as we watch it go across here, all these weights and all the math behind this, and it's a little complicated on the math side. You really don't need to know that when you're programming or working with the deep learning. But it's like magic. You don't know, you really can't figure out what's going to come out by looking what's in each one of those dots and each one of those lines are firing and what's going in between them. So we like to call it the magic box. So that's where deep learning comes in. And in the end, it comes up and you have this whole neural network that comes up and it says, okay, we fire all these different pixels and we connects all these different dots and gives them different weights and it says, okay, this is a bicycle. And that's how we determine what the object is present in the data with deep learning. Machine learning. We're going to take a step into machine learning here, and you'll see how these fit together in a minute. The system is able to make predictions or take decisions based on past data. That's very important for machine learning, is that we're looking at stuff, and based on what's been there before, we're creating a decision on there. We're creating something out of there. We're coloring a beach ball. We're telling you what the weather is in Chicago. What's nice about machine learning is a very powerful processing capability. It's quick and accurate outcomes, so you get results right away. Once you program the system, the results are very fast. And the decisions and predictions are better. They're more accurate, they're consistent. You can analyze very large amounts of data. Some of these data things that they're analyzing now are petabytes and terabytes of data. It would take hundreds of people hundreds of years to go through some of this data and do the same thing that the machine learning can do in a very short period of time. And it's inexpensive compared to hiring hundreds of people. So it becomes a very affordable way to move into the future is to apply the machine learning to whatever businesses you're working on. And deep learning. Systems think and learn like humans using artificial neural networks. Again, it's like a magic box. Performance improves with more data. So the more data the deep learning gets, the more it gives you better results. It's scalability. So you can scale it up, you can scale it down, you can increase what you're looking at. Currently, we're limited by the amount of computer processing power as to how big that can get, but that envelope continually gets pushed every day on what it can do. Problem solved in an end-to-end method. So instead of having to break it apart, and you have the first piece coming in and you identify tires, and the second piece is identifying labeling handlebars, and then you bring that together that if it has handlebars and tires, it's a bicycle, and if it has something that looks like a large square, it's probably a truck. The neural networks does this all in one network. You don't really know what's going on in all those weights and all those little bubbles, but it does it pretty much in one package. That's why the neural network systems are so big nowadays and coming into their own. Best features are selected by the system, and this is important. They kind of put it's on a bullet on the side here. It's a subset of machine learning. This is important. When we talk about deep learning, it is a form of machine learning. There's lots of other forms of machine learning, data analysis, but this is the newest and biggest thing that they apply to a lot of different packages, and they use all the other machine learning tools available to work with it. And it's very fast to test. You put in your information, you then have your group of test, and then you held some aside, you see how does it do. It's very quick to test it and see what's going on with your deep learning and your neural network. Are they really all that different? AI versus machine learning versus deep learning. Concepts of AI. So we have concepts of AI. You'll see natural language processing, machine learning, an approach to create artificial intelligence. So it's one of the subsets of artificial intelligence. Knowledge representation, automated reasoning, computer vision, robotics. Machine learning versus AI versus deep learning, or AI and machine learning and deep learning. So when we look at this, we have AI with machine learning and deep learning. And so we're going to put them all together. We find out that AI is the big picture. We have a collection of books. It goes through some deep learning. The digital data is analyzed. Text mining comes through. The particular book you're looking for, maybe it's a genre of books, is identified. And in this case, we have a robot that goes and gives a book to the patron. I have yet to be at a library that has a robot bring me a book, but that will be cool when it happens. So we'll look at some of the pieces here. This information goes into, as far as this example, the translation of the handwritten printed data to digital form. That's pretty hard to do. That's pretty hard to go in there and translate hundreds and hundreds of books and understand what they're trying to say if you've never read them. So in this case, we used a deep learning because you can already use examples where they've already classified a lot of books, and then they can compare those texts and say, oh, okay, this is a book on automotive repair. This is a book on robotic building. The digital data is then analyzed. Then we have more text mining using machine learning. So maybe we'd use a different program to do a basic classify what you're looking for and say, oh, you're looking for auto repair and computers. So you're looking for automated cars. Once it's identified, then of course it brings you the book. So here's a nice summation of what we were just talking about. AI with machine learning and deep learning. Deep learning is a subset of machine learning, which is a subset of artificial intelligence. So you can look at artificial intelligence as the big picture. How does this compare to the human experience in either doing the same thing as a human we do, or it does it better than us? And machine learning, which has a lot of tools, is something that learns from data, past experiences. It's programmed. It comes in there and it says, hey, we already had these 5 things happen. The 6th one should be about the same. And then there's a lot of tools in machine learning, but deep learning then is a very specific tool in machine learning. It's the artificial neural network, which handles large amounts of data and is able to take huge pools of experiences, pictures, and ideas and bring them together. Real life examples. Artificial intelligence, news generation. Very common nowadays as it goes through there and finds the news articles or generates the news based upon the news feeds or the backend coming in and says, okay, let's give you the actual news based on this. There's all the different things. Amazon Echo, they have a number of different Prime Music on there. Of course, there's also the Google Command, and there's also Cortana. There's tons of smart home devices now where we can ask it to turn the TV on or play music for us. That's all artificial intelligence. From front to back, you're having a human experience with these computers and these objects that are connected to the processing. Machine learning, spam detection, very common. Machine learning doesn't really have the human interaction part. So this is the part where it goes and says, okay, that's a spam, that's not a spam, and it puts it in your spam folder. Search engine result refining, another example of machine learning, whereas it looks at your different results and it is able to categorize them as far as this had the most hits, this is the least viewed, this has 5 stars, however they want to weight it. All good examples of machine learning. And then the deep learning. Deep learning, another example is as you have like a exit sign, in this case is translating it into French, sortie. I hope I said that right. The neural network has been programmed with all these different words and images, and so it's able to look at the exit in the middle, and it goes, okay, we want to know what that is in French, and it's able to push that out in French, and learn how to do that. And then we have chatbots. I remember when Microsoft first had their little paperclip. Boy, that was like a long time ago. They came up and you would type in there and chat with it. These are growing. It's nice to just be able to ask a question and it comes up and gives you the answer. And instead of it being where you're just doing a search on certain words, it's now able to start linking those words together and form a sentence in that chat box. Types of AI and machine learning. Types of artificial intelligence. This and the next few slides are really important. So one of the types of artificial intelligence is reactive machines. Systems that only react. They don't form memories, they don't have past experiences, they have something that happens to them and they react to it. My washing machine is one of those. If I put a ton of clothes in it and they get all clumped on one side, it automatically adds a weight to recenter it. So that my washing machine is actually a reactive machine working with whatever the load is and keeps it nice, and so when it spins it doesn't go thumping against the side. Limited memory. Another form of artificial intelligence. Systems look into the past. Information is added over a period of time and information is short-lived. When we're talking about this and you look at like a neural network that's been programmed to identify cars, it doesn't remember all those pictures. It has no memory as far as the hundreds of pictures you process through it. All it has is, this is the pattern I use to identify cars as the final output for that neural network we looked at. So when they talk about limited memory, this is what they're talking about. They're talking about, I've created this based on all these things, but I'm not going to remember any one specifically. Theory of mind. Systems being able to understand human emotions and how they affect decision making to adjust their behaviors according to their human understanding. This is important because this is our page mark. This is how we know whether it is an artificial intelligence or not. Is it interacting with humans in a way that we can understand? Without that interaction, is just an object. So when we talk about theory of mind, we really understand how it interfaces. That whole, if you're in web development, user experience would be the term I would put in there. So the theory of mind would be user experience. How is the whole UI connected together? And one of the final things is, as we get into artificial intelligence, is systems being aware of themselves, understanding their internal states, and predicting other people's feelings and act appropriately. So as artificial intelligence continues to progress, we see ones that are trying to understand, well, what makes people happy? How would they increase our happiness? How would they keep themselves from breaking down if something's broken inside? They have that self-awareness to be able to fix it. And just based on all that information, predicting which action would work the best, what would help people. If I know that you're having a cup of coffee first thing in the morning is what makes you happy, as a robot I might make you a cup of coffee every morning at the same time to help your life and help you grow. That'd be the self-awareness, is being able to know all those different things. Types of machine learning, and like I said on the last slide, this is very important. This is very important. If you decide to go in and get certified in machine learning or know more about it, these are the 3 primary types of machine learning. The first one is supervised learning. Systems are able to predict future outcome based on past data. Requires both an input and an output to be given to the model for it to be trained. So in this case, we're looking at anything where you have 100 images of a bicycle, and those 100 images are bicycle. So they're preset. Someone already looked at all 100 images and said, these are pictures of bicycles. And so the computer learns from those, and then it's given another picture, and maybe the next picture is a bicycle, and it says, oh, that resembles all these other bicycles, so it's a bicycle. And the next one's a car, and it says, it's not a bicycle. That would be supervised learning, because we had to train it. We had to supervise it. Unsupervised learning. Systems are able to identify hidden patterns from the input data provided by making the data more readable and organized. The patterns, similarities, or anomalies become more evident. You'll heard the term cluster. How do you cluster things together? Some of these things go together, some of these don't. This is unsupervised, where it can look at an image and start pulling the different pieces of the image out because they aren't the same. All the parts of the human are not the same as a fuzzy tree behind them because it's slightly out of focus, which is not the same as the beach ball. It's unsupervised because we never told it what a beach ball was, we never told it what the human was, and we never told it that those were trees. All we told it was, hey, separate this picture by things that don't match and things that do match and come together. And finally, there's reinforcement learning. Systems are given no training. It learns on the basis of the reward punishment it received for performing its last action. It helps increase the efficiency of a tool function or a program. Reinforced learning, or reinforcement learning, is kind of you give it a yes or no. Yes, you gave me the right response. No, you didn't. And then it looks at that and says, oh, okay, so based on this data coming in, what I gave you was a wrong response, so next time I'll give you a different one. Comparing machine learning and deep learning. So remember that deep learning is a subcategory of machine learning. So it's one of the many tools. And so we're grouping a ton of machine learning tools all together. Linear regression, K-Means clustering. There's all kinds of cool tools out there you can use in machine learning. Enables machines to make decisions on their own based on past data. Enables machines to make decisions with the help of artificial neural networks. So it's doing the same thing, but we're using an artificial neural network as opposed to one of the more traditional machine learning tools. Needs only a small amount of training data. This is very important. When you're talking about machine learning, they're usually not talking about huge amounts of data. We're talking about maybe your spreadsheet from your business and your totals for the end of the year. When you're talking about neural networks, you usually need a large amount of data to train the data. So there's a lot of training involved. If you have under 500 points of data, that's probably not going to go into machine learning. Or maybe you have, like in the case of one of the things, 500 points of data and 30 different fields. It starts getting really confusing there in artificial intelligence or machine learning, and the deep learning aspect really shines when you get to that larger data that's really complex. Works well on a low-end systems. So a lot of the machine learning tools out there you can run on your laptop with no problem and do the calculations there. Where with the machine learning, you usually needs a higher end system to work. It takes a lot more processing power to build those neural networks and to train them. It goes through a lot of data. We're talking about the general machine learning tools. Most features need to be identified in advance and manually coded. So there's a lot of human work on here. The machine learns the features from the data it is provided. So again, it's like a magic box. You don't have to know what a tire is. It figures it out for you. The problem is divided into parts and solved individually and then combined. So machine learning, you usually have all these different tools and you use different tools for different parts. And the problem is solved in an end-to-end manner. So you only have one neural network or two neural networks that is bringing the data in and putting it out. It's not going through a lot of different processes to get there. And remember, you can put machine learning and deep learning together. So you don't always have just the deep learning solving the problem. You might have it solving one piece of the puzzle. With regular machine learning and most of the machine learning tools out there, they take longer to test and understand how they work. And with the deep learning, it's pretty quick. Once you build that neural network, you test it and you know. So we're dealing with very crisp rules, limited resources. You have to really explain how the decision was made when you use most machine learning tools. But when you use the deep learning tool inside the machine learning tools, the system takes care of it based on its own logic and reasoning. And again, it's like a magic black box. You really don't know how it came up with the answer. You just know it came up with the right answer. A glimpse into the future. So a quick glimpse into the future, artificial intelligence, be using it to detecting crimes before they happen, humanoid AI helpers, which we already have a lot of. There'll be more and more. Maybe it'll actually be androids. That'd be cool to have an android that comes and gets stuff out of my fridge for me. Machine learning, increasing efficiency in healthcare. That's really big in all the forms of machine learning. Better marketing techniques. Any of these things, if we get into the sciences, it's just off the scale. Machine learning and artificial intelligence go everywhere. And then the subcategory deep learning, increased personalization. So what's really nice about the deep learning is it's going to start now catering to you. That'll be one of the things we see more and more of. And we'll have more of a hyper-intelligent personal assistant. I'm excited about that.
In this lesson, you are going to understand the concept of text mining. By the end of this lesson, you will be able to explain text mining, execute text processing tasks. So let's go ahead and understand text mining in detail. Let's first understand what text mining is. Text mining is the technique of exploring large amounts of unstructured text data and analyzing it in order to extract patterns from the text data. It is aided by software that can identify concepts, patterns, topics, keywords, and other attributes in the data. It utilizes computational techniques to extract and summarize the high-quality information from unstructured textual resources. Let's understand the flow of text mining. There are 5 techniques used in text mining system. Information extraction or text preprocessing. This is used to examine the unstructured text by searching out the important words and finding the relationships between them. Categorization or text transformation attribute generation. Categorization technique labels the text document under one or more categories. Classification of text data is done based on input-output examples with categorization. Clustering or attribute selection. Clustering method is used to group text documents that have similar content. Clusters are the partitions, and each cluster will have a number of documents with similar content. Clustering makes sure that no document will be omitted from the search, and it derives all the documents that have similar content. Visualization technique. The process of finding relevant information is simplified by visualization technique. This technique uses text flags to represent a group of documents or a single document, and compactness is indicated using colors. Visualization technique helps to display textual information in a more attractive way. Summarization or interpretation or evaluation. Summarization technique will help to reduce the length of the document and summarize the details of the documents. It makes the document easy to read for users and understand the content at the moment. Let's understand the significance of text mining. Document clustering. Document clustering is an important part of text mining. It has many applications in knowledge management and information retrieval. Clustering makes it easy to group similar documents into meaningful groups, such as in newspapers where sections are often grouped as business, sports, politics, and so on. Pattern identification. Text mining is the process of automatically searching large amount of text for text patterns and recognition of features. Features such as telephone numbers and email addresses can be extracted using pattern matches. Product insights. Text mining helps to extract large amounts of text, for example, customer reviews about the products. Mining consumer reviews can reveal insights like most loved feature, most hated feature, improvements required, and reviews of competitors' products. Security monitoring. Text mining helps in monitoring and extracting information from news articles and reports for national security purposes. Text mining makes sure to use all of your available information. It is a more effective and productive knowledge discovery that allows you to make better informed decisions, automate information-intensive processes, gather business-critical insights, and mitigate operational risk. Let's look at the applications of text mining. Speech recognition. Speech recognition is the recognition and translation of spoken language into text and vice versa. Speech often provides valuable information about the topics, subjects, and concepts of multimedia content. Information extraction from speech is less complicated, yet more accurate and precise than multimedia content. This fact motivates content-based speech analysis for multimedia data mining and retrieval, where audio and speech processing is a key enabling technology. Spam filtering. Spam detection is an important method in which textual information contained in an email is extracted and used for discrimination. Text mining is useful in automatic detection of spam emails based on the filtering content. Using text mining, an email service provider such as Gmail or Yahoo Mail checks the content of an email, and if some malicious text is found in the mail, then that email is marked as spam and sent to the spam folder. Sentiment analysis. It is done in order to determine if a given sentence expresses positive, neutral, or negative sentiments. Sentiment analysis is one of the most popular applications of text analytics. The primary aspect of sentiment analysis includes data analysis of the body of the text for understanding the opinion expressed by it and other key factors comprising modality and mood. Usually, the process of sentiment analysis works best on text that has a subjective context than on that with only an objective context. E-commerce personalization. Text mining is used to suggest products that fit into a user's profile. Text mining is increasingly being used by e-commerce retailers to learn more about the consumers, as it is the process of analyzing textual information in order to identify patterns and gain insights. E-commerce retailers can target specific individuals or segments with personalized offers and discounts to boost sales and increase customer loyalty by identifying customer purchase patterns and opinions on particular products. Let's look at Natural Language Toolkit library in detail. Natural Language Toolkit is a set of open-source Python models that are used to apply statistical natural language processing on human language data. Let's see how you can do environment setup of NLTK. Go to Windows Start and launch Python Interpreter from Anaconda prompt and enter the following commands. Enter command Python to check the version of Python installed on your system. Enter import NLTK to link you to the NLTK library available to download. Then enter NLTK.download function that will open the NLTK download window. Check the download directory, select all packages, and click on Download. This will download NLTK onto your Python. Once you have downloaded the NLTK, you must check the working and functionality of it. In order to test the setup, enter the following command in Python idle. From nltk.corpus import brown.word parenthesis. The brown is an NLTK corpus that shows the systematic difference between different genres available. Words function will give you the list available words in the genre. The given output shows that we have successfully tested the NLTK installed on Python. Let's now understand how you can read a specific module from NLTK corpora. If you want to import an entire module from NLTK corpora, use asterisk symbol with that module name import command. Enter the command from nltk.book_import asterisk. It will load all the items available in NLTK's book module. Now, in order to explore brown corpus, enter the command nltk.corpus import brown. This will import brown corpus on the Python. Enter brown.categories function to load the different genres available. Select a genre and assign that genre to a variable using the following syntax. Variable name is equal to brown.words. Categories is equal to genre name. Now, in order to see the available words inside the selected genre, just enter the defined variable name as a command. Let's understand text extraction and preprocessing in detail. So let's first understand the concept of tokenization. Tokenization is the process of removing sensitive data and placing unique symbols of identification in that place in order to retain all the essential information concerned with the data by its security. It is a process of breaking running streams of text into words and sentences. It works by segregating words using punctuation and spaces. Text extraction and preprocessing engrams. Now let's look at what engram is and how it is helpful in text mining. Engram is the simplest model that assigns these probabilities to sequences of words or sentences. Engrams are combinations of adjacent words or letters of length n in the source text. So engram is very helpful in text mining when it is required to extract patterns from the text. As in the given example, this is a sentence. All of these words are considered individual words and thus represent unigrams. A 2-gram or bigram is a two-word sequence of words like this is a, or a sentence, and a 3-gram or trigram is a three-word sequence of words like this is a, or is a sentence. Let's now understand what stop words are and how you can remove them. Stop words are natural language words that have negligible meaning, such as a, an, and, or, the, and other similar words. These words also will take up space in the database or increase the processing time, so it is better to remove such words by storing a list of stop words. You can find the list of stop words in the NLTK data directory that is stored in 16 different languages. Use the following command to list the stop words of English language defined in NLTK corpus. Importing NLTK will import the NLTK corpus for that instance. Enter from nltk.corpus import. Stop words will import stop words from NLTK corpus. Now set the language as English, so use set function as set under braces stop words dot words. Set genre as English. Stop words are filtered out before processing of natural language data, as they don't reveal much information. So as you can see in the given example, before filtering the sentence, the tokenization of stop word is processed in order to remove these stop words, and the filtering is applied in order to filter the sentence based on some criteria. Text extraction and preprocessing stemming. Stemming is used to reduce a word to stem or base word by removing suffixes such as helps, helping, helped, and helper to the root word help. The stemming process or algorithm is generally called a stemmer. There are various stemming algorithms such as Porter stemmer, Lancaster stemmer, Snowball stemmer, etc. Use any of the stemmers defined under NLTK stem corpus in order to perform stemming as shown in the example. Here we have used Porter stemmer. When you observe the output, you will see that all of the words given have been reduced to their root word or stem. Text extraction and preprocessing lemmatization. Lemmatization is the method of grouping the various inflected types of a word in order that they can be analyzed as one item. It uses vocabulary list or a morphological analysis to get the root word. It uses WordNet database that has English words linked together by their semantic relationship. As you can observe, the given example, the different words have been extracted to their relevant morphological word using lemmatization. Text extraction and preprocessing POS tagging. Let's now look at different part-of-speech tags available in the National Language Toolkit library. A POS tag is a special label assigned to each token or word in a text corpus to indicate the part of speech and often also other grammatical categories such as tense, number either plural or singular, case, etc. POS tags are used in text analysis tools and algorithms and also in corpus searches. So look at the given example. Here Alice wrote a program is the source text given. The POS tags given are Alice is a noun, wrote is a verb, a is an article, and program is an adjective. Look at the given example to understand how POS tags are defined. So the given sentence or paragraph contains different words that represent different parts of speech. We will first use tokenization and removal of stop words, and then allocate the different POS tags. These are shown with different words in the given sentence. POS tags are useful for lemmatization in building named entity recognition and extracting relationships between words. Text extraction and pre-processing named entity recognition. Now let's understand what named entity recognition is all about. NER seeks to extract a real-world entity from the text and sorts it into predefined categories, such as names of people, organizations, locations, etc. Many real-world questions can be answered with the help of name entity recognition. Were specified products mentioned in complaints or reviews? Does the tweet contain the name of a person? Does the tweet contain the person's address? As you can see in the given example, Google, America, Larry, Page, etc. are the names of a person, place, or an organization. So these are considered named entities and have different tags such as person, organization, GPE or geopolitical entity, etc. NLP process workflow. Now you have an understanding of all NLTK tools. So now let's understand the natural language processing workflow. Step 1, tokenization. It splits text into pieces, tokens, or words and removes punctuation. Step 2, stop word removal. It removes commonly used words such as the, is, are, etc., which are not relevant to the analysis. Step 3, stemming and lemmatization. It reduces words to base form in order to be analyzed as a single item. Step 4, POS tagging. It tags words to be part of speech such as noun, verb, adjective, etc. based on the definition and context. Step 5, information retrieval. It extracts relevant information from the source. Demo 1, Brown Corpus. Problem statement. The Brown University Standard Corpus of Present-Day American English, also known popularly as Brown Corpus, was compiled in the 1960s as a general corpus in the field of corpus linguistics. It contains 500 samples of English language text, totaling roughly 1 million words, compiled from works published in the United States in 1961. We will be working on one of the subset dataset and perform text processing tasks. Let us import the NLTK library and read the CA_10 corpus. Import NLTK. We will have to make sure that there are no slashes in between. Hence, we will use the replace function within pandas for the same. Let's have a look at the data once. Tokenization. After performing sentence tokenization on the data we obtain, similarly, after applying Sentence Tokenizer, the resulting output shows all individual words, tokens. Stop word removal. Let's import the stop word library. From nltk.corpus, import stop words. We also need to ensure that the text is in the same case. NLTK has its own list of stop words. We can check the list of stop words using stopwords.words and English inside the parenthesis. Map the lowercase string with our list of word tokens. Let's remove the stop words using the English stop words list in NLTK. We will be using set checking as it is faster in Python than a list. By removing all stop words from the text, we obtain Often we want to remove the punctuations from the documents too. Since Python comes with batteries included, we have string.punctuation. From string, import punctuation. Combining the punctuation with the stop words from NLTK. Removing stop words with punctuation. Stemming and lemmatization. We will be using stemming and lemmatization to reduce words to their root form. For example, walks, walking, walked will be reduced to their root word walk. Importing Porter Stemmer as the stemming library. From nltk.stem, import Porter Stemmer. Printing the stem words. Import the WordNet lemmatizer from nltk.stem. Printing the root words. We also need to evaluate the POS tags for each token. Create a new word list and store the list of word tokens against each of the sentence tokens in Data 2. For I in tokenized, also, we will check if there were any stop words in the recently created word list. We will now tag the word tokens accordingly using the POS tags and print the tagged output. For our final text processing task, we will be applying named entity recognition to classify named entities in text into predefined categories such as the names of persons, organizations, locations, expressions of times, quantities, monetary values, percentages, etc. Now press the tagged sentences under the chunk parser. If we set the parameter binary equals true, then named entities are just tagged as NE. Otherwise, the classifier adds category labels such as person, organization, and GPE. Create a function named as extract entity names along with an empty list named as entity names. We will now extract named entities from a NLTK chunked expression and store them in the empty created above. Again, we will set the entity names list as an empty list and will extract the entity names by iterating over each tree in chunked sentences. Great, we have seen how to explore and examine the corpus using text processing techniques. Let's quickly recap the steps we've covered so far. 1. Import the NLTK library. 2. Perform tokenization. 3. Perform stemming and lemmatization. 4. Remove stop words. 5. Perform named entity recognition. Structuring sentences, syntax. Let's first understand what syntax is. Syntax is the grammatical structure of sentences. In the given example, this can be interpreted as syntax, and it is similar to the ones you use while writing codes. Knowing a language includes the power to construct phrases and sentences out of morphemes and words. The part of the grammar that represents a speaker's knowledge of these structures and their formation is called syntax. Phrase structure rules are rules that determine what goes into a phrase, that is, constituents of a phrase, and how the constituents are ordered. Constituent is a word or group of words that operate as a unit and can be used to frame larger grammatical units. The given diagram represents that a noun phrase is determined when a noun is combined with a determiner, and the determiner can be optional. A sentence is determined when a noun phrase is combined with a verb phrase. A verb phrase is determined when a verb is combined optionally with the noun phrase and prepositional phrase. And a prepositional phrase is determined when a preposition is combined with a noun phrase. A tree is a representation of syntactic structure of formulation of sentences or strings. Consider the given sentence. The factory employs 12.8% of Bradford County. What can be the syntax for pairing this statement? Let's understand this. A tree is produced that might help you understand that the subject of the sentence is the factory. The predicate is employs, and the target is 12.8%, which in turn is modified by Bradford County. Syntax parses are often a first step toward deep information extraction or semantic understanding of text. Rendering syntax trees. Download the corresponding .exe file to install the Ghost script rendering engine based on your system configuration in order to render syntax trees in your notebook. Let's understand how you can set up the environment variable. Once you have downloaded and installed the file, go to the folder where it is installed and copy the path of the file. Now go to System Properties, and under Advanced Properties, you will find the Environment Variable button. Click on that to open the pop-up box tab of the environment. Now open the bin folder and add the path to the bin folder in your environment variables. Now you will have to modify the path of the environment variable. Use the given code to test the working of syntax tree after the setup is successfully installed. Structuring sentences, chunking and chunk parsing. The process of extraction of phrases from unstructured text is called chunking. Instead of using just simple tokens which may not represent the actual meaning of the text, it is advisable to use phrases such as Indian team as a single word instead of Indian and team as separate words. The chunking segmentation refers to identifying tokens, and labeling refers to identifying the correct tag. These chunks correspond to mixed patterns in some way. To extract patterns from chunks, we need chunk parsing. The chunk parsing segment refers to identifying strings of tokens, and labeling refers to identifying the correct chunk type. Let's look at the given example. You can see here that yellow is an adjective, dog is a noun, and the is the determiner, which are chunked together into a noun phrase. Similarly, chunk parsing is used to extract patterns and to process such patterns from multiple chunks while using different parsers. Let's take an example and try to understand how chunking is performed in Python. Let's consider the sentence, "The little mouse ate the fresh cheese," assigned to a variable named cent. Using the word tokenize function under NLTK corpora, you can find out the different tags associated with the sentence provided. So as you can see in the output, different tags have been allocated against each of the words from the given sentence using chunking. NP chunk and parser. You will now create grammar from a noun phrase and will mention the tags you want in your chunk phrase within the function. Here you have created a regular expression matching the string. The given regular expression indicates optional determiner followed by optional number of adjective followed by a noun. You will now have to parse the chunk. Therefore, you will create a chunk parser and pass your noun phrase string to it. The parser is now ready. You will use the parse parenthesis within your chunk parser to parse your sentence. The sentence provided is, "The little mouse ate the fresh cheese." This sentence has been parsed and the tokens that match the regular expressions are chunked together into noun phrases, NP. Create a verb phrase chunk using regular expressions. The regular expression has been defined as optional personal pronoun followed by 0 or more verbs with any of its type followed by any type of adverb. You'll now create another chunk parser and pass the verb phrase string to it. Create another sentence and tokenize it. Add POS tags to it. So the new sentence is, "She is walking quickly to the mall," and the POS tag has been allocated from NLTK corpora. Now use the new verb phrase parser to parse the tokens and run the results. You can look at the given tree diagram, which shows a verb parser where a pronoun followed by two verbs and an adverb are chunked together into a verb parse. Structuring sentences, chinking. Chinking is the process of removing a sequence of tokens from a chunk. How does chunking work? The whole chunk is removed when the sequence of tokens spans an entire chunk. If the sequence is at the start or the end of the chunk, the tokens are removed from the start and end, and a smaller chunk is retained. If the sequence of tokens appears in the middle of the chunk, these tokens are removed, leaving two chunks where there was only one before. Consider you create a chinking grammar string containing three things: chunk name, the regular expression sequence of a chunk, the regular expression sequence of your chink. Here in the given code, we have the chunk regular expression as optional personal pronoun, followed by 0 or more occurrences of any type of the verb type followed by 0 or more occurrences of any of the adverb types. The chink regular expression says that it needs to check for the adverb in the extracted chunk and remove it from the chunk. Inside the chinking block with open curly braces and closing curly braces, you have created one or more adverbs. You will now create a parser from nltk.regexp parser and pass the chink grammar to it. Now use the new chink parser to parse the tokens cent3 and run the results. As you can see, the parse tree is generated. While comparing the syntax tree of the chink parser with that of the original chunk, you can see that the token is quickly, adverb, chinked out of the chunk. Let's understand how to use context-free grammar. A context-free grammar is a four-tuple sum NTRS where sum is an alphabet and each character in sum is called a terminal. NT is a set and each element in NT is called a non-terminal. R, the set of rules, is a subset of NT times the set of sum UNT. S, the start symbol, is one of the symbols in NT. A context-free grammar generates a language L capturing constituency and ordering. In CFG, the start symbol is used to derive the string. You can derive the string by repeatedly replacing a non-terminal on the right-hand side of the production until all non-terminals have been replaced by terminal symbols. Let's understand the representation of context-free grammar through an example in context-free grammar. A sentence can be represented as a noun phrase followed by a verb phrase. Noun phrase can be a determiner, nominal. A nominal can be a noun. VP represents the verb phrase. A can be called a determiner. Flight can be called a noun. Consider the string below where you have certain rules. When you look at the given context-free grammar, a sentence should have a noun phrase followed by a verb phrase. A verb phrase is a verb followed by a noun. A verb can either be saw or met. Noun phrases can either be John or Jim, and a noun can either be a dog or a cat. Check the possible list of sentences that can be generated using the rules. Use the join function to create the possible list of sentences. You can check the different rules of grammar for sentence formation using the production function. It will show you the different tags used and the defined context-free grammar for the given sentence. Demo 2. Structuring sentences. Problem statement. A company wants to perform text analysis for one of its data sets. You are provided with this data set named tweets.csv, which has tweets of 6 U.S. airlines along with their sentiments, positive, negative, and neutral. The tweets are present in the text column and sentiments in airline_sentiment column. We will be retrieving all tags starting with @ in the dataset and save the output in a file called references.txt. Let us first import the pandas library and read the tweets dataset. Extract the features, text, and airline sentiment. We will iterate through the dataset using regx, find the relevant tweets. Now we will import the itertools module. It returns efficient iterators. The result is stored in a file named references.txt. Let's extract all noun phrases and save them in a file named noun phrases for left caret airline underscore sentiment right caret review.txt. Here, left caret airline underscore sentiment right caret has 3 different values, positive, negative, and neutral, so 3 files will be created. Now we will iterate all the leaf nodes and assign them to noun phrases variable. This means that the functions in itertools operate on iterators to produce more complex iterators. Using the map function, we will get all the noun phrases from the text. Putting it into list. Creating a file name in the name of review.txt. Great, we have now seen how to explore and examine the corpus using text processing techniques.
If you're looking for a course that covers everything from the fundamentals to advanced techniques, then accelerate your career in AI and machine learning with a comprehensive postgraduate program in AI and machine learning. Boost your career with this AI and ML course delivered in collaboration with the Purdue University and IBM. Learn in-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, generative AI, prompt engineering, ChatGPT, and many more. You'll receive a prestigious certificate and Ask Me Anything sessions by IBM. With 5 capstones in different domains using real datasets, you will gain practical experience. Masterclasses by Purdue faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist help you get noticed by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more such skills. Admission to this postgraduate program in AI and machine learning requires a bachelor's degree with an average of 50% or higher marks, along with the basic understanding of programming concepts and mathematics. And candidates with 2+ years of work experience are preferred to enroll in this course. So enroll now and unlock exciting AI and machine learning opportunities. The link is mentioned in the description box below.
The term generative AI has emerged seemingly out of nowhere in recent months, with a notable surge in interest according to Google Trends even within the past year. The spike in curiosity can be attributed to the introduction of generative models such as DALL-E 2, BARD, and ChatGPT. However, what does generative AI entail? As a part of our introductory series on generative AI, this video will provide a comprehensive overview of a subject starting from the basics. The explanation will cater to all levels of familiarity, ensuring that viewers gain a better understanding of how this technology operates and its growing integration to our daily lives. Generative AI is, after all, a tool that is based on artificial intelligence. A professional who elicits to switch careers with AI by learning from the experts. Then try giving a shot Simplilearn's postgraduate program in AI and machine learning from Purdue University in collaboration with IBM. The link in the description box should navigate to the home page where you can find a complete overview of the program being offered. Take action, upskill, and get ahead. What is generative AI? Generative AI is a form of artificial intelligence possesses the capability of to generate a wide range of content including text, visual, audio, and synthetic data. The recent excitement surrounding generative AI stems from the user-friendly interfaces that allow users to effortlessly create high-quality text, graphics, and video within a second. Now moving forward, let's see how does generative AI works. Generative AI begin a prompt which can take form of text, image, video, design, audio, musical notes, or any input that AI system can process. Various AI algorithms that generate new content in response to the given prompt. This content can range from essay and problem solution to realistic, created using images or audio of a person. In the early stages of generative AI, utilizing the technology involves submitting data through an API or a complex process. Developers need to acquaint themselves with a specialized tool and writing application using programming language like Python. Some of the recent and fully operational generative AIs are Google Bard, DALL-E, OpenAI ChatGPT, Microsoft Bing, and many more. So now let's discuss ChatGPT, DALL-E, and Bard, which are the most popular generative AI interfaces. So first is DALL-E 2, which was developed using OpenAI GPT implementation in 2021. Exemplify a multimodal AI application. It has been trained on a vast dataset of images and their corresponding textual description. DALL-E is capable of establishing connection between various media forms such as vision, text, audio. It specifically links the meaning of words to visual elements. OpenAI introduced an enhanced version called DALL-E 2 in 2022, which empowers users to generate imagery in multiple styles based on their prompts. And the next one is ChatGPT. In November 2022, ChatGPT, an AI-powered chatbot built on OpenAI GPT 3.5 implementation, gained immense popularity worldwide. OpenAI enabled users to interact with and fine-tune the chatbot's text response through a chat interface with interactive feedback, unlike earlier version of GPT that was solely accessible via an API. ChatGPT brought a more interactive experience. On March 14, 2023, OpenAI released GPT-4. ChatGPT integrates the conversational history with a user making a genuine dialogue. Microsoft, impressed by the success of new ChatGPT interface, announced a substantial investment in OpenAI and integrated a version of GPT into its Bing search engine. And the next one is Bard, Google Bard. Google was also an earlier forerunner in advancing transformer AI techniques for language processing. protein analysis, and other content types. It made some of these models open source for researchers but were not made available through a public interface. In response to Microsoft integration of GPT into Bing, Google hurriedly launched a public-facing chatbot named Google Bard. Bard's debut was met by an error when the language model incorrectly claimed that the Webb telescope was the first to discover a planet in a foreign solar system. As a consequence, Google's stock price suffered a significant decline. Meanwhile, Microsoft implementation of ChatGPT and GPT-powered system also faced criticism for producing inaccurate results and displaying erratic behavior in their early iteration. So, moving forward, let's see what are the use cases of generative AI. Generative AI has broad applicability and can be employed across a wide range of use cases to generate diverse forms of content. Recent advancements like GPT have made this technology more accessible and customizable for various applications. Some notable use cases for generative AI are as follows. Chatbot implementation. Generative AI can be utilized to develop chatbots for customer service and technical support, enhancing interaction with users and providing efficient assistance. The second one is language dubbing enhancement. In the realm of movies and educational content, generative AI can contribute to improving dubbing in different languages, ensuring accurate and high quality translation. And the third one is content writing. Generative AI can assist in writing email responses, dating profiles, resumes, and term papers, offering valuable support and generating customized content tailored to specific requirements. And the fourth one is art generation. Leveraging generative AI, artists can create photorealistic artwork in various styles, enabling the exploration of new artistic expression and enhancing creativity. The fifth one is product demonstration videos. Generative AI can enhance product demonstration video, making them more engaging, visually appealing, and effective in showcasing product features and benefits. So generative AI versatility allows it to employed in many other applications, making it a valuable tool for content creation and enhancing user experience across diverse domains. So after seeing use cases of generative AI, let's see what are the benefits of generative AI. So generative AI offers extensive application across various business domains, simplifying the interpretation and comprehension of existing content while also enabling the automated creation of a new content. Developers are actively exploring ways to leverage generative AI in order to enhance the optimize existing workflows and even to reshape workflows entirely to harness the potential of technology fully. Implementing generative AI can bring numerous benefits, including automated content creation. Generative AI can automate the manual process of writing content, saving time and effort by generating text or other form of content. The next one is efficient email response. Responding to emails can be made more efficient with generative AI, reducing the effort required and improving response time. And the third one is enhanced technical support. Generative AI can improve responses to specific technical queries, providing accurate and helpful information to users or customers. And the fourth one is realistic person generation. By leveraging generative AI, it becomes possible to create realistic representation of people, enabling applications like virtual characters or avatars. And the fifth one is coherent information summarization. Generative AI can summarize complex information into a coherent narrative, distilling key points and making it easier to understand and communicate complex concepts. The implementation of generative AI offers a range of potential benefits, streamlining process and enhancing content creation in various areas of business operation. So after seeing advantages of generative AI, let's move forward and see what are the limitations of generative AI. Early implementation of generative AI serve as vivid examples highlighting the numerous limitations associated with this technology. Several challenges arise from the specific approaches employed to implement various use cases. For instance, while a summary of a complex topic may be more reader-friendly than explanation incorporating multiple supporting sources, the ease of readability comes at the expense of transparent identifying the information sources. So the first one is, when implementing or utilizing a generative AI application, it is important to consider the following limitation. I repeat, the first one is lack of source identification. Generative AI does not always provide clear identification of content source, making it difficult to trace and verify origin of the information. The second one is assessment of bias. Assessing the bias of original sources used generative AI can be challenging, as it may be difficult to determine the underlying perspective or agenda of the data utilized in the training process. The third one is difficulty in identifying inaccurate information. Generative AI can generate realistic content, making identifying inaccuracy or falsehoods within the generated output harder. And the fourth one is adaptability to a new circumstances. Understanding how to fine-tune generative AI for a new circumstances or specific context can be complex, requiring careful consideration and expertise to achieve desired result. And the fifth one is glossing over bias, prejudice, and hatred. Generative AI results may amplify or perpetuate biases, prejudices, or hateful content present in the training data, requiring vigilant scrutiny to prevent such issues. So awareness of these limitations is crucial when the implementing of utilizing generative AI, as it helps users and developers critically evaluate and mitigate potential risks and challenges associated with the technology. So, future of generative AI. Furthermore, advances in AI development platforms will contribute to the accelerated progress of research and development in the realm of generative AI. The development will encompass various domains such as text, images, videos, 3D content, drugs, supply chains, logistics, and business processes. While the current standalone tools are impressive, the true transformative impact generative AI will realize while these capabilities are seemingly integrated into the existing tools with regular use.
If you want to become an AI expert and gain handsome salary packages, look at the wide range of AI/ML courses by Simplilearn in collaboration with top universities across the globe. So, what are you waiting for? Hurry up and enroll now. Find the course link in the description box.
My name is Richard Kirschner. I'm with the Simplilearn team. What's in it for you? Well, today we're going to cover what is a neural network, what can neural networks do, how does a neural network work, types of neural networks, and then we're going to jump into a use case to classify between the photos of dogs and cats. And we'll do that on the Keras with the TensorFlow in the back, but it's a Python script, so that's always my favorite part is when we dive into the actual script. So what is a neural network? So hi guys, I heard you want to know what a neural network is. Here we have, looks like you just went shopping at a red tag sale. My robot's back. So as a matter of fact, you have been using neural network on a daily basis. In today's world, it's just amazing how much we use our new technology. We're not even aware of it. When you ask your mobile assistant to perform a search for you, like saying your Google or Siri or whoever you use, Amazon Web. Self-driving cars, so that's the newest thing coming out. They're just now trying to make those legal in different states in the US and around the world. Even in the UK, they now have self-driving cars going up and down the street. It's pretty amazing. These are all neural network driven. Computer games use it. So a lot of computer games are driven by neural networks in the back end as part of the game system and how it adjusts to the players. And it's also used in processing the map images on your phone. So every time you do a navigation someplace and it opens it up, they now use neural networks to help you find the quickest way to get there. Neural network. A neural network is a system or hardware that is designed to operate like a human brain. In today's development, this is so important to understand because we don't have anything else to compare it to. I'm sure someday in the future, the computer will redefine, or the neural network, or the AI, artificial intelligence, will redefine what these mean. But as far as we can today's world, in today's commercial development, we have to compare it to what humans do. So we want to compare how it operates to a human brain and how it solves problems like a human does. What can a neural network do? And really, we're just going to dive in deeper to what we just covered and look at other examples. So what can a neural network do? Well, let's list out the things neural networks can do for you. Translate text. Boy, we got Google Translate, and Microsoft has their own Translate. They have some really cool, they actually have an earpiece that's supposed to start translating as you talk. What a cool technology. What a cool time to live. Identify faces. Can you imagine all the uses for facial identification? In the case of our sample, or our code that we're going to look at later, we'll be identifying dogs and cats, so not quite as detailed as understanding whose face belongs to who. I'm waiting for the Google glasses to come out so I can see who's who in the identify faces as I'm walking around, have a little name tag over them. Not out there yet, but boy, we are close. We can identify the faces, and they have all kinds of technologies to bring that information back to us. Recognize speech goes along with the translate text. So now as you're talking into your assistant, it can use that to do commands commands, turn lights on, all kinds of things you can do with recognizing speech. Read handwritten text. They're starting to translate all these old text documents that they've had in storage. Instead of doing it individually where somebody's going through each text by themselves in a room, you can picture like an old Raiders of the Lost Ark theme where he's in the back, archaeologist studying the text. Now it's fed into a computer. They take a picture. They even use neural networks to take a scroll that is so messed up that they can't undo the scroll, and they x-ray it, and then they use that x-ray to translate the text off of it without ever opening the scroll. I mean, just way cool stuff they're starting to do with all this. And of course, control robots. What would be a neural network without bringing in the robots? And we have our own favorite robot in the middle who goes to our red tag cell and goes shopping for us. So, these are just a few of the wonderful things that neural networks are being applied to. It's such an infant stage technology. What a wonderful time to jump in. And there are a lot of other things it goes into. I mean, we could spend just forever talking about all the different applications from business to whatever you could even imagine. They're now applying neural networks to help us understand. So now that we've talked a little bit about all the cool things you can do with a neural network, let's dive in and say, how does a neural network work? So now we've come far enough to understand how neural network works. Let's go ahead and walk through this in a nice graphical representation. They usually describe a neural network as having different layers. And you'll see that we've identified a green layer, an orange layer, and a red layer. The green layer is the input. So you have your data coming in. It picks up the input signals and passes them to the next layer. The next layer does all kinds of calculations and feature extraction. It's called the hidden layer. A lot of times there's more than one hidden layer. We're only showing one in this picture, but we'll show you how it looks like in a more detail in a little bit. And then finally we have an output layer. This layer delivers the final result. So the only two things we see is the input layer and the output layer. Now let's make use of this neural network and see how it works. Wonder how traffic cameras identify vehicles' registration plate on the road to detect speeding vehicles and those breaking the law? They got me going through a red light the other day. Well, last month. That's like the horrible thing. They send you this picture of you and all your information because they pulled it up off of your license plate and your picture. I shouldn't have gone through the red light. So here we are, and we have an image of a car, and you can see the license plates on there. So let's consider the image of this vehicle and find out what's on the number plate. The picture itself is 28 by 28 pixels, and the image is fed as an input to identify the registration plate. Each neuron has a number called activation that represents the grayscale value of the corresponding pixel range. And we range it from 0 to 1. 1 for a white pixel and 0 for a black pixel. And you can see down here we have an example where one of the pixels is registered as like 0.82, meaning it's probably pretty dark. Each neuron is lit up when its activation is close to 1. So as we get closer to black on white, we can really start seeing the details in there. And you can see again the pixel shows us one up there. It's like part of the car, and so it lights up. So pixels in the form of arrays are fed to the input layer. And so we see here the pixel of a car image fed as an input. And you're going to see that the input layer, which is green, is 1 dimension, while our image is 2 dimension. Now, when we look at our setup that we're programming in Python, it has a cool feature that automatically does the work for us. If you're working with an older neural network pattern package, you then convert each one of those rows so it's all one array. So you'd have like row 1 and then just tack row 2 onto the end. You can almost feed the image directly into some of these neural networks. The key is, though, is that if you're using a 28 by 28 and you get a picture of this 30 by 30, shrink the 30 by 30 down to fit the 28 by 28. So you can't increase the number of input, in this case green dots. It's very important to remember when you work on neural networks. And let's name the inputs x1, x2, x3 respectively. So each one of those represents one of the pixels coming in. And the input layer passes it to the hidden layer. And you can see here we now have 2 hidden layers in this image, in the orange, and each one of those pixels connects to each one of those hidden layers. And the interconnections are assigned weights at random. So they get these random weights that come through. If x1 lights up, then it's going to be x1 times this weight going into the hidden layer. And we sum those weights. The weights are multiplied with the input signal, and a bias is added to all of them. So as you can see here, we have x1 comes in, and it actually goes to all the different hidden layers nodes, or in this case, whatever you want to call them, network setup, the orange dots. And so you take the value of x1, you multiply it by the weight for the next hidden layer. So x1 goes to hidden layer 1, x1 goes to hidden layer 2, x1 goes to hidden layer 1 node 2, hidden layer 1 node 3, and so on. And the bias, a lot of times they just put the bias in as like another green dot or another orange dot, and they give the bias a value 1, and then all the weights go in from the bias into the next node. So the bias can change. We always just remember that you need to have that bias in there. There's things that can be done with it. Generally, most of the packages out there control that for you, so you don't have to worry about figuring out what the bias is. But if you ever dive deep into neural networks, you got to remember there's a bias, or the answer won't come out correctly. The weighted sum of the input is fed as an input to the activation function to decide which nodes to fire and for feature extraction. As the signal flows within the hidden layers, the weighted sum of inputs is calculated and is fed to the activation function in each layer to decide which nodes to fire. So here's our feature extraction of the number plate. And you can see these are still hidden nodes in the middle. And this becomes important. We're going to take a little detour here and look at the activation function. So we're going to dive just a little bit into the math, so you can start to understand where some of the games go on when you're playing with neural networks and you're programming. So let's look at the different activation functions. Before we move ahead, here's our friendly red tag shopping robot. And so one is the sigmoid function. And the sigmoid function, which is 1 over 1 plus e to the minus x, takes the x value, and you can see where it generates almost a 0 and almost a 1 with a very small area in the middle where it crosses over. And we can use that value to feed into another function. So if it's really uncertain, it might have a 0.1 or 0.2 or 0.3, but for the most part it's going to be really close to 1 and really close to, in this case, 0 to 1. The threshold function. So if you don't want to worry about the uncertainty in the middle, you just say, oh, if x is greater than or equal to 0, if not, then x is 0. So it's either 0 or 1. Really straightforward. There's no in between in the middle. And then you have what they call the ReLU function. And you can see here where it puts out the value, but then it says, well, if it's over 1, it's going to be 1. And if it's less than 0, it's 0. So it kind of just dead ends it on those two ends, but allows all the values in the middle. And again, this, like the sigmoid function, allows that information to go to the next level. So it might be important to know if it's a 0.1 or a minus 0.1. The next hidden layer might pick that up and say, oh, this piece of information is uncertain, or this value has a very low certainty to it. And then the hyperbolic tangent function. And you can see here it's 1 minus e to the minus 2x over 1 plus e to the minus 2x. And it's very much along the same theme. A little bit different in here in that it goes between minus 1 and 1. So you'll see some of these, they go 0 to 1, but this one goes minus 1 to 1. And if it's less than 0, it's, it doesn't fire. And if it's over 0, it fires. And it also still puts out a value. So you still have a value that you can get off of that, just like you can with the sigmoid function and the ReLU function. Very similar in use. And I believe originally used to be everything was done in the sigmoid function. That was the most commonly used. And now they just kind of use more the ReLU function. The reason is, one, it processes faster because you already have the value and you don't have to add another compute the 1 over 1 plus e to the minus x for each hidden node. And the data coming off works pretty good as far as putting it into the next level if you want to know just how close it is to 0. How close is it not to functioning? Is it minus 0.1, minus 0.2? Usually they're float values. You get like minus 0.00138 or something. So, important information, but the ReLU is most commonly used these days as far as the setup we're using. But you'll also see the sigmoid function very commonly used also. Now that you know what an activation function is, let's get back to the neural network. So finally, the model would predict the outcome of applying a suitable activation function to the output layer. So we go in here, we look at this, and we have the optical character recognition, OCR, is used on the images to convert it into a text in order to identify what's written on the plate. And as it comes out, you'll see the red node, and the red node might actually represent just the letter A. So there's usually a lot of outputs when you're doing text identification. We're not going to show that on here, but you might have it even in the order. It might be what order the license plate's in. So you might have A, B, C, D, E, F, G, the alphabet plus the numbers, and you might have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So it's a very large array that comes out. It's not a small amount of, we show 3 dots coming in, 8 hidden layer nodes, 2 sets of 4. We just show 1 red coming out. A lot of times this is, 28 times 28 If you did 30 times 30, that's 900 nodes. So 28 is a little bit less than that just on the input. And so you can imagine the hidden layer is just as big. Each hidden layer is just as big, if not bigger. And then the output is going to be, there's so many digits. It's a lot. It's a huge amount of input and output. But we're only showing you just, it'd be hard to show in one picture. And so it comes up, and this is what it finally gets out on the output, is it identifies a number on the plate. And in this case, we have 08-D-03858. Error in the output is back propagated through the network, and weights are adjusted to minimize the error rate. This is calculated by a cost function. When we're training our data, this is what's used. And we'll look at that in the code when we do the data training. So we have stuff we know the answer to, and then we put the information through, and it says, yes, that was correct, or no. Because remember, we randomly set all the weights to begin with. And if it's wrong, we take that error. How far off are you? Are you off by, if it was like -1, you're just a little bit off. If it's like -300 was your output, remember when we're looking at those different options? Hyperbolic or whatever, and we're looking at the REL. The REL doesn't have a limit on top or bottom. It actually just generates a number. So if it's way off, you're going to have to adjust those weights a lot. But if it's pretty close, you might adjust the weights just a little bit. And you keep adjusting the weights until they fit all the different training models you put in. So you might have 500 training models, and those weights will adjust using the back propagation. It sends the error backward. The output is compared with the original result, and multiple iterations are done to get the maximum accuracy. So not only does it look at each one, but it goes through it and just keeps cycling through the data and making small changes in the network until it gets the right answers. With every iteration, the weights at every interconnection are adjusted based on the error. We're not going to dive into that math because it is a differential equation and it gets a little complicated. But I will talk a little bit about some of the different options they have when we look at the code. So we've explored a neural network. Let's look at the different types of artificial neural networks. And this is like the biggest area growing, is how these all come together. Let's see the different types of neural network. And again, we're comparing this to human learning. So here's a human brain. I feel sorry for that poor guy. So we have a feed-forward neural network. Simplest form of they call it an ANN, a neural network. Data travels only in one direction, input to output. This is what we just looked at. So as the data comes in, all the weights are added, it goes to the hidden layer, all the weights are added, it goes to the next hidden layer, all the weights are added, and it goes to the output. The only time you use the reverse propagation is to train it. So when you actually use it, it's very fast. When you're training it, it takes a while because it has to iterate through all your training data. And you start getting into big data because you can train these with a huge amount of data. The more data you put in, the better trained they get. The applications, vision and speech recognition, actually they're pretty much everything we talked about. Almost all of them use this form of neural network at some level. Radio basis function neural network. This model classifies the data point based on its distance from a center point. What that means is that you might not have training data, so you want to group things together and you create central points, and it looks for all the things, some of these things are just like the other. If you've ever watched the Sesame Street as a kid, that dates me. So it brings things together, and this is a great way. If you don't have the right training model, you can start finding things that are connected you might not have noticed before. Applications, power restoration systems. They try to figure out what's connected, and then based on that, they can fix the problem if you have a huge power system. Kohonen self-organizing neural network. Vectors of random dimensions are input to discrete map comprised of neurons. So they basically find a way to draw, and they say dimensions, or vectors, or planes, because they actually chop the data in 1 dimension, 2 dimension, 3 dimension, 4, 5, 6. They keep adding dimensions and finding ways to separate the data and connect different data pieces together. Applications used to recognize patterns in data, like in medical analysis. The hidden layer saves its output to be used for future prediction. Recurrent neural networks. So the hidden layers remember its output from last time, and that becomes part of its new input. You might use that especially in robotics or flying a drone. You want to know what your last change was and how fast it was going to help predict what your next change you need to make is to get to where the drone wants to go. Applications, text-to-speech, conversation model. So, I talked about drones, but, just identifying on Lexus Genesis or Google Assistant or any of these, they're starting to add in, I'd like to play a song on my Pandora and I'd like it to be at volume 90%. So you now can add different things in there and it connects them together. The input features are taken in batches like a filter. This allows a network to remember an image in parts. Convolution neural network. Today's world in photo identification and taking apart photos and trying to, have you ever seen that on Google where you have 5 people together? This is the kind of thing separates all those people so then it can do a face recognition on each person. Applications used in signal and image processing. In this case, I use facial images or Google picture images as one of the options. Modular neural network. It has a collection of different neural networks working together to get the output. So, wow, we just went through all these different types of neural networks, and the final one is to put multiple neural networks together. And I mentioned that a little bit when we separated people in a larger photo, individuals in the photo, and then do the facial recognition on each person. So one network is used to separate them, and the next network is then used to figure out who they are and do the facial recognition. Applications still undergoing research. This is the cutting edge. You hear the term pipeline, and there's actual in Python code and in almost all the different neural network setups out there, they now have a pipeline feature usually. And it just means you take the data from one neural network and maybe another neural network, or you put it into the next neural network, and then you take 3 or 4 other neural networks and feed them into another one. So how we connect the neural networks is really just cutting edge, and it's so experimental. I mean, it's almost creative in its nature. There's not really a science to it because each specific domain has different things it's looking at. So if you're in the banking domain, it's going to be different than the medical domain, than the automatic car domain. And suddenly figuring out how those all fit together is just a lot of fun and really cool. So we have our types of artificial neural network. We have our feed-forward neural network. We have our radial basis function neural network. We have our KNN self-organizing neural network, recurrent neural network, convolution neural network, and modular neural network where it brings them all together. And the colors on the brain do not match what your brain actually does, but they do bring it out that most of these were developed by understanding how humans learn. And as we understand more and more of how humans learn, we can build something in the computer industry to mimic that, to reflect that. And that's how these were developed. So, exciting part, use case, problem statement. So this is where we jump in. This is my favorite part. Let's use the system to identify between a cat and a dog. If you remember correctly, I said we're going to do some Python code, and you can see over here, my hair is kind of sticking up over the computer, a cup of coffee on one side, and then a little bit of old school, a pencil and a pen on the other side. Yeah, most people now take notes. I love the stickies on the computer. That's great. That is my computer. I have sticky notes on my computer in different colors. So not too far from today's programmer. So the problem is we want to classify photos of cats and dogs using a neural network. And you can see over here we have quite a variety of dogs in the pictures and cats, and just sorting out it is a cat is pretty amazing. And why would anybody want to even know the difference between a cat and a dog? Okay, why? Well, I have a cat door. It'd be kind of fun that instead of having like a little collar with a magnet on it, which is what my cat has, the door would be able to see, oh, that's the cat. That's our cat coming in. Oh, that's the dog. We have a dog too. That's the dog I want to let in. Maybe I don't want to let this other animal in because it's a raccoon. So you can see where you could take this one step further and actually apply this. You could actually start a little startup company idea, a self-identifying door. So this use case will be implemented on Python. I am actually in Python 3.6. It's always nice to tell people the version of Python because that does affect sometimes which modules you load and everything. And we're going to start by importing the required packages. I told you we're going to do this in Keras. So we're going to import from Keras models, a sequential from the Keras layers, conversion 2D or CONV 2D, max pooling 2D, flatten, and dense. And we'll talk about what each one of these do in just a second. But before we do that, let's talk a little bit about the environment we're going to work in. And in fact, let me go ahead and open the website, Keras's website, so we can learn a little bit more about Keras. So here we are on the Keras website, and it's keras.io. That's the official website for Keras. And the first thing you'll notice is that Keras runs on top of either TensorFlow, CNTK, and I think it's pronounced Thano or Theano. What's important on here is that TensorFlow, and the same is true for all these, but TensorFlow is probably one of the most widely used currently packages out there with the Keras. And of course, tomorrow this is all going to change. It's all going to disappear and they'll have something new out there. So make sure when you're learning this code that you understand what's going on and also know the code. I mean, when you look at the code, it's not as complicated once you understand what's going on. The code itself is pretty straightforward. And the reason we like Keras, and the reason that people are jumping on it right now and it's such a big deal, is if we come down here, let me just scroll down a little bit, they talk about user friendliness, modularity, easy extensibility, work with Python. Python's a big one because a lot of people in data science now use Python, although you can actually access Keras other ways. If we continue down here is layers. And this is where it gets really cool. When we're working with Keras, you just add layers on. Remember those hidden layers we were talking about? And we talked about the RELU activation. You can see right here. Let me just up that a little bit in size. There we go. That's big. I can add in an RELU layer, and then I can add in a softmax layer in the next instance. We didn't talk about softmax. So you can do each layer separate. Now, if I'm working in some of the other kits I use, I take that and I have one setup, and then I feed the output into the next one. This one I can just add hidden layer after hidden layer with the different information in it, which makes it very powerful and very fast to spin up and try different setups and see how they work with the data you're working on. And we'll dig a little bit deeper in here. And a lot of this is very much the same, so when we get to that part I'll point that out to you also. Now, just a quick side note, I'm using Anaconda with Python in it, and I went ahead and created my own package, and I called it the Keras Python 3.6 because I'm in Python 3.6. Anaconda is cool that way. You can create different environments real easily. If you're doing a lot of different experimenting with these different packages, you probably want to create your own environment in there. And the first thing is you can see right here, there's a lot of dependencies. A lot of these you should recognize by now if you've done any of these videos. If not, kudos for you for jumping in today. Pip install NumPy, SciPy, the scikit-learn. Pillow and H5py are both needed for the TensorFlow and then putting the Keras on there. And then you'll see here, and pip is just a standard installer that you use with Python. You'll see here that we did pip install TensorFlow, since we're going to do Keras on top of TensorFlow. And then pip install, and I went ahead and used the GitHub. So git plus git, and you'll see here github.com. This is one of their releases, one of the most current release on there that goes on top of TensorFlow. And you can look up these instructions pretty much anywhere. This is for doing it on Anaconda. Certainly you'd want to install these if you're doing it in Ubuntu server setup. You'd want to get, I don't think you need the H5py on Ubuntu, but you do need the rest in there because they are dependencies in there, and it's pretty straightforward, and that's actually in some of the instructions they have on their website. So you don't have to necessarily go through this. Just remember their website on there. And then when I'm under my Anaconda Navigator, which I like, you'll see where I have environments, and on the bottom I created a new environment and I called it Keras Python 36, just to separate everything. You can say I have Python 30.5 and Python 3.6. I used to have a bunch of other ones, but I kind of cleaned house recently. And of course, once I go in here, I can launch my Jupyter Notebook, making sure I'm using the right environment that I just set up. This, of course, opens up my, in this case I'm using Google Chrome, and in here I could go and just create a new document in here. And this is all in your browser window when you use the Anaconda. Do you have to use Anaconda in Jupyter Notebook? No. You can use any kind of Python editor, whatever setup you're comfortable with and whatever you're doing in there. So let's go ahead and go in here and paste the code in. And we're importing a number of different settings in here. We have import sequential, that's under the models, because that's the model we're going to use as far as our neural network. And then we have layers, and we have conversion 2D, max pooling 2D, flatten, dense, and you can actually just kind of guess at what these do. We're working in a 2D photograph, and if you remember correctly, I talked about how the actual input layer is a single array. It's not in 2 dimensions, it's 1 dimension. All these do is these are tools to help flatten the image, so it takes a 2-dimensional image and then it creates its own proper setup. You don't have to worry about any of that. You don't have to do anything special with the photograph. You let the Keras do it. And we're going to run this, and you'll see right here they have some stuff that is going to be depreciated and changed, because that's what it does. Everything's being changed as we go. You don't have to worry about that too much. If you have warnings, if you run it a second time, the warning will disappear. And this has just imported these packages for us to use. And Jupyter's nice about this that you can do each thing step by step. And I'll go ahead and also zoom in there. A little Control plus. That's one of the nice things about being in a browser environment. So here we are back. Another sip of coffee. If you're familiar with my other videos, you notice I'm always sipping coffee. I always have in my case, latte next to me, an espresso. So the next step is to go ahead and initialize, we're going to call it the CNN, or classifier neural network. And the reason we call it a classifier is because it's going to classify it between two things. It's going to be cat or dog. So when you're doing classification, you're picking specific objects. You're specific, it's a true or false, yes, no, it is something or it's not. So first thing, we're going to create our classifier, and it's going to equal sequential. So their sequential setup is the classifier. That's the actual model we're using. That's the neural network. So we call it a classifier. And the next step is to add in our convolution. And let me just do let me shrink that down in size so you can see the whole line. And let's talk a little bit about what's going on here. I have my classifier and I add something. What am I adding? Well, I'm adding my first layer. This first layer we're adding in is probably the one that takes the most work to make sure you have it set correct. And the reason I say that is this is your actual input. And we're going to jump here to the part that says input shape equals 64 by 64 by 3. What does that mean? Well, that means that our picture's coming in, and there's these pictures. Remember we had like the picture of the car was 128 by 128 pixels? Well, this one is 64 by 64 pixels. And each pixel has 3 values. That's where these numbers come from. And it is so important that this matches. I mentioned a little bit that if you have like a larger picture, you have to reformat it to fit this shape. If it comes in as something larger, there's no input nodes. There's no input neural network there that will handle that extra space. So you have to reshape your data to fit in here. Now, the first layer is the most important because after that, Keras knows what your shape is coming in here and it knows what's coming out. And so that really sets the stage. Most important thing is that input shape matches your data coming in. And you'll get a lot of errors if it doesn't. You'll go through there and picture number 55 doesn't match it correctly. And guess what it does? It usually gives you an error. And then the activation, if you remember we talked about the different activations on here, we're using the ReLU model. Like I said, that is the most commonly used now because one, it's fast. It doesn't have the added calculations in it. It just says, here's the value coming out based on the weights and the value going in, and from there, you know, it's if it's over 1, then it's good, or over 0, it's good. If it's under 0, then it's considered not active. And then we have this conversion 2D. What the heck is conversion 2D? I'm not going to go into too much detail in this because this has a couple of things it's doing in here. A little bit more in depth than we're ready to cover in this tutorial. But this is used to convert from the photo because we have 64 by 64 by 3 and we're just converting it to two-dimensional kind of setup. So it's very aware that this is a photograph and that different pieces are next to each other. And then we're going to add in a second convolutional layer. That's what the CONV stands for, 2D. So these are hidden layers. So we have our input layer and our 2 hidden layers, and they are two-dimensional because we're doing with a two-dimensional photograph. And you'll see down here that on the last one we add a max pooling 2D, and we put a pool size equals 2, And so what this is that as you get to the end of these layers, one of the things you always want to think of is what they call mapping and then reducing. Wonderful terminology from the big data. We're mapping this data through all these layers, and now we want to reduce it to only 2 sets. In this case, it's already in 2 sets because it's a 2D photograph. But we had, 2 dimensions we actually have 64 by 64 by 3. So now we're just getting it down to a 2 by 2, just the two-dimensional instead of having the third dimension of colors. And we'll go ahead and run these. We're not really seeing anything on our run script because we're just setting up. This is all set up. And this is where you start playing because maybe you'll add a different layer in here to do something else to see how it works and see what your output is. That's what makes Keras so nice is I can, with just a couple flips of code, put in a whole new layer that does a whole new processing and see whether that improves my run or makes it worse. And finally, we're going to do the final setup, which is to flatten. Classifier add a flatten setup, and then we're going to also add a layer, a dense layer, and then we're going to add in another dense layer, and then we're going to build it. We're going to compile this whole thing together. So let's flip over and see what that looks like. And we've even numbered them for you, so we're going to do the flattening. And flatten is exactly what it sounds like. We've been working in a two-dimensional array of picture, which actually is in 3 dimensions because of the pixels. The pixels have a whole nother dimension to it of 3 different values. And we've kind of resized those down to 2 by 2, but now we're just going to flatten it. I don't want to have multiple dimensions being worked on by Tensor and by Keras. I want just a single array, so it's flattened out. And then step 4, full connection. So we add in our final 2 layers, and you could actually do all kinds of things with this. You could actually leave out this some of these layers and play with them. You do need to flatten it. That's very important. Then we want to use the dense. Again, we're taking this and we're taking whatever came into it. So once we take all those the 2 dimensions or 3 dimensions as they are, and we flatten it to 1 dimension, we want to take that and we're going to pull it into units of 128. They got that. You can say, where did they get 128 from? You could actually play with that number and get all kinds of weird results. But in this case, we took the 64 plus 64 is 128. You could probably even do this with 64 or 32. Usually you want to keep it in the same multiple of whatever the data shape you're already using is in. And we're using the activation, the RELU, just like we did before. And then we finally filter all that into a single output. And it has how many units? 1. Why? Because we want to know whether true or false. It's either a dog or a cat. You could say 1 is dog, 0 is cat. Or maybe you're a cat lover and it's 1 is cat and 0 is dog. And if you love both dogs and cats, you're going to have to choose. And then we use the sigmoid activation. If you remember from before, we had the RELU and there's also the sigmoid. The sigmoid just makes it clear it's yes or no. We don't want any kind of in-between number coming out. And we'll go ahead and run this, and you'll see it's still all in setup. And then finally we want to go ahead and compile. And let's put the compiling our classifier neural network. And we're going to use the optimizer Atom. And I hinted at this just a little bit before. Where does Atom come in? Where does an optimizer come in? Well, the optimizer is the reverse propagation. When we're training it, it goes all the way through and says error, and then how does it readjust those weights? There are a number of them. Atom is the most commonly used, and it works best on large data. Most people stick with the Atom because when they're testing on smaller data, see if their model is going to go through and get all their errors out before they run it on larger data sets. They're going to run it on Atom anyway, so they just leave it on Atom, most commonly used. But there are some other ones out there. You should be aware of that you might try them if you're stuck in a bind, or you might explore that in the future. But usually Atom is just fine on there. And then you have 2 more settings. You have loss and metrics. We're not going to dig too much into loss or metrics. These are things you really have to explore Keras because there are so many choices. This is how it computes the error. There's so many different ways on your back propagation and your training. So we're using the Atom model, but you can compute the error by standard deviation squared. They use binary cross entropy. I'd have to look that up to even know what that is. There's so many of these. A lot of times you just start with the ones that look correct, that are most commonly used, and then you have to go read the Keras site and actually see what these different losses and metrics and what different options they have. So we're not going to get too much into them other than to reference you over to the Keras website to explore them deeper. But we are going to go ahead and run them. And now we've set up our classifier. So we have an object classifier, and if you go back up here, you'll see that we've added in step 1, we added in our layer for the input. We added a layer that comes in there and uses the RELU for activation, and then it pulls the data. So this is, even though these are 2 layers, the actual neural network layer is up here, and then it uses this to pull the data into a 2 by 2. So into a 2-dimensional array from a 3-dimensional array with the colors. Then we flatten it. So there's our adder flatten. And then we add another dense, what they call dense layer. This dense layer goes in there and it downsizes it to 128. It reduces it. So you can look at this as we're mapping all this data down the 2-dimensional setup, and then we flatten it. So we map it to a flattened map, and then we take it and reduce it down to 128. And we use the RELU again. And then finally we reduce that down to just a single output, and we use the sigmoid to do that, to figure out whether it's yes, no, true, false, in this case cat or dog. And then finally, once we put all these layers together, we compile them. That's what we've done here. And we've compiled them as far as how it trains to use these settings for the training, back propagation. So if you remember, we talked about training our setup. And when we go into this, you'll see that we have two data sets. We have one called the training set and the testing set. And that's very standard in any data processing, is you need to have, that's pretty common in any data processing, is you need to have a certain amount of data to train it, and then you got to know whether it works or not. Is it any good? And that's why you have a separate set of data for testing it, where you already know the answer, but you don't want to use that as part of the training set. So in here we jump into part 2, fitting the classifier neural network to the images. And then from Keras, and let me just zoom in there. I always love that about working with Jupyter Notebooks, you can really see. We're going to come in here, we do the cross pre-processing an image, and we import image data generator. It's so nice of Keras. It's such a high-end product right now going out, and since images are so common, they already have all this stuff to help us process the data, which is great. And so we come in here, we do train data gen, and we're going to create our object for helping us train it, for reshaping the data so that it's going to work with our setup. And we use an image data generator, and we're going to rescale it. And you'll see here we have 1 point, which tells us it's a float value on the rescale over 255. Where does 255 come from? Well, that's the scale in the colors of the pictures we're using. They're value from 0 to 255. So we want to divide it by 255, and it'll generate a number between 0 and 1. They have shear range and zoom range, horizontal flip equals true, and this of course has to do with if the photos are different shapes and sizes. Like I said, it's a wonderful package. You really need to dig in deep to see all the different options you have for setting up your images. For right now though, we're going to just stick with some basic stuff here, and let me go ahead and run this code. And again, it doesn't really do anything because we're still setting up the pre-processing. Let's take a look at this next set of code. And this one is just huge. We're creating the training set. So the training set is going to go in here and it's going to use our train data gen we just created, .flow from directory. It's going to access, in this case, the path, data set, training set. That's a folder. So it's going to pull all the images out of that folder. Now, I'm actually running this in the folder that the data set's in. So if you're doing the same setup and you load your data in there and you're doing this, make sure wherever your Jupyter Notebook is saving things to that you create this path, or you can do the complete path if you need to, C:/, etc. And the target size, the batch size, and class mode is binary. So the classes, we're switching everything to a binary value. Batch size, what the heck is batch size? Well, that's how many pictures we're going to batch through the training each time. And the target size, 64 by 64. A little confusing, but you can see right here that this is just a general training, and you can go in there and look at all the different settings for your training set. And of course, with different data, we're doing pictures, there's all kinds of different settings depending on what you're working with. Let's go ahead and run that and see what happens. And you'll see that it found 800 images belonging to one classes. So we have 800 images in the training set. And if we're going to do this with the training set, we also have to format the pictures in the test set. Now, we're not actually doing any predictions. We're not actually programming the model yet. All we're doing is preparing the data. So we're going to prepare a training set and the test set. So any changes we make to the training set at this point also have to be made to the test set. So we've done this thing, we've done a train data generator, we've done our training set, and then we also have, remember, our test set of data. So I'm going to do the same thing with that. I'm going to create a test data gen, and we're going to do this image data generator. We're going to rescale 1 over 255. We don't need the other settings, just the single setting for the test data gen. And we're going to create our test set. We're going to do the same thing we did with the test set, except that we're pulling it from the test set folder. And we'll run that, and you'll see in our test set we found 2,000 images. That's about right. We're using 20% of the images as test and 80% to train it. And then finally we've set up all our data. We've set up all our layers, which is where all the work is cleaning up that data and making sure it's going in there correctly. And we're actually going to fit it. We're going to train our data set. And let's see what that looks like. And here we go. Let's put the information in here. And let's just take a quick look at what we're looking at with our fit generator. We have our classifier.fit generator. That's our back propagation. So the information goes through forward with a picture, and it says, oh, you're either right or you're wrong, and then the error goes backward and reprograms all those weights. So we're training our neural network. And of course we're using the training set. Remember, we created the training set up here, and then we're going steps per epoch. So it's 8,000 steps. Epic means that's how many times we go through all the pictures. So we're going to rerun each of the pictures, and we're going to go through the whole data set 25 times. But we're going to look at each picture during each epic 8,000 times. So we're really programming the heck out of this and going back over it. And then they have validation data equals test set. So we have our training set, and then we're going to have our test set to validate it. So we're going to do this all in one shot. And we're going to look at that, and they're going to do 200 steps for each validation. And we'll see what that looks like in just a minute. Let's go ahead and run our training here. And we're going to fit our data. And as it goes, it says epic 1 of 25. You start realizing that this is going to take a while. On my older computer, it takes about 45 minutes. I have a dual processor. We're processing 10,000 photos. That's not a small amount of photographs to process. So if you're on your laptop, which I am, that's going to take a while. So let's go ahead and go get our cup of coffee and a sip and come back and see what this looks like. So I'm back. You didn't know I was gone. That was actually a lengthy pause there. I made a couple changes, and let's discuss those changes real quick and why I made them. So the first thing I'm going to do is I'm going to go up here and insert a cell above, and let's paste the original code back in there. And you'll see that the original thing was steps per epic 8,000, 25 epics, and validation steps 2,000. And I changed these to 4,000 epics, or 4,000 steps per epic, 10 epics, and just 10 validation steps. And this will cause problems if you're doing this as a commercial release. But for demo purposes, this should work. And if you remember, our steps per epic, that's how many photos we're going to process. In fact, let me go ahead and get my drawing pen out. And let's just highlight that right here. Well, we have 8,000 pictures we're going through. So for each epic, I'm going to change this to 4,000. I'm going to cut that in half. So it's going to randomly pick 4,000 pictures each time it goes through an epic. And the epic is how many processes. So this is 25, and I'm just going to cut that to 10. So instead of doing 25 runs through 8,000 photos each, which you can do the math of 25 times 8,000, I'm only going to do 10 through 4,000. So I'm going to run this 40,000 times through the processes. And the next thing I noted you'll want to notice is that I also changed the validation step. And this would cause some major problems in releasing because I dropped it all the way down to 10. What the validation step does is it says we have 2,000 photos in our trainings or in our testing set. And we're going to use that for validation. Well, I'm only going to use a random 10 of those to validate. So not really the best settings, but let me show you why we did that. Let's scroll down here just a little bit. And let's look at the output here and see what's going on there. So I've got my drawing tool back on, and you'll see here it lists a run. So each time it goes through an epic, it's going to do 4,000 steps. And this is where the 4,000 comes in. So that's where we have epic 1 of 10, 4,000 steps. So it's randomly picking half the pictures in the file and going through them. And then we're going to look at this number right here. That is for the whole epic. And that's 2,411 seconds. And if you remember correctly, you divide that by 60, you get minutes. If you divide that by 60, you get hours. Or you can just divide the whole thing by 60 times 60, which is 3,600. If 3,600 is an hour, this is roughly 45 minutes right here. And that's 45 minutes to process half the pictures. So if I was doing all the pictures, we're talking an hour and a half per epic times 36. Or no, 25. They had 25 up above. 25. So that's roughly a couple days of processing. Well, for this demo, we don't want to do that. I don't want to come back the next day. Plus, my computer did a reboot in the middle of the night. So we look at this and we say, okay, we're just testing this out. My computer that I'm running this on is a dual core processor, runs 0.9 gigahertz per second. For a laptop, it was good about 4 years ago, but for running something like this, it's probably a little slow. So we cut the times down, and the last one was validation. We're only validating it on a random 10 photos. And this comes into effect because you're going to see down here where we have accuracy, value loss, value accuracy, and loss. Those are very important numbers to look at. So the 10 means I'm only validating across 10 pictures. That is where, here we have value, this is ACC is for accuracy. Value loss, we're not going to worry about that too much, and accuracy. Now accuracy is while it's running, it's putting these two numbers together. That's what accuracy is. And value accuracy is at the end of the epic. What's our accuracy at the end of the epic? What is it looking at? In this tutorial, we're not going to go so deep, but these numbers are really important when you start talking about these two numbers reflect bias. That is really important. I'll just put that up there. And bias is a little bit beyond this tutorial, but the short of it is if this accuracy, which is being our validation per step, is going down, and the value accuracy continues to go up, that means there's a bias. That means I'm memorizing the photos I'm looking at. I'm not actually looking for what makes a dog, what makes a cat. I'm just memorizing them. And so the more this discrepancy grows, the bigger the bias is. And that is really the beauty of the Keras neural network. It has a lot of built-in features like this that make that really easy to track. So let's go ahead and take a look at the next set of code. So here we are into part 3. We're going to make a new prediction. And so we're going to bring in a couple tools for that, and then we have to process the image coming in and find out whether it's an actual dog or cat, if we can actually use this to identify it. And of course the final step of part 3 is to print prediction. We'll go ahead and combine these, and of course you can see me there adding more sticky notes to my computer screen, hidden behind the screen, and last one was don't forget to feed the cat and the dog. So let's go ahead and take a look at that and see what that looks like in code and put that in our Jupyter notebook. All right, and let's paste that in here. And we'll start by importing NumPy as NP. NumPy is a very common package. I pretty much import it on any Python project I'm working on. Another one I use regularly is pandas. They're just ways of organizing the data. And then NP is usually the standard in most machine learning tools as a return for the data array. Although, you can use a standard data array from Python. And we have Keras, preprocessing, import image. This should all look familiar because we're going to take a test image and we're going to set that equal to, in this case, cat or dog 1, as you can see over here. And let me get my drawing tool back on. So let's take a look at this. We have our test image we're loading, and in here we have test image 1, and this one data hasn't seen this one at all, so this is all new. Oh, let me shrink the screen down. Let me start that over. So here we have my test image, and we went ahead and the Keras processing has this nice image setup. So we're going to load the image and we're going to alter it to a 64 by 64 print. So right off the bat, Keras is nice that way. It automatically sets it up for us so we don't have to redo all our images and find a way to reset those. And then we use all those to set the image to an array. So again, we're all in pre-processing the data, just like we pre-processed before with our test information and our training data. And then we use the NumPy. Here's our NumPy. That's from our right up here, import NumPy as NP. Expand the dimensions, test image, axes equals 0. So it puts it into a single array. And then finally, all that work, all that pre-processing, and all we do is we run the result. We click on here and we go result equals classifier, predict, test image, and then we find out, well, what is the test image? And let's just take a quick look and just see what that is. And you can see when I ran it, it comes up dog, and if we look at those images, there it is, cat or dog, image number 1. That looks like a nice floppy-eared lab, friendly with his tongue hanging out. It's either that or a very floppy-eared cat. I'm not sure which. But according to our software, it says it's a dog. And we have a second picture over here. Let's just see what happens when we run the second picture. We can go up here and change this from dog image 1 to 2. We'll run that, and it comes down here and says cat. You can see me highlighting it down there as cat. So our process works. We are able to label a dog and a cat just from the pictures. There we go, cleared my drawing tool. And the last thing I want you to notice, when we come back up here to when I ran it, you'll see it has an accuracy of 1 and the value accuracy of 1. Well, the value accuracy is the important one because the value accuracy is what it actually runs on the test data. Remember, I'm only validating it on a random 10 photos. And those 10 photos just happen to come up 1. Now, when they ran this on the server, it actually came up about 86%. This is why cutting these numbers down so far for a commercial release is bad. So you want to make sure you're a little careful of that when you're testing your stuff, that you change these numbers back when you run it on a more enterprise computer other than your old laptop that you're just practicing on or messing with. And we come down here and again, we had the validation of cat. And so we have successfully built a neural network that could distinguish between photos of a cat and a dog. Imagine all the other things you could distinguish. Imagine all the different industries you could dive into with that, just being able to understand those two different pictures. What about mosquitoes? Could you find the mosquitoes that bite versus the mosquitoes that are friendly? It turns out the mosquitoes that bite us are only 4% of the mosquito population, if even that, maybe 2%. There's all kinds of industries that use this, and there's so many industries that are just now realizing how powerful these tools are. Just in the photos alone, there is a myriad of industries sprouting up. And I said it before, I'll say it again, what an exciting time to live in with these tools that we get to play with. So, key takeaways. Well, we covered what is a neural network. We use all kinds of processing, the map images on your phone. We talked about things that a neural network can do. Translate text, identify faces, all the way to control robots. Lots of exciting things. How does a neural network work? So we discussed that with the different layers, going from the picture to the input layer, to the hidden layers and their weights, to the final output layer. We also talked about how it does the math and computing the output as yes or no, categorically true, false. We discussed types of artificial neural networks. A lot of vocabulary there from the feed-forward neural network, which is the most commonly used. That's the neural network we used is a feed-forward neural network that does backward propagation to train. And there's a lot of other ones out there. There's the radial biases, the KNN self-organizing recurrent neural network, convolution neural network, modular neural network. The big one was modular because it incorporates pieces of all the other ones so that whatever you're working on now is a huge conglomerate of multiple networks. Just all cutting edge. All of it's new. People even working on it don't even know where it's going. Again, very exciting times. And finally, we dug through my favorite part. You can see with my latte on one side, my old school pens and pencil and all my sticky notes working away. That's not actually me, by the way. You probably guessed that. And we walked through and actually did a cat and dog photo. A simple cat and dog photo. And you could see where some of the problems are in processing large amounts of photographs and data, where that starts to become going from a single machine on my laptop with its lower amount of resources all the way to big data. How if you're processing hundreds and thousands of these photos, this now needs to be set up on an enterprise machine or even on a cluster of computers. Again, significantly past the scope of this. The neat part about it, though, is once you write this code, most of this code, they now have tools that you can almost take the same ideas, if not the actual code, and push it right onto a cluster computation. So really cool times for this.
If you want to become an AI expert and gain handsome salary packages, look at the wide range of AI/ML courses by Simplilearn in collaboration with top universities across the globe. So what are you waiting for? Hurry up and enroll now. Find the course link in the description box.
Welcome to the video on large language models. Large language models are basically very advanced artificial intelligence systems that can process and generate massive amounts of text data. They are designed to learn from and understand natural human language and can be used to perform a wide range of language-related tasks such as translation, speech recognition, and automatic summary generation. One of the key advantages of large language models is their ability to learn from vast amounts of data, which allows them to generate highly accurate and realistic responses to complex natural language prompts. Additionally, they can be trained on multiple languages simultaneously, which means they can be used to perform language translation between different pairs of languages, making them an invaluable tool for businesses and organizations that work with people from diverse cultural backgrounds. Not just language-related tasks, but LLMs can also have the potential to revolutionize fields such as research, science, and healthcare. By allowing researchers to quickly analyze and process vast amounts of complex text data, they can accelerate progress in areas such as drug discovery, healthcare diagnostics, and AI development. That being said, large language models also present some challenges. For instance, they require a significant amount of compute resources, which can be prohibitively expensive for some organizations. Additionally, because they are trained on huge amounts of data, they may inadvertently reinforce biased or discriminatory patterns in language use, which is something that researchers and engineers are continuously working to address. Overall, large language models are an exciting and rapidly developing field with tremendous potential to transform the way we live, work, and communicate. So if you want to embark on a journey of AI and ML, then try giving a shot to our postgraduate program in AI and ML that is in partnership with IBM. This artificial intelligence course covers the latest tools and technologies from the AI ecosystem and features masterclasses by Caltech faculty and IBM experts, hackathons, and Ask Me Anything sessions. This program showcases Caltech CTMA's excellence and IBM's industry prowess. The artificial intelligence course covers key concepts like statistics, data science with Python, machine learning, deep learning, NLP, and reinforcement learning through an interactive learning model with live sessions. Enroll now and unlock exciting AI and ML opportunities. The link is mentioned in the description box below. And with that having said, hey everyone, welcome to Simplilearn's YouTube channel. But before we dive into that, don't forget to like, subscribe and share. In this video, we will cover topics like what are large language models. After that, we will look at what large language models used for. And after that, we'll cover how are large language models trained. After this, we'll look at how do large language models work. And at the last, we'll see some applications of large language models. So without any further ado, let's get started. So we'll start with what are the large language models. Large language models such as GPT-3, Generative Pre-trained Transformer 3 are advanced artificial intelligence systems designed to understand and generate human-like text. These models are built using deep learning techniques and have been trained on vast amounts of text data from the internet. These models use self-attention mechanisms to analyze the relationships between words or tokens in a text, enabling them to capture contextual information and generate coherent responses. These models use self-attention mechanisms to analyze the relationship between different words or tokens in a text, enabling them to capture contextual information and generate coherent responses. These models have significant implications for a wide range of applications, including virtual assistants, chatbots, content generation, language translation, and aiding in research and decision-making processes. Their ability to generate coherent and contextually appropriate text has led to advancement in natural language understanding and human-computer interaction. Now we'll see what are language models used for. So large language models are utilized in scenarios where there is limited or no domain-specific data available for training. These scenarios include both few-shot and zero-shot learning approaches, which rely on the model's strong inductive bias and its capability to derive meaningful representations from a small amount of data or even no data at all. Now, we'll see how are large language models trained. Large language models typically undergo pre-training on a broad, all-encompassing dataset that shares statistical similarities with the dataset specific to the target task. The objective of pre-training is to enable the model to acquire high-level features that can later be applied during the fine-tuning phase for specific tasks. And the training process of a large language model involves several steps. The first is text preprocessing. The textual data is transformed into a numerical representation that can be effectively processed by the model. This conversion may involve techniques like tokenization, encoding, and creating input sequences. The next we have is random parameter initialization. The model's parameters are initialized randomly before the training process begins. The next is inputting numerical data. The numerical representation of text data is fed into the model for processing. The model's architecture, typically based on transformers, allows it to capture the contextual relationships between the words and tokens in the text. And the next is loss function calculation. A loss function is employed to measure the discrepancy between the model's predictions and the actual next word or token in a sentence. The model aims to minimize this loss during training. And the next is parameter optimization. The model's parameters are adjusted through optimization techniques such as gradient descent to reduce the loss. This involves calculating gradients and updating the parameters accordingly, gradually improving the model's performance. And the next is iterative training. The training process is repeated over multiple iterations or epochs until the model's outputs achieve a satisfactory level of accuracy on the given task or dataset. By following this training process, large language models learn to capture linguistic patterns, understand context, and generate coherent responses, enabling them to excel at a wide range of language-related tasks. And now, we will see how do large language models work. So large language models leverage deep neural networks to generate outputs based on patterns learned from the training data. Typically, a large language model adopts a transformer architecture which enables the model to identify relationships between words in a sentence irrespective of the position in the sequence. In contrast to recurrent neural networks, that is RNNs, that rely on recurrence to capture token relationships, transformer neural networks employ self-attention as their primary mechanism. Self-attention calculates attention scores that determines the importance of each token with respect to other tokens in the text sequence, facilitating the modeling of intricate relationships within the data. Now we'll see applications of large language models. Large language models have a wide range of applications across various domains. And here are some notable applications. The first one is natural language processing. Large language models are used to improve natural language understanding tasks such as sentiment analysis, named entity recognition, text classification, and language modeling. The next is chatbots and virtual assistants. Large language models power conversational agents, chatbots, and virtual assistants, providing more interactive and human-like interactions with users. And the next is machine translation. Large language models have been used for automatic language translation, enabling the translation of text between different languages with improved accuracy. And the next we have is sentiment analysis. Large language models can analyze and classify the sentiment or emotion expressed in a piece of text, which is valuable for market research, brand monitoring, and social media analysis. And the next we have is content recommendation. These models can be employed to provide personalized content recommendations, enhancing user experience and engagement on platforms such as news websites or streaming services. These applications highlight the versatility and potential impact of large language models in various domains, improving language understanding, automation, and interaction between humans and computers.
Everyone knows the algorithm is a step-by-step process to approach a particular problem. There are numerous examples of algorithms, from figuring out sets of numbers to finding routes through maps to showing data on a screen. Let's understand this by using an example. Every algorithm is built on inputs and outputs. Google search algorithm is no different. The input is the search field and the output is the page of result that appears when you enter a particular phrase or keyword, also known as SERP or search engine result page. Google has a search algorithm so it can sort results from various websites and provides the user the best result. When you start a search, you will see the search box. Will attempt to guess what you are looking for. In order to better understand what the user is looking for, the algorithm is trying to gather as many as suggestions from them as possible. The results from the search field that best matches the query will be ranked. The choose with website will rank and in what position using more than 200 ranking variables. Now let's take an example of coding program and see how the algorithm works. Here, we will use a case of computer program wherein we want to print the multiplication table of any number. Let's take 2. The algorithm start here and then it assign a value to a variable. The variable I is having an initial value of 1. The system will read the number. The number in case is 2. Now, the system has a condition. A condition can now either be true or false. If the value of I reaches 11, then the loop will end. Otherwise, value of I will multiply by the number. The initial value of I is 1. So, for the first time, the system output will be 2. Now, value of I will be increased by 1. According to the loop condition, the system will then move back and check for the condition again. The new value of I is 2, which is still less than 11. The system will again print 2 into I, which is 2 into 2 on the screen. The new output result will be 4. The system will keep following the same procedure repeatedly until the value of I becomes 11. Once the value of I becomes 11, then only the algorithm will terminate. After discussing how an algorithm works, let's move forward and see some popular machine learning algorithms. Some popular machine learning algorithms are: first one is linear regression algorithm, second one is logistic regression algorithm, and the third one is decision tree, and the fourth one is support vector machine algorithm SVM, and the fifth one is KNN, K nearest neighbor algorithm, and the sixth one is K means clustering algorithms, and the seventh one is random forest algorithms, and the last but not the least algorithm is Apriori algorithms. Let's go through them in detail one by one. Linear regression is one of the most famous and straightforward machine learning algorithms utilized for predictive analysis. Linear regression shows the linear connection between the dependent and the independent factors. The equation of line is y equals to mx plus b. Here, y stands for the response variable or a dependent variable, whereas x is for the predictor variable or an independent variable. It attempts best to fit line between the dependent and the independent variables, and this best fit line is known as line of regression or regression line. Let's take a real application example. In predicting consumer behavior, businesses use linear regression to forecast things like how much a client is likely to spend. Things like targeted marketing and product development may benefit from this. Walmart, for instance, used linear regression to forecast which good would be in high demand across the nation. Moving forward, let's see types of linear regression. There are two types of linear regression algorithm. The first one is simple linear regression and the second one is multiple linear regression. In simple linear regression, if an independent variable is utilized to forecast the worth of a mathematical dependent variable, then at that point, such a linear regression algorithm is called simple linear regression. The equation of line will be y equals to a0 plus a1x. And the second one is multiple linear regression. If the dependent variable declines on the y and the independent variable on the x, then such a relationship is known as negative linear relationship. The line of equation will be minus of a0 plus a1x. Moving forward, let's see logistic linear regression. Logistic regression is the supervised machine learning algorithm utilized to anticipate all the categorical factors or discrete values. It could be very well used for the grouping issues in machine learning. And the result of the logistic regression can be either yes or no, 0 or 1, man or woman, and so on. It gives the values which lies between 0 and 1. For example, a credit card business is interested in knowing whether the transaction amount and the credit scope have an impact on the probability that a particular transaction would be fraudulent. The business can use logistic regression to determine how these two predator values can relate the probability that a transaction is fraudulent. The response variable in the model has two possible outcomes. First one is the transaction is fraudulent, and the second one is the transaction is not fraudulent. In logistic regression, rather than fitting a regression line, we fit an S-form logistic capability, which predicts two greatest value, 0 or 1. The logistic regression equation can be calculated from linear regression equation. The steps to get logistic regression equations are: the equation of straight line can be written as y equals to b0 plus b1x1 plus b2x2 till bnxn. In logistic regression, y can be between 0 and 1 only. So for that, let's divide the above equation by 1 minus y. Then the equation will be y upon 1 minus y, that is 0 for y0 and infinity for y equals to 1. But range between minus infinity to plus infinity, then we have to take the logarithm of equation, and now it will become log of y upon 1 minus y equals to b0 plus b1x1 plus b2x2 so on till bn xn. Let's move forward and see types of logistic regression. There are three types of logistic regression that can be classified. First one is binomial. In binomial logistic regression, there can be only two possible types of dependent variables like yes or no, pass or fail, man woman, and many more. And the second one is multinomial. In multinomial logistic regression, there can be three or more possible unordered ways of dependent variable such as horse, cow, and sheep. And the last one is ordinal. In ordinal logistic regression, there can be three or more possible ordered ways of dependent variable such as small, medium, or large. Moving forward, let's see decision trees in detail. A decision tree is a tree structured classifier that could be used for classification and regression. A decision tree is a tree in which each non-leaf node is assigned to an attribute. Additionally, each arc contains one of the available values for its parent node, which is associated with each leaf node, that is, the node from where the arc is directed. Let's see some decision tree terminology. First one is root, that contains the entire data set. The next one is node, a test for the data of a certain attribute. And the third one is branch, which connect the node to internal node or the internal node to leaf node. And the fourth one is leaf node, the terminal node that predicts the outcome. Let's move forward and see decision tree algorithms. The first one is select the best attribute to use the current node in the tree. The second one is for each possible values, select the attributes. The third one is partition the examples using the possible values of this attribute and assign these disjoint subset of the example to the appropriate child node. Recursively generate each child node until ideally all examples for a node have the same label, like class. Moving forward, let's understand the decision tree. For building a decision tree, step 1 is select an attribute. Then split the data into its children in a tree. Continue splitting with available attributes and keep splitting until leaf nodes are pure, like only one class remains, a maximum depth is reached, a performance metric is achieved. Let's move forward and see SVM algorithm, support vector machine algorithms. A support vector machine is a well-known supervised machine learning model. It is utilized for both information, classification, and regression. It is regularly utilized for the grouping issues. We can involve it in different life care systems, and we can involve it in typically happy or sad look arrangements. We can involve it in filters if we make specific looks. It would add the particular filter according to the expression. The scope of articulation lies between happy and sad. Support vector machine helps in to recognize handwritten characters used widely like checks continue to be a significant part of the majority of non-cash transactions and are frequently written by the pupil. The current check processing system in many developing nations involves a bank employee to read and manually enter the information in a check, while also verifying the data like signature and date. A handwritten text recognition system can reduce expenses and labor hours because a bank must handle several checks each day. Moving forward, let's see the algorithm of SVM. The objective of support vector machine is to make the best line or choice limit that can isolate n-dimensional space into classes. So we can undoubtedly put the new data of interest in the right category. Later on, this best decision boundary is known as a hyperplane. Let's move forward and see types of support vector machine. Support vector machine can be of two types. First one is linear SVM, second one is non-linear SVM. Let's move forward and see linear SVM. Linear SVM is utilized for linearly detachable information, which implies if a dataset can be ordered into two classes by utilizing a straight line, then such information are named linearly separable information, and a classifier is utilized called linear SVM classifier. Moving forward, let's see nonlinear SVM. Nonlinear SVM is utilized for non-directly isolated information, and that implies in the event that a dataset can't be categorized by utilizing a straight line. Such information is named non-directed information, and the classifier utilized is called a nonlinear SVM classifier. Moving forward, let's see KNN algorithm in detail. KNN is a supervised learning technique. KNN classifies new data into a targeted classes depending on the features of its neighboring points and also be used for the regression problems. It is an instance-based learning algorithm and a bit lazy learning algorithm. KNN calculation stores every one of its accessible information and orders another information point based on the likeliness. This means that when new data information appears, it usually tends to be successfully categorized into a good suit classes using the KNN algorithm. Let's imagine we have an image of animal that resembles a cow or ox. However, here we are not sure if it is a cow or ox. As KNN method is based on a likeness matrix, it will identify the properties of new data that are related to the image of cow or ox. And based on those quality, it will classify the data as belonging to either cow or ox group. Moving forward, let's see how does KNN work. The steps to implement KNN algorithms are: Step 1. Decide on the neighbors' k numbers. Step 2. Calculate the Euclidean distance between k neighbors in step 2. Third one is Based on the determined Euclidean distance, select the k closest neighbors. Step 4 is count the numbers of data points in each category between these k neighbors. Step 5, assign the fresh data points in the category where the highest neighbors count. And then KNN model is ready. Let's say we need to add a new data point to the vital category. At first, we will decide on the numbers of neighbors. Therefore, we will pick k equals to 5. Then the Euclidean distance between the data points and then can be determined. The distance between 2 points known as the Euclidean distance can be determined by under root of x2 minus x1 का whole square plus y2 minus y1 whole square. Then we determine the closest neighbors by calculating the Euclidean distance. There are 3 closest neighbors in category A and 2 closest neighbor in category B. This new data point must fall within category A because as we can see, its 3 closest neighbors are also from group A. After understanding KNN algorithm, let's move forward and see K-means algorithms in detail. The K-means is a cluster false. Under that is an unsupervised learning algorithm. It is used to address machine learning clustering problems and utilized to tackle the grouping issues in machine learning. It permits us to bunch the information into various gatherings. It is a helpful method for finding the classification of groups in the unlabeled dataset without the requirement of any training. This K-means algorithm groups the data into similar classes. Let's see some application of K-means clustering. Diagnostic system. The medical profession uses K-means clustering in creating smarter medical decision support system, especially in the treatment of liver alignments. The second one is search engines. Clustering forms a backbone of search engine. When a search engine is performed, the search result need to be grouped, and the search engines very often use clustering to do this. Moving forward, let's see how K-means algorithm works. The steps to implement K-means algorithms are: Step 1. Select the number k to set the number of clusters. Step 2. Select a random k points or centroid. Step 3. Assign each data point the closest centroid that forms to predefined k cluster. Step 4. Determine the variance and set a new gravity points for each cluster. Step 5. Repeat the third step. This means reallocating each data point to the new closest centroid cluster. Step 6. If a reassignment occurs, go to step 4, otherwise go to exit. Step 7. The model is ready to use. So now we have a clear understanding of how K-means algorithm work. Let's move forward to see the graphical representation of K-means algorithm. Consider that there are two variables m1 and m2. This is a scatter plot of these two variables along the x and y axis. We should accept the number of k of bunches, that is k equals to 2, to recognize the dataset and to place them into various groups. It implies here we will attempt to bunch these datasets into two unique groups. We will really want to pick an irregular k point or centroid to frame this group. These centroids can be either the focus of the dataset or some of other points. Thus, here we are choosing under 2 points as k points, which are not the piece of our dataset. We will assign every data of interest in the scatter plot to the nearest k point or centroid. We will register it by applying some math that we consider to find the distance between 2 points, that is Euclidean distance. Thus, we will draw a median between both the centroids. From the graph, the left half of the line are close points to the right and the k1 centroid. Green is near the orange centroid. We should variety them as green and orange for clear representation. As the need might arise to track down the nearest group, we will repeat the cycle by picking another centroid. To pick the new centroid, we will figure out the center point of gravity of these centroids and will track down new centroids. Then we will reassign every piece of information to highlight new centroid. For this, we will repeat a similar course of tracking down a middle line. The middle will be like as seen in the picture. One orange point is on the left half of the line and two green points are on the right. Thus, these 3 points will be appointed to the new centroids. As reassignment has occurred, we will again go to step 4, tracking down new centroids or k points. We will repeat the cycle by tracking down the center point of gravity of centroids. So the new centroids will be displayed as like this. We now have new centroids, so once more define the middle boundary and reassign the data of interest. By this graph, there are no unique pieces of information on one or the other side of the line, implying our model is shaped. By the previous graph, there are no unique pieces of information on one or the other line, implying our model is shaped. As our K-means model is ready, and the two last groups will be displayed as like these. Now we have a clear understanding of how K-means clustering algorithm works. Now let's move forward to understand random forest algorithm. Random forest is an adaptable, simple to utilize machine learning algorithm that produces, even without the hyperboundary tuning, an extraordinary outcome more often than not. It is likewise quite possibly the most utilized algorithm because of its effortlessness and variety. Like it tends to be utilized for both grouping and classification tasks. Random forest is a classifier that contains various choice trees on different subsets of the given dataset and takes the normal to work on the present exactness of the dataset. Instead of depending on the choice tree, the random forest takes the forecast from each tree and in light of the larger part of votes of expectation, it predicts the final result. Now let's move forward and see how does random forest work. We should see the random forest in order since the arrangement is now and again thought to be the structure block of machine learning. This is what a random forest would look like with two trees. The random forest has a similar hypermeter to our decision tree or a Bayesian classifier. Luckily, there is a compelling reason need to consolidate a decision tree with a Bayesian classifier, since you can undoubtedly utilize the classifier classes of random forest. With random forest, you can likewise manage tasks using the algorithm regression. Random forests add extra arbitrariness to the model while developing the trees, rather than looking for the main element while parting a node. It looks to the best component among an irregular subset of highlights. These outcomes in a wide variety often result in a superior model. Subsequently, in a random forest, just a random subset of the element is thought about the algorithm. You might make trees more random by involving random edges for each component instead of looking for the most ideal limits like a typical choice tree does. Let's move forward and see some application of random forest algorithms. Random forest is involved at work by researchers in numerous ventures, including banking, stock exchanging, medication, and many more. It is utilized to predict things which assist these businesses with running productively, like client activity, patient history, and safety. In banking, random forest is used to identify clients who are more likely to pay back their debts on schedule. Additionally, it is utilized to forecast who will make more frequent use of bank services. Even fraud detection uses it. The Robin Hood of algorithms, indeed. Random forest is a tool used by stock traders to forecast future stock behavior. Retail businesses utilize it to make product recommendation and forecast client satisfaction. Random forests can be used in healthcare industry to examine a patient medical history and detect disorders. Random forest is a tool used by pharmaceutical experts to determine the ideal mix of ingredients in treatment or to forecast drug sensitivity. By seeing application of random forest algorithm, let's move forward and see some difference between decision trees and random forest. Let's see the difference between random forest and decision tree. The first one is while building a random forest, the number of rows is selected randomly. In decision trees, it builds several decision trees and find out the output. The second one is it combines two or more decision trees together. In decision trees, whereas the decision is a collection of variables or datasets or attributes. The third one is it gives accurate results, whereas it gives less accurate results. The fourth one is by using random forest, it reduces the chance of overlifting, whereas decision trees it has the possibility of overlifting. The fifth one is random forest is more complicated to interpret, whereas the decision tree is simple, it is easy to read and understand. After seeing what is random forest, how it works, let's move forward to see Apriori algorithms in detail. The Apriori algorithm utilizes standard item sets to create affiliation rules and is intended to chip away the information bases containing exchanges. With the assistance of these affiliation rules, it decides how firmly or feebly two objects are associated. This algorithm utilizes a breadth first search and hash tree to work out the item set association effectively. It is the iterative interaction for finding out the successive item set from the huge dataset. Let's move forward and see steps for a priori algorithms. The steps for a priori algorithms are: step 1 is establish minimal support and confidence for item set in the transactional database. The second one is take all transaction supports with a greater support value, the minimum or chosen support value in step 2. The third one is track down all the rules in these subsets with confidence value greater than the threshold value. The fourth one is arrange the rules to lower the lift. At last, we will see some advantages and disadvantages of a priori algorithm. The advantages of a priori algorithms are easy to understand an algorithm, and the second one is the join and prune steps of the algorithms can be easily implemented on the large dataset. The disadvantages of a priori algorithms are the a priori algorithms work slowly as compared to the other algorithm. And the second one is the a priori algorithms times and space complexity are O of 2D, which is very low compared to the other ones. Let's move forward and see some hands-on lab demo. So we will see a hands-on lab demo on linear regression. As we know, linear regression is a way to find or to predict the relationship between two variables. Generally, we use x and y. So first we will open command prompt to write command to open Jupyter Notebook. So we will here write Jupyter Notebook and then press enter. So this is the landing page of Jupyter Notebook, and select open new Python file. So this is how Jupyter Notebook UI looks like. So at first we will import some major libraries of Python which will help us in mathematical functioning. So the first one is NumPy. NumPy is a Python library used for working with arrays. It also has functions for working in domains like linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. So we will write like import NumPy as NP. Here NP is used for denoting NumPy. So we will import the next library is Pandas. Pandas is a software library written for Python programming for like data manipulation and analysis. In particular, it offers data structures and operation for manipulating numerical labels and time series. So we will write import pandas as PD. Here, PD is used for denoting pandas. So our next library is matplotlib. Matplotlib is a graph plotting library in Python that serves as a visualization utility. Matplotlib is open source, so we can use it freely. And it is most written in Python, a few segments in C and JavaScript for platform compatibility. For importing matplotlib, you have to write import matplotlib dot pyplot as plt. So after importing the libraries, we will move ahead and import dataset. So for importing dataset, we have to write dataset equals to pd dot read underscore csv, and here we have to give the path of the file dataset dot csv. Here pd is for pandas library and read is used for reading the dataset from the machine, and csv is used for the type of file which you want to read. So after reading, let's see our data. So we will write dataset dot head and press enter. Here head is used for retrieving the first 5 lines from the data, so our data is coming properly. So moving ahead, now let's first define x and y axis. For x, we have to write x equals to dataset dot ilog bracket colon comma colon again -1 dot values for x axis, and for y axis we have to write y equals to dataset dot ilog bracket colon comma 1 dot values. So if we will use dataset dot ilog for -1 values for x-axis, it will select till the second last column of the data frame instead of the last column. And I know this is as the second last column value, and the last column value for the row is different. Whereas if we will use for the y-axis, values return a series vector. A vector does not have a column size. So moving ahead, let's see the value for x and y-axis. First, we will see the value for x, like just you have to write x and press enter. So these are the arrays value for x, and for y-axis you have to type y and then enter. So these are arrays value for y-axis. So after this, now let's split the dataset into training and testing. Separating data into training and testing set is an important part for evaluating data mining models. Typically, when you separate a dataset into a training set and a testing set, most of the dataset is used for training and a similar portion of dataset is used for testing. So we will split it into 70 and 30 ratio. So for splitting, we need to import some more libraries for this process. So we will write from sklearn dot model underscore selection import train underscore test underscore split. Scikit-learn, like sklearn, is most useful and robust library for machine learning in Python. It provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, and clustering. So after importing, let's write code for the splitting data. So we will write here x underscore train comma x underscore test comma y underscore train comma y underscore test equals to train underscore test underscore split. In brackets we have to write x comma y comma test underscore size equals to 0.3 comma random underscore state equals to 0. Random is with random state equals to 0, we get the same train and test sets across different execution. So after this, let's see the values together. So we will write x underscore train comma x underscore test comma y underscore train comma y underscore test. So these are the values of array x and array y together. Moving ahead, now let's work with regression. First, we need to import the library for regression. So we will use from sklearn dot linear underscore model import linear regression. We already discussed sklearn is used for machine learning and linear regression is a major part of machine learning. So after this, let's make a function for regression as reg for easy use. So we will write reg equals to linear regression and brackets. First, we try to train and then test and compare. So we will write here reg dot fit bracket x underscore train comma y underscore train. Now let's predict values, but prediction values are always different. So we will predict values for y first. So we will write y underscore predict equals to reg dot predict or x underscore test. So like y underscore predict, then enter. This is when the predict functions come into the picture. Python predict function enables us to predict the labels of the data values on the basis of training model. The predict function accepts only a single argument, which is x underscore test here, usually the data to be tested. So when you will check the value for y test, you will see the different values like y underscore test. So you can see there are totally different values from x-axis. Now let's display on graph for training dataset. So we have to write plt dot scatter x underscore train comma y underscore train comma color equals to, you can choose by yourself, I will choose red, and then plt dot plot x underscore train comma regression point for predicting values for x underscore train comma color equals to blue. So this color is for the regression line, and the plt dot title linear regression, regression salary versus experience, and I will prefer the size would be 18. So let's set the labels for x and y axis. So x label year of employee, comma size will be, I will prefer size will be 50. Then for y axis we will write here like salaries of employee, and I will prefer this same size 15. Let's show the plot by writing plt.show. Then hopefully we are fortunate, everything is going to be fine. Perfect. So you can see we have linear regression line fitting through our data set. So this is how the linear regression work for training data set. Let's see how it will work for testing data set. Now let's predict for test data set. You can copy for the same, and like you can change it. So we can copy here. So we can paste here. So we have to just change here train to test data set. Test here, then again test here, then again test here. Everything we will reduce some size to 16. Let's see, then it will use 12, and it will be 12, and so perfect. So you can see we have linear regression line fitting through our data set. So this is how the linear regression works for testing data set.
If you're looking for a course that covers everything from the fundamentals to advanced techniques, then accelerate your career in AI and machine learning with a comprehensive postgraduate program in AI and machine learning. Boost your career with this AI and ML course delivered in collaboration with the Purdue University and IBM. Learn in-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, generative AI, prompt engineering, ChatGPT, and many more. You'll receive a prestigious certificate and Ask Me Anything sessions by IBM. With 5 capstones in different domains using real datasets, you will gain practical experience. Masterclasses by Purdue faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist help you get noticed by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more such skills. Admission to this postgraduate program in AI and machine learning requires a bachelor's degree with an average of 50% or higher marks, along with the basic understanding of programming concepts and mathematics. And candidates with 2+ years of work experience are preferred to enroll in this school. So enroll now and unlock exciting AI and machine learning opportunities. The link is mentioned in the description box below.
Let's first understand what text mining is. Text mining is the technique of exploring large amounts of unstructured text data and analyzing it in order to extract patterns from the text data. It is aided by software that can identify concepts, patterns, topics, keywords, and other attributes in the data. It utilizes computational techniques to extract and summarize the high-quality information from unstructured textual resources. Let's understand the flow of text mining. There are 5 techniques used in text mining system. Information extraction or text preprocessing. This is used to examine the unstructured text by searching out the important words and finding the relationships between them. Categorization or text transformation attribute generation. Categorization technique labels the text document under one or more categories. Classification of text data is done based on input-output examples with categorization. Clustering or attribute selection. Clustering method is used to group text documents that have similar content. Clusters are the partitions, and each cluster will have a number of documents with similar content. Clustering makes sure that no document will be omitted from the search, and it derives all the documents that have similar content. Visualization technique. The process of finding relevant information is simplified by visualization technique. This technique uses text flags to represent a group of documents or a single document, and compactness is indicated using colors. Visualization technique helps to display textual information in a more attractive way. Summarization or interpretation or evaluation. Summarization technique will help to reduce the length of the document and summarize the details of the documents. It makes the document easy to read for users and understand the content at the moment. Let's understand the significance of text mining. Document clustering. Document clustering is an important part of text mining. It has many applications in knowledge management and information retrieval. Clustering makes it easy to group similar documents into meaningful groups, such as in newspapers where sections are often grouped as business, sports, politics, and so on. Pattern identification. Text mining is the process of automatically searching large amount of text for text patterns and recognition of features. Features such as telephone numbers and email addresses can be extracted using pattern matches. Product insights. Text mining helps to extract large amounts of text, for example, customer reviews about the products. Mining consumer reviews can reveal insights like most loved feature, most hated feature, improvements required, and reviews of competitors' products. Security monitoring. Text mining helps in monitoring and extracting information from news articles and reports for national security purposes. Text mining makes sure to use all of your available information. It is a more effective and productive knowledge discovery that allows you to make better informed decisions, automate information-intensive processes, gather business-critical insights, and mitigate operational risk. Let's look at the applications of text mining. Speech recognition. Speech recognition is the recognition and translation of spoken language into text and vice versa. Speech often provides valuable information about the topics, subjects, and concepts of multimedia content. Information extraction from speech is less complicated, yet more accurate and precise than multimedia content. This fact motivates content-based speech analysis for multimedia data mining and retrieval, where audio and speech processing is a key enabling technology. Spam filtering. Spam detection is an important method in which textual information contained in an email is extracted and used for discrimination. Text mining is useful in automatic detection of spam emails based on the filtering content. Using text mining, an email service provider such as Gmail or Yahoo Mail checks the content of an email, and if some malicious text is found in the mail, then that email is marked as spam and sent to the spam folder. Sentiment analysis. It is done in order to determine if a given sentence expresses positive, neutral, or negative sentiments. Sentiment analysis is one of the most popular applications of text analytics. The primary aspect of sentiment analysis includes data analysis of the body of the text for understanding the opinion expressed by it and other key factors comprising modality and mood. Usually, the process of sentiment analysis works best on text that has a subjective context than on that with only an objective context. E-commerce personalization. Text mining is used to suggest products that fit into a user's profile. Text mining is increasingly being used by e-commerce retailers to learn more about the consumers, as it is the process of analyzing textual information in order to identify patterns and gain insights. E-commerce retailers can target specific individuals or segments with personalized offers and discounts to boost sales and increase customer loyalty by identifying customer purchase patterns and opinions on particular products. Let's look at Natural Language Toolkit library in detail. Natural Language Toolkit is a set of open-source Python models that are used to apply statistical natural language processing on human language data. Let's see how you can do environment setup of NLTK. Go to Windows Start and launch Python Interpreter from Anaconda prompt and enter the following commands. Enter command Python to check the version of Python installed on your system. Enter import NLTK to link you to the NLTK library available to download. Then enter NLTK.download function that will open the NLTK download window. Check the download directory, select all packages, and click on Download. This will download NLTK onto your Python. Once you have downloaded the NLTK, you must check the working and functionality of it. In order to test the setup, enter the following command in Python idle. From nltk.corpus import brown, brown.word parenthesis parenthesis. The brown is an NLTK corpus that shows the systematic difference between different genres available. Words function will give you the list available words in the genre. The given output shows that we have successfully tested the NLTK installed on Python. Let's now understand how you can read a specific module from NLTK corpora. If you want to import an entire module from NLTK corpora, use asterisk symbol with that module name import command. Enter the command from nltk.book import asterisk. It will load all the items available in NLTK's book module. Now, in order to explore brown corpus, enter the command nltk.corpus import brown. This will import brown corpus on the Python. Enter brown.categories function to load the different genres available. Select a genre and assign that genre to a variable using the following syntax. Variable name is equal to brown.words. Categories is equal to genre name. Now, in order to see the available words inside the selected genre, just enter the defined variable name as a command. Let's understand text extraction and pre-processing in detail. So let's first understand the concept of tokenization. Tokenization is the process of removing sensitive data and placing unique symbols of identification in that place in order to retain all the essential information concerned with the data by its security. It is a process of breaking running streams of text into words and sentences. It works by segregating words using punctuation and spaces. Text extraction and pre-processing engrams. Now let's look at what engram is and how it is helpful in text mining. Engram is the simplest model that assigns these probabilities to sequences of words or sentences. Engrams are combinations of adjacent words or letters of length n in the source text. So engram is very helpful in text mining when it is required to extract patterns from the text. As in the given example, this is a sentence. All of these words are considered individual words and thus represent unigrams. A 2-gram or bigram is a two-word sequence of words like this is a, or a sentence, and a 3-gram or trigram is a three-word sequence of words like this is a, or is a sentence. Let's now understand what stop words are and how you can remove them. Stop words are natural language words that have negligible meaning, such as a, an, and, or, the, and other similar words. These words also will take up space in the database or increase the processing time, so it is better to remove such words by storing a list of stop words. You can find the list of stop words in the NLTK data directory that is stored in 16 different languages. Use the following command to list the stop words of English language defined in NLTK corpus. Importing NLTK will import the NLTK corpus for that instance. Enter from nltk.corpus import. Stop words will import stop words from NLTK corpus. Now set the language as English, so use set function as set under braces stop words dot words. Set genre as English. Stop words are filtered out before processing of natural language data, as they don't reveal much information. So as you can see in the given example, before filtering the sentence, the tokenization of stop word is processed in order to remove these stop words, and the filtering is applied in order to filter the sentence based on some criteria. Text extraction and pre-processing stemming. Stemming is used to reduce a word to stem or base word by removing suffixes such as helps, helping, helped, and helper to the root word help. The stemming process or algorithm is generally called a stemmer. There are various stemming algorithms such as Porter stemmer, Lancaster stemmer, Snowball stemmer, etc. Use any of the stemmers defined under NLTK stem corpus in order to perform stemming as shown in the example. Here we have used Porter stemmer. When you observe the output, you will see that all of the words given have been reduced to their root word or stem. Text extraction and pre-processing lemmatization. Lemmatization is the method of grouping the various inflected types of a word in order that they can be analyzed as one item. It uses vocabulary list or morphological analysis to get the root word. It uses WordNet database that has English words linked together by their semantic relationship. As you can observe, the given example, the different words have been extracted to their relevant morphological word using lemmatization. Text extraction and pre-processing POS tagging. Let's now look at different part-of-speech tags available in the National Language Toolkit library. A POS tag is a special label assigned to each token or word in a text corpus to indicate the part of speech and often also other grammatical categories such as tense, number, either plural or singular, case, etc. POS tags are used in text analysis tools and algorithms and also in corpus searches. So look at the given example. Here, Alice wrote a program is the source text given. The POS tags given are Alice is a noun, wrote is a verb, a is an article, and program is an adjective. Look at the given example to understand how POS tags are defined. So the given sentence or paragraph contains different words that represent different parts of speech. We will first use tokenization and removal of stop words, and then allocate the different POS tags. These are shown with different words in the given sentence. POS tags are useful for lemmatization in building named entity recognition and extracting relationships between words. Text extraction and pre-processing named entity recognition. Now let's understand what named entity recognition is all about. NER seeks to extract a real-world entity from the text and sorts it into predefined categories, such as names of people, organizations, locations, etc. Many real-world questions can be answered with the help of name entity recognition. Were specified products mentioned in complaints or reviews? Does the tweet contain the name of a person? Does the tweet contain the person's address? As you can see in the given example, Google, America, Larry, Page, etc. are the names of a person, place, or an organization. So these are considered named entities and have different tags such as person, organization, GPE, or geopolitical entity, etc. NLP process workflow. Now you have an understanding of all NLTK tools. So now let's understand the natural language processing workflow. Step 1, tokenization. It splits text into pieces, tokens, or words and removes punctuation. Step 2, stop word removal. It removes commonly used words such as the, is, are, etc., which are not relevant to the analysis. Step 3, stemming and lemmatization. It reduces words to base form in order to be analyzed as a single item. Step 4, POS tagging. It tags words to be part of speech such as noun, verb, adjective, etc. based on the definition and context. Step 5, information retrieval. It extracts relevant information from the source. Demo 1, Brown Corpus. Problem statement. The Brown University Standard Corpus of Present-Day American English, also known popularly as Brown Corpus, was compiled in the 1960s as a general corpus in the field of corpus linguistics. It contains 500 samples of English language text, totaling roughly 1 million words, compiled from works published in the United States in 1961. We will be working on one of the subset dataset and perform text processing tasks. Let us import the NLTK library and read the CA_10 corpus. Import NLTK. We will have to make sure that there are no slashes in between. Hence, we will use the replace function within pandas for the same. Let's have a look at the data once. Tokenization. After performing sentence tokenization on the data we obtain, similarly, after applying Sentence Tokenizer, the resulting output shows all individual words, tokens. Stop word removal. Let's import the stop word library. From nltk.corpus, import stop words. We also need to ensure that the text is in the same case. NLTK has its own list of stop words. We can check the list of stop words using stopwords.words and English inside the parenthesis. Map the lowercase string with our list of word tokens. Let's remove the stop words using the English stop words list in NLTK. We will be using set checking as it is faster in Python than a list. By removing all stop words from the text, we obtain Often we want to remove the punctuations from the documents too. Since Python comes with batteries included, we have string.punctuation. From string, import punctuation. Combining the punctuation with the stop words from NLTK. Removing stop words with punctuation. Stemming and lemmatization. We will be using stemming and lemmatization to reduce words to their root form. For example, walks, walking, walked will be reduced to their root word walk. Importing Porter Stemmer as the stemming library. From nltk.stem, import Porter Stemmer. Printing the stem words. Import the WordNet lemmatizer from nltk.stem. Printing the root words. We also need to evaluate the POS tags for each token. Create a new word list and store the list of word tokens against each of the sentence tokens in Data 2. For I in tokenized, also, we will check if there were any stop words in the recently created word list. We will now tag the word tokens accordingly using the POS tags and print the tagged output. For our final text processing task, we will be applying named entity recognition to classify named entities in text into predefined categories such as the names of persons, organizations, locations, expressions of times, quantities, monetary values, percentages, etc. Now press the tagged sentences under the chunk parser. If we set the parameter binary equals true, then named entities are just tagged as NE. Otherwise, the classifier adds category labels such as person, organization, and GPE. Create a function named as extract entity names along with an empty list named as entity names. We will now extract named entities from a NLTK chunked expression and store them in the empty created above. Again, we will set the entity names list as an empty list and will extract the entity names by iterating over each tree in chunked sentences. Great, we have seen how to explore and examine the corpus using text processing techniques. Let's quickly recap the steps we've covered so far. 1. Import the NLTK library. 2. Perform tokenization. 3. Perform stemming and lemmatization. 4. Remove stop words. 5. Perform named entity recognition. Structuring sentences, syntax. Let's first understand what syntax is. Syntax is the grammatical structure of sentences. In the given example, this can be interpreted as syntax, and it is similar to the ones you use while writing codes. Knowing a language includes the power to construct phrases and sentences out of morphemes and words. The part of the grammar that represents a speaker's knowledge of these structures and their formation is called syntax. Phrase structure rules are rules that determine what goes into a phrase, that is, constituents of a phrase, and how the constituents are ordered. Constituent is a word or group of words that operate as a unit and can be used to frame larger grammatical units. The given diagram represents that a noun phrase is determined when a noun is combined with a determiner, and the determiner can be optional. A sentence is determined when a noun phrase is combined with a verb phrase. A verb phrase is determined when a verb is combined optionally with the noun phrase and prepositional phrase. And a prepositional phrase is determined when a preposition is combined with a noun phrase. A tree is a representation of syntactic structure of formulation of sentences or strings. Consider the given sentence. The factory employs 12.8% of Bradford County. What can be the syntax for pairing this statement? Let's understand this. A tree is produced that might help you understand that the subject of the sentence is the factory. The predicate is employs, and the target is 12.8%, which in turn is modified by Bradford County. Syntax parses are often a first step toward deep information extraction or semantic understanding of text. Rendering syntax trees. Download the corresponding .exe file to install the Ghost script rendering engine based on your system configuration in order to render syntax trees in your notebook. Let's understand how you can set up the environment variable. Once you have downloaded and installed the file, go to the folder where it is installed and copy the path of the file. Now go to System Properties, and under Advanced Properties, you will find the Environment Variable button. Click on that to open the pop-up box tab of the environment. Now open the bin folder and add the path to the bin folder in your environment variables. Now you will have to modify the path of the environment variable. Use the given code to test the working of syntax tree after the setup is successfully installed. Structuring sentences, chunking and chunk parsing. The process of extraction of phrases from unstructured text is called chunking. Instead of using just simple tokens which may not represent the actual meaning of the text, it is advisable to use phrases such as Indian team as a single word instead of Indian and team as separate words. The chunking segmentation refers to identifying tokens, and labeling refers to identifying the correct tag. These chunks correspond to mixed patterns in some way. To extract patterns from chunks, we need chunk parsing. The chunk parsing segment refers to identifying strings of tokens, and labeling refers to identifying the correct chunk type. Let's look at the given example. You can see here that yellow is an adjective, dog is a noun, and the is the determiner, which are chunked together into a noun phrase. Similarly, chunk parsing is used to extract patterns and to process such patterns from multiple chunks while using different parsers. Let's take an example and try to understand how chunking is performed in Python. Let's consider the sentence, "The little mouse ate the fresh cheese," assigned to a variable named cent. Using the word tokenize function under NLTK corpora, you can find out the different tags associated with the sentence provided. So as you can see in the output, different tags have been allocated against each of the words from the given sentence using chunking. NP chunk and parser. You will now create grammar from a noun phrase and will mention the tags you want in your chunk phrase within the function. Here you have created a regular expression matching the string. The given regular expression indicates optional determiner followed by optional number of adjective followed by a noun. You will now have to parse the chunk. Therefore, you will create a chunk parser and pass your noun phrase string to it. The parser is now ready. You will use the parse parenthesis within your chunk parser to parse your sentence. The sentence provided is, "The little mouse ate the fresh cheese." This sentence has been parsed and the tokens that match the regular expressions are chunked together into noun phrases, NP. Create a verb phrase chunk using regular expressions. The regular expression has been defined as optional personal pronoun followed by 0 or more verbs with any of its type followed by any type of adverb. You'll now create another chunk parser and pass the verb phrase string to it. Create another sentence and tokenize it. Add POS tags to it. So the new sentence is, "She is walking quickly to the mall," and the POS tag has been allocated from NLTK corpora. Now use the new verb phrase parser to parse the tokens and run the results. You can look at the given tree diagram, which shows a verb parser where a pronoun followed by two verbs and an adverb are chunked together into a verb parse. Structuring sentences, chinking. Chinking is the process of removing a sequence of tokens from a chunk. How does chunking work? The whole chunk is removed when the sequence of tokens spans an entire chunk. If the sequence is at the start or the end of the chunk, the tokens are removed from the start and end, and a smaller chunk is retained. If the sequence of tokens appears in the middle of the chunk, these tokens are removed, leaving two chunks where there was only one before. Consider you create a chinking grammar string containing three things: chunk name, the regular expression sequence of a chunk, the regular expression sequence of your chink. Here in the given code, we have the chunk regular expression as optional personal pronoun, followed by 0 or more occurrences of any type of the verb type followed by 0 or more occurrences of any of the adverb types. The chink regular expression says that it needs to check for the adverb in the extracted chunk and remove it from the chunk. Inside the chinking block with open curly braces and closing curly braces, you have created one or more adverbs. You will now create a parser from NLTK.regexp parser and pass the chink grammar to it. Now use the new chink parser to parse the tokens cent3 and run the results. As you can see, the parse tree is generated. While comparing the syntax tree of the chink parser with that of the original chunk, you can see that the token is quickly, adverb, chinked out of the chunk. Let's understand how to use context-free grammar. A context-free grammar is a four-tuple sum ntrs where sum is an alphabet and each character in sum is called a terminal. Nt is a set and each element in Nt is called a non-terminal. R, the set of rules, is a subset of NT times the set of sum U and T. S, the start symbol, is one of the symbols in NT. A context-free grammar generates a language L capturing constituency and ordering. In CFG, the start symbol is used to derive the string. You can derive the string by repeatedly replacing a non-terminal on the right-hand side of the production until all non-terminals have been replaced by terminal symbols. Let's understand the representation of context-free grammar through an example in context-free grammar. A sentence can be represented as a noun phrase followed by a verb phrase. Noun phrase can be a determiner, nominal. A nominal can be a noun. VP represents the verb phrase. A can be called a determiner. Flight can be called a noun. Consider the string below where you have certain rules. When you look at the given context-free grammar, a sentence should have a noun phrase followed by a verb phrase. A verb phrase is a verb followed by a noun. A verb can either be saw or met. Noun phrases can either be John or Jim, and a noun can either be a dog or a cat. Check the possible list of sentences that can be generated using the rules. Use the join function to create the possible list of sentences. You can check the different rules of grammar for sentence formation using the production function. It will show you the different tags used and the defined context-free grammar for the given sentence. Demo 2. Structuring sentences. Problem statement. A company wants to perform text analysis for one of its data sets. You are provided with this data set named tweets.csv, which has tweets of 6 U.S. airlines along with their sentiments, positive, negative, and neutral. The tweets are present in the text column and sentiments in airline_sentiment column. We will be retrieving all tags starting with @ in the dataset and save the output in a file called references.txt. Let us first import the pandas library and read the tweets dataset. Extract the features, text, and airline sentiment. We will iterate through the dataset using regex. Find the relevant tweets. Now we will import the itertools module. It returns efficient iterators. The result is stored in a file named references.txt. Let's extract all noun phrases and save them in a file named noun phrases for left_airline_sentiment right_review.txt. Here, left caret airline underscore sentiment right caret has 3 different values, positive, negative, and neutral, so 3 files will be created. Now we will iterate all the leaf nodes and assign them to noun phrases variable. This means that the functions in itertools operate on iterators to produce more complex iterators. Using the map function, we will get all the noun phrases from the text. Putting it into list. Creating a file name in the name of review.txt.
In a world where email is crucial, spam messages plague our inboxes, disrupting our digital lives. But fear not, a hero emerges, the email spam classifier. This intelligent system learns from past encounters, uncovering the tricks employed by spammers. Deceitful subject lines, promising riches, unreasonable low prices. It spots signs like excessive capital letters, misspellings, and suspicious URLs. Yet the battle doesn't end here. Spammers constantly evolve their tactics. But the email spam classifier doesn't flinch. It adapts, refining its knowledge and staying up to date with the latest tricks. Every new spam email it encounters, it provides insights, enhancing its accuracy and ensuring our protection. Thanks to dedicated minds and AI and ML power, the fight against email spam continues. The email spam classifier stands as our faithful guardian, a symbol of technology's victory over digital adversaries. It reclaims our inboxes and restores order to our virtual world. According to recent studies, AI and machine learning related job postings have increased by a staggering 344% in the past 5 years. Companies across the globe are actively seeking professionals who can harness the power of data and build intelligent systems. The average salary is $150,000 in the US and 15 lakhs per annum in India. Accelerate your career in AI and machine learning with our comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and hackathons and Ask Me Anything sessions by IBM. With 3 capstones and 25 plus industry projects using real data sets from Twitter, Uber, and more, you will gain practical experience, master classes by Purdue faculty, and IBM experts ensure top-notch education. Simplilearn's Job Assist help you notice by leading companies, live sessions on AI trends like ChatGPT, Generative AI, and Explainable AI. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The link is mentioned in the description box below. Let's take a minute to hear from our learners who have experienced massive success in their careers.
You need to keep updating your skills on a regular basis, no matter what level you're at. I recently completed the professional certificate program in AI and machine learning from Simplilearn in partnership with Purdue University. The course material was comprehensive and the faculty was extremely experienced. The faculty was able to adjust their teaching style in order to cater to the overall skill set of the class. In the rapidly evolving world of technology, it's important to keep upskilling for every working professional. Stay relevant, continue.
With that having said, hey everyone, welcome to Simplilearn's YouTube channel. But before we dive into that, don't forget to like, subscribe and share. And now over to our training experts.
So hello and welcome to this new video by Simplilearn, email spam classifier. Okay, so first we will change this name to email spam classifier. Okay, let's rename it. So first what we're gonna do, we will import some libraries, then the main libraries like NumPy, Pandas, Sklearn, and logistic regression algorithm, and then we will move on to this importing of data set of spam mail and ham mail. Ham is known as like which is not spam. Okay, so we will do some categorization of spam email and ham email. Then we will split into the training test and the testing of the data set. Okay, then we will transform the text data to feature vectors that can be used as input to the logistic regression, and then we will convert the void train and the void test values as integers. And then moving forward, we will see the features, the model extractions, and then we will train the model using logistic regression. And after that, we will predict the accuracy, how much the training data is giving, how much the testing data is giving, and at the end we will build a predictive system which will tell whether a particular email is spam or not spam. Okay, cool. So let's move on to the coding part then. Okay, so first I will import some major libraries like import NumPy as NP. Okay, then NumPy. So NumPy is a powerful Python library for numerical computing. So it stands for numerical Python and provides support for efficient array operations and mathematical function, linear algebra, random number generation, and more. With NumPy, you can work with a multi-dimensional array known as ND arrays. And these arrays are highly optimized for performance and allow you to perform mathematical and logical operations on large dataset efficiently. So NumPy provides a wide range of functions and methods to manipulate and analyze these arrays. And the second one is import pandas as PD. Okay, this PD and NP is nothing. We don't want to write again and again pandas and NumPy. So what is pandas? So pandas is a powerful Python library used for data manipulation and analysis. It provides easy to use data structure and data analysis tool, making it essential tool for working with structured data. So the third one is scikit-learn. Okay, so I will write here from. Okay, I will will write here from sklearn dot model selection import train test split. Okay, so what is sklearn model selection and the train test split? So sklearn or scikit-learn is a popular Python library for machine learning. It provides a wide range of tools and algorithms for various machine learning tasks, including classification, regression, and that clustering, dimensional reduction, and the model evaluation. Okay, and this train test split, this one. So the train test split function is a utility in scikit-learn that helps in splitting the dataset into training and the testing subset. Later we will split the data into training and the testing. So this function is commonly used in machine learning tasks to assess the performance of a model on unseen data. Okay, so move on to the next algorithm. We will write here from sklearn dot feature extraction dot text import tfid vectorizer. Okay, so what is tfid vectorizer? So tfid vectorizer is a feature of extraction technique commonly used in natural language processing NLP and text mining tasks. So it is a part of scikit-learn library in Python. So tfid vectorizer transforms a collection of text documents into a numerical representation that machine learning algorithm can work with. Okay, so move on to, we will import from sklearn dot linear model import logistic regression. Okay, so what is logistic regression? So logistic regression is a popular classification algorithm used in machine learning. It is a part of the scikit-learn library in Python. Logistic learn and the regression is suitable for binary classification problems where the target variable has the two classes. Okay, and the last we will import accuracy score. Okay, so here I will write from sklearn dot matrix import accuracy score. Okay, so let me tell you first what is accuracy score. The accuracy score function is a performance metric provided by the scikit-learn library in Python. It is commonly used to evaluate the performance of a classification model by measuring the accuracy of the predictions. Okay, so let me run it. Okay, there is some error, maybe the spelling mistake. Okay, what I will do, I will write it again. Running it again. Yeah, it's working. So now what I will do, I will import the data set. So I will write here df equals to data frame equals to pd dot read underscore csv mail underscore data dot csv. You can find this dataset link in the description box below. Okay, I will run it. Yeah, so let's see the data frame, what's in it for us. So as you can see, here is category, then message. So these are the, the mails. Ham means not spam and spam is spam. Okay, those mails which are not spam known as ham. So there are two columns, 5, 5, 7, 2 rows. So moving forward, what I will do, I will convert this mail data, okay, to not null. So I will write here data equals to raw, not raw, data equals to df dot where pd dot not null is df. Okay, then some space. Okay, let me give you some spaces for the better visual. Yeah, so now I will print data dot head. So what is the meaning of head here? Head means if you want to print the top 5 lines of the particular data set, it is you can use the head. And if you want to print the last 5 rows of the data set, so you can use the tail instead. If you will write here 10 instead of giving it blank, then run it, so it will give you the top 10 rows of the particular data set. Okay, so these are the spam mail, this ham mails. So later on what we will do, we will train this data set using this particular data set. Okay, so let's move on to and see the info, okay, of the data set. So data dot info. So info, you can see there are columns, this null count, this data type. So there are 2 columns like category and the message, and the particular rows are the 5572 on the both, and the data type is object. Okay, see the memory usage and you can see everything. And there is one more, you can see the data shape is 5572 comma 2. These are the rows and these are the columns, 2 columns and 5572 rows. Okay, so now what I will do, I will assign the category to spam, am and ham mail. Okay, so what I will do here, I will write here data dot loc, then data versus category equals to spam comma category, okay, comma equals to 0. So if the 0 will show, it is known as the spam, and if 1 will show, it is known as the ham mail. Okay, I will write here data dot loc location and data, then category equals to ham, then category will be 1. Okay, then let me run it. Okay, it's running smoothly. So I will write here x equals to data, then message, okay, and the y value will be equals to main, so not main, data, then category. Okay, then let me run it. So now what I will do first, so now what I will do, I will write here print x. Okay, so these are only the messages, and category print y. So now as you can see 1 1 0 1 1 0. So here 0 means, what is the 0 means? 0 means spam, and the 1 means it's ham mail. Okay, so moving forward, what I will do, I will split this data set into testing and the training. Okay, so I will write here x train, this is the most important part, and the x test. Okay, then y train, then y test. Okay, equals to train test split x comma y comma test size equals to 0.2, then random state equals to 3. Okay, I will run it. So this is x train for the training set and x test is the testing. Okay, then the same y, you know the what is the x and y here, and here we are splitting using train test split, then x comma y test size is equal to 0.2. okay, 0.2 means it will be 80 and 20%, and 80% will be training and the testing will be 20%. Okay, we will train data, 80% of data using this data set will be trained, and for the test the 20% will data. Okay, the random state equals to 3, and the random state is a hyperparameter used to control any such randomness involved in machine learning model to get consistent result. Okay, when splitting a data set, splitting a node in a decision tree or a logistic regression, initializing centroids in clustering takes place. So that is why we use random state. Okay, so let me run it. It's working fine. So now I will show print x dot shape. Okay, then print x underscore train dot shape. I will show you about I'm talking about the test size now. Print x underscore test dot shape. Now see carefully. Okay, this x will be in capital. So as you can see, total rows are 5572. Total row of 80% is 4457, or else you can calculate, and the 20% is for the testing is the 11115. Same goes for the y. So moving forward, okay, let me show you for the y also. So I will copy and paste it here. So it's y. See, same goes for the y also. Okay, so now what I will do here, I will transform the text data to feature vectors that can be used as input to the logistic regression. So feature extraction equals to tfid vectorizer. Okay, the minimum difference will be 1 comma stop words stop words equals to English and the lowercase equals to true. Okay, here I am transforming the test data to the feature vector, and okay, so here x, okay, let me tell you. So this is a feature extraction. We are using tfid vectorizer. Okay, we have import here, as you can see, for the feature extraction of the text, and this is the minimum difference equal to 1. And what is the stop word? The stop words are the English words which does not add much meaning to the sentence. They can safely be ignored without sacrificing the meaning of the sentence. Okay, like for example, you can see the words like the, he, have, such words already computerized, and the captured, this is a corpus name and the corpus. Okay, and this lowercase equals to true. So here I will write x train features equals to feature extraction dot fit transform x underscore train x underscore test features equals to feature extraction dot transform to the x test. Okay, yeah. So moving forward, I will convert y train and y test values as an integer. Okay, y train, because they are 0 1 0 1 0, train equals to y train dot as type int. Okay, then y test equals to y test dot as type int. So okay, so there is spelling mistake. We'll copy from here, paste it here. Okay, then I will run it. Okay, y test it is. Yeah, it's running. So now what I will do, I will print the x train as you can see, the x train. So these are the messages, and if I will print x train features, we created here na, see x train features. Okay, then you can see, so these are the features accuracy. Okay, so 0 0 0 means spam, 1 1 means ham. Okay, so moving forward, what I will do, I will now train the model. Okay, logistic regression. So I will write here model equals to, okay, logistic regression. So now we will train the model. So here I will write model equals to logistic regression. Okay, so we don't want to write again and again logistic regression, so I am here assigning model to it. So let me run it. So here I will train the logistic regression model with the training data. So here I will write model dot fit x train features comma y train. Okay, here we are training the logistic regression model with the training data. Let me run it. Yeah, fine, it's running fine. So moving forward, we will do the evaluating of the train model and the prediction of the training data. So for that I will write here prediction on training data equals to model dot predict x train features. Okay, then I will write here accuracy on training data equals to accuracy score y train comma prediction. Okay, I will write from here prediction on the training data. Okay, let me run it. So now we will see the prediction. So I will write here prediction, or simply I will write print accuracy on training data comma. Okay, I will copy it, leave it. accuracy on training data. Okay, let me run this. So as you can see, accuracy on training data is 0.96, means almost 97%, which is not bad, very good. Okay, we will see print. Okay, now we have to do for the testing data. This is for the training data, and let's see the accuracy for the testing data. So for that, I will add same prediction on test data equals to model dot predict x test features. Okay, then accuracy on test data equals to accuracy score, then y test comma prediction on test data. Okay, I'll run it. Okay, accuracy score. So here I will write print the accuracy on test data. Okay, comma, then I will write accuracy on test data. Okay, so as you can see, the accuracy on test data is almost same as the training data. Okay, almost 95%, 97%, sorry. So now what we will do, we will build a predictive system now. Okay, so I will write here like input. Okay, you have to input the mail here, then okay, we will input later, and we will now write the line for the convert text to feature vector. So for that I will write here input data features equals to feature extraction dot transform input. Okay, this is a function, so I will write here input your main input your mail. Okay, so here we will make the prediction. Okay, I will write the prediction equals to model dot predict input data features. Okay, so I have some spam mails with myself, so I will try to copy them, and let's see. Okay, I have some mails, so I will copy it. Okay, and I will paste it here. Okay, this is the second time we have tried to contact you. You have won this. These type of mails are spam actually, like you also know. So I will try to run it. Let me run it. Okay, I forgot to write print prediction. Okay, so 0. So here, as you can see, already 0 means spam. Okay, so this is a spam mail. Actually, this is a spam mail. So okay, wait, let me write here. If prediction is showing 0 equals to true, then print it to ham mail and else then print spam mail. Okay, the prediction will be 0 is not equals to 1. Okay, so it will show the ham mail or else the spam mail. It's simple, pretty simple. See, 0 spam mail. Okay, I will try to put here one ham mail. Okay, let me copy it and paste it here. Okay, let me delete this quickly. Okay, let me run this. So it is showing ham mail, means not spam. So quickly let me run one more spam mail. Okay, let me copy this and paste it here. You can try with your own own email with your got. Okay, so let me run this. So it is a spam mail. Okay, see, you can see you have been selected to stay like marketing. Okay, see in so these type of mails are like, you know, deals and the vouchers. This type of mails are known as the spam mails. See, holiday value, this, dial this and this. Okay, so here we have done with our email spam classifier. As you can see, if you want this code, so you can comment down below.
If you're looking for a course that covers everything from the fundamentals to advanced techniques, then accelerate your career in AI and machine learning with a comprehensive postgraduate program in AI and machine learning. Boost your career with this AI and ML course delivered in collaboration with the Purdue University and IBM. Learn in-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, generative AI, prompt engineering, ChatGPT, and many more. You'll receive a prestigious certificate and Ask Me Anything sessions by IBM. With 5 capstones in different domains using real datasets, you will gain practical experience. Masterclasses by Purdue faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist help you get noticed by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more such skills. Admission to this postgraduate program in AI and machine learning requires a bachelor's degree with an average of 50% or higher marks, along with the basic understanding of programming concepts and mathematics. And candidates with 2+ years of work experience are preferred to enroll in this course. So enroll now and unlock exciting AI and machine learning opportunities. The link is mentioned in the description box below.
We will take you through the hands-on lab demo of how you can do the sentimental analysis of Amazon customer reviews. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. Let's wait for some more minutes to let other people join. Let's wait for some more minutes to let other people join. Let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek on a continuous hunt for the latest technological trends, then consider subscribing to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Great, I think we can get started. So in today's session, we will go through the what is sentimental analysis. After that, we will see types of sentimental analysis. We will see some application of sentiment analysis, and at the end, we will see hands-on lab demo like how to implement sentiment analysis using Python in detail. We already have Amazon customer dataset with us. We will perform different function and analyze data for sentiment analysis using Python. You can download dataset from the description box below. So before we move on the programming part, let's discuss what is sentiment analysis actually is and proceed further for the same. Sentiment analysis, sometimes known as opinion mining, is a technique used in natural language processing (NLP) to determine the emotional undertone of a document. This is a common method used by organizations to identify and group ideas regarding a certain good, service, or concept. Text is mined for sentiment and subjective information using data mining, machine learning, and artificial intelligence. Tools for sentiment analysis assist businesses in extracting information from unstructured, unorganized language found in online sources like emails, blog posts, support tickets, web chats, forums, and comments. Algorithms use rule based, automatic, or hybrid technology to replace manual data processing. While automatic systems use machine learning to learn from their data, rule based systems execute sentiment analysis using predetermined. Lexicon based rules combining the two methods result in hybrid sentiment analysis. Sentiment analysis or opinion mining can extract the subject, opinion holder, and polarity or the degree of positivity and negative from the text and identify sentiment. Additionally, other scopes including document, paragraph, sentence, and sub-sentence level can be used for sentiment analysis. After seeing what is sentiment analysis, let's discuss some types of sentiment analysis. So the first one is fine-grained sentiment analysis. By segmenting sentiment, each phrase or clause in a sentence is broken down and examined in relationship to the others. Simply said, you can tell who review a product and what topics a person specifically discuss in their feedback. And the second one is emotion detection. Instead of identifying positivity and negativity, emotion detection recognizes particular emotions. Example could include shock, rage, grief, frustration, and happiness. And the third one is intent based analysis. In addition to identify opinions in a text, the intent based analysis also identifies behaviors. For instance, a frustrated online comment about changing a battery can motivate customer care to get in touch to address that particular problem. And the last one is expect based analysis. Collects the precise component that is being mentioned either favorably or unfavorably. For instance, a client may write in a product review that the battery life is too short. The system will then respond that the battery life is the main complaint and not the product as a whole. So after seeing types of sentiment analysis, let's see some application of sentiment analysis. Organization can employ sentiment analysis technologies for a number of purposes such as determining brand popularity, reputation, and awareness at a particular period or over time. Customer service requests into categories. And the next one is monitoring consumer response to new improvements or products. And the fourth one is identifying the demographics or target market. And the fifth one is determining the effectiveness of a marketing effort. So here is one question for you guys. I will give you 1 minute for this. You can comment or you can give answers in chat section, so I can see if the answers given by you are right or wrong. So the question is text analytics also refers to as text mining? I'm repeating again. Is text analytics also refers to as text mining? The options are true or false. So let us know your answer in comment section below or in chat section. So I'm starting timer of 1 minute. Just type your answer in comment section or in chat section. Do let me know your answers. So I'm starting timer of 1 minute. I kindly ask that everyone take part in this to make this live session exciting. So the question is text analytics also refers to as text mining? 35 seconds are left. Do let me know your answers. I kindly ask that everyone take part in this to make the live session exciting. Do one 20 seconds left. You can comment or you can give your answer in chat section so I can see if the answers given by you are right or wrong. So time up, guys. So after the allotted time has passed, those who provided the correct response will receive a response, and those who provided the incorrect response will receive one. Okay. Now let's move to our programming part to perform sentiment analysis using Amazon customer dataset. So first we will open command prompt to write command to open Jupyter notebook. So here we will write Jupyter notebook, press enter. Okay, it's Jupyter notebook. So this is the landing page of Jupyter notebook, and here you can select new Python file. It's loading. So this is how the Jupyter UI looks like. So at first we will import some bunch of major libraries of Python which will help us in mathematical functioning. So the first one is NumPy. So first I will write NumPy, import NumPy as NP. NumPy is a Python library used for working with arrays. It also has functions for working in the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. So the next one is pandas. I will write here import pandas as PD. So pandas is a software library written for a Python programming language for data manipulation and analysis. In particular, it offers data structures and operation for manipulating numerical tables and time series. After that, we will import NLTK. So the Natural Language Toolkit NLTK is a Python programming environment for creating application for statistical natural language processing NLP for parsing, classification, stemming, tagging and semantic reasoning. It includes text processing libraries. So after that we will import from NLTK dot sentiment dot wader import sentiment density analyzer. Okay, there is no colon. Yeah. So the lexicon and rule-based sentiment analysis tool Wader. Wader means valence aware dictionary and essential reasoning. Is a customized precisely to sentiments expressed on social media. Wader makes use of variety of a sentiment lexicon is a collection of lexical elements such as words that are often classified as either positive or negative depending on their semantic orientation. Wader not only informs us of the positivity and negativity scores, but also of the sentimentally of each score. So the next one is import RE. Python RE module fully supports regular expression similar to those in Perl. If a regular expression, compilation or use error occurs, the RE modules raises the expression RE. Two key functions that are used to manage regular expression will be covered. So RE means regular expressions. So the next one is from text blob, import text blob. Okay, so a Python 2 or 3 package called text blob is used to process textual data. It offers a straightforward API to explore typical natural language processing (NLP) tasks like part of speech tagging, noun phrase extraction, sentiment analysis, classification, translation, and more. So the next one is import words from word cloud. A word cloud, commonly refers to as a tag cloud, is an image of words. Popular words and phrases are highlighted using cloud creators depending on their frequency and importance. They give you immediate, straightforward visual insights that can inspire more through analysis. And the next one is import Seaborn as SNS. Yeah. So, like an open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization, where data frames and the pandas library Seaborn function with ease. So the next one is import matplotlib dot pyplot as plt. Okay, yeah, seems good. For Python and its numerical expression NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it presents a strong open source substitute for MATLAB. The APIs for Matplotlib allow programmers to incorporate graphs into GUI applications. And the next one is import cufflinks cufflinks as CF. Perfect. Another Python module called cufflink links Plotly with pandas so that charts can be easily created on data frames. In essence, it functions like a plugin. So next in line matplotlib. Matplotlib. So you can enable inline plotting by using the magic function percentage matplotlib inline, which causes the plots and graphs to appear below the cell where your plotting commands are entered. Similar to a Jupyter notebook, it offers backend interactivity in front ends. So next we will import what you can like. We can import, okay, from plotly dot offline import init underscore notebook underscore mode comma a plot. Okay. Init underscore notebook mode true. Okay, it's true. Yeah. Ef dot go underscore offline. So yeah, in order to display the plot inside the notebook, you need to initiate plotly notebook mode as follows, like this. Keep rest of the script as it is like it and run the notebook cell by pressing you can shift plus enter. Graph will be displayed offline inside the notebook. So basically it is used for the offline graphing, you can say. Okay. So next we will import from plotly dot subplots. Subplots are important. Import make underscore subplot. Okay, yeah. The non-leaf nodes in this figure schema are represented by a hierarchy of Python classes that was automatically constructed and is found in the plotly.graph objects, which is normally imported as Go. These class instances are referred to as graph object, the plotly defined fundamental classes. Okay. So here we will import some like warnings, you can say, like to get not error. So we will import, let me give a line space, import warnings, yeah, warnings dot filter warning ignore warnings dot warn, and this like will not show. And let me add something, pd dot set option display dot max underscore columns. Okay, import words from word cloud. Okay, there is an error. Let me check. What's the error? Okay. Import this word cloud from word cloud. It's capital. And W is also capital. Here W will be capital. Let it put it small only. From word cloud. Okay, my bad. Here word from word cloud. From word cloud. Import word cloud. Okay. Yeah, seems good. So where were we? Yeah, in warnings. Despite the notification, the software continues to execute. To display warning messages, utilize the warn found in the warning module. The Python built-in class expression is a subclass of the warning module, which is used to display warning messages, import warnings. Okay. For seeing full data, every single columns like, okay, there is error, cborn. No module as cborn. So S will be small. Got it? Okay, inline is only like something like that. Inline. Okay, any error now? I guess no error. Okay. Yeah, for seeing full data like every single columns of PD. So here we are using this pd.set option. So we can use for it. So moving forward, let's import dataset. So for importing dataset, we will write here like df equals to pd dot read csv. Okay. A dataset name. Yeah. So So you can download dataset from the description box below. So no worries for that. So let me run this. Okay. So like here is PD is for pandas library. Read is used for reading the dataset from the machine, and CSV is used for the type of file which you want to read. So let's see our data. So here I will write df dot head. Yeah. So if you want to see top 5 rows of your data set, you can use head. And if you want to see 5 rows of your data set, you can use tail instead of head. This one. Okay, so this is our data set with only 5 rows. If you want to see full data set, you can like from starting from 0 and ending it 4914 rows. Okay, 49115 rows and 12 columns. Right. So let me give something like this for the better visual. Yeah. Okay. So moving ahead, let's sort this Wilson bound column to ascending order for better analysis. So I am talking about this Wilson lower bound column. This one. For it's not 000 like in all the rows. So let me show you. So here you have to write like df equals to df dot sort values Wilson, spelling should be correct, lower bound. I will make it to ascending order, descending order. So df dot drop named unnamed colon 0. Okay, in place equals to true, comma axis equals to 1. Okay, so let's see our data. So here you can see the data is sorted in as ascending order. Okay. So the provided row or column is eliminated via the drop function. The drop method eliminates the specified column when the column axis is specified. The drop method eliminates the designated row when the row axis is supplied. Okay. So I hope you guys understand till here. If you have any queries or like any queries regarding any code or there is something question till here, just put as in comments. Our team will shortly provide you the correct solution. Okay. So moving forward, let's make a function for missing values. So, okay. So I will write here like df missing values analysis. Okay, it's def for function we use def. Yeah, def columns equals to col for columns for col in df dot columns if df column is null dot sum is greater than 0. underscore miss equals to df underscore columns underscore is null dot sum dot sort underscore values like in ascending ascending equals to true. Okay. Like sum be like this and this. That's fine, I guess. Yeah. So here I will write ratio underscore equals to df na underscore columns underscore dot is null. Same thing, that sum divided by f dot shape level 100 dot sort values sending equals to true. Fine. Okay. Sum is okay, and the df part. Let sort values equals to sending equals to true. Fine. So here we will write missing underscore df equals to pd dot concat p dot round ratio underscore comma 2. Yeah, perfect. Their axis will be 1. Okay. Is equals to, I will give like total, where I will write missing values, okay, comma ratio thing underscore df equals to pd dot data frame score df. Okay, so let me return thing df. Let me create one more function for like check data frame. So df check underscore data frame. Okay, it equals to 5 comma tail equals to 5. So here I will write print shape. Okay, dot center 2 comma Again for rows, print rows, curly braces, okay, dot format dot format yeah, dot shape 0. So for columns, print dot shape print types like of types of data dot center, same as like that, 82 comma int df dot d types center. Just printing this is like, you will see, don't worry, just stay with me, you will see the beautiful result. Okay, print values, print missing values, analysis, analysis like df. Okay, then again duplicated values, like there's many, how many duplicated values are there. So dot same for the center 3 comma again this one print f dot duplicated. Don't worry, I will explain you like line by line. Just stay with me. Let me write the whole code. First, print tiles. Like I'm printing multiple of things. So just be with me. Dot enter 82 comma ef dot one tile 0.05 comma 1. Okay. Check data frame. I'm hoping like there will be no error. Yeah. So you can see now like multiple information regarding dataset is printed. So this shape is for like how many rows and columns present in the dataset. Like in types, you can say like every column type like object, int 64, float 64, and many more are like present. So like you can see review text is like object, and day difference is int 64, and Wilson lower bound is float 64. Okay, so total missing values. So total missing values are like one from here and one from here. Like one in from reviewer name and other is from reviewer text. And like there is no duplicated values in our dataset. And here you can see. So like after that quantiles. A quantile defines a particular part of the dataset. That is, a quantile determines how many values in the distribution are above or below a certain limit. Special quantiles are the like quartile quarter, and you can say quintile, that the fifth one, and the percentile which is from 100th. Okay, so quantile is for like quarter, or the you can say the fifth one. So why I wrote this 83, 82, and this for this purpose, for making this something look cool. That is why. Okay, and yeah. So moving forward, let's see unique values and in each column. Okay, so I will write def check class data frame unique f equals to pd dot data frame variable variable data frame dot columns comma classes colon data frame I will write like n unique UUE or I in data frame dot columns, okay, like n unique u or df equals to dot sort values classes comma ascending equals to false. Okay, n unique underscore df equals to n unique df dot reset index drop equals to true. Return n unique QUE n unique underscore df check underscore class which one df. So let me run this first. Yeah, it's running. You can see here. Okay, there is an error. Classes. Okay, check class TF. Is saying that this is okay. C is capital, C is small. Let me run now. Yeah. So here you can see the every column having unique values are sorted in descending order. Like review tags have like more unique values. So it come first, and then reviewer name, reviewer time, day difference, Wilson lower bound, score average, then goes to overall. Okay. Moving forward, let's do some categorical variable analysis for overall. Yes, so this will be like amazing. Something amazing is going to be happen. So constants equals to, so I'm giving here like some color values. So B34 D22 EB00C. Okay, so you can change, you can like write whatever you want color. Hashtag, oh I didn't write hashtag. Yeah, hashtag 3, come on, 1 F C, hashtag 0C92 EB. EB0 C and then D, you like 5, right? Okay, so DEF, let's make function. Okay, small DEF categorical variable summary. Okay, DF comma column. Okay, categorical variable summary. Yeah, perfect. So let's make some figures. So make subplots, plots, rows equals to 1 comma calls equals to 2. Let me write from here like subplot titles equals to count plot like 1 for percentage. Okay. So specs equals to a like type colon y. Okay, comma same type colon here domain. figure dot add and then trace go dot bar, like one bar and one that pie chart. Okay, y equals to df columns, column name, value, values dot to list. For x you can like string, yeah, str I for I in, yeah, column name dot value dot counts index, text equals to df column name dot value counts and then bracket dot values dot to list. Okay, so for text font, the size should be 14 is enough, I guess. So column underscore name exposition. So I'm doing for like making chart. So stay with me to see that amazing chart. Okay. So show legend. To dictate color equals to constants. So these are the like colors. So I'm giving here value like variable name constants comma line equals to line hashtag db e6ec comma width to 1. Okay, small. Okay, let me just like go over through everything is correct or not for the column name value counts index. Yeah, it's fine. Text equals to df column name dot value counts dot values to list. Okay. Text font equals to text size, then okay, font size is enough. Name equals to column name, and text position equals to auto, and show legend false, and mark dict like color equals to constant. Okay, fine line equals to color, and this, yeah, this. Okay, cool. Row equals to 1 comma column equals to 1. Seems good. Like for pie chart, we will make figure dot add. So this is done for the line chart, not line chart, that bar chart, and this I'm doing for the pie chart. Okay, trace go dot pie f columns, column name, value, count, keys, values equals to df. Again, that column name, dot value, count, counts, and dot values. Text font equals to text. Size, I will prefer 18 is enough. Exposition equals to, like, auto is fine. So legend equals to no need of legend, false. Name equals to column name, value, column name, equals to like text, then colors equals to constants, equals to 1. One column equals to 2, like in second. Okay, you will see and you will get to know, don't worry. So figure dot update layout title equals to text column 0.9 0.5 comma x or should be on center. And Y anchor be on top. Let equals to totally. Okay. I plot figure. Let me run this. Okay, like okay, call equals to 2. Now let's see the chart of like column overall one. So we will write here categorical. Okay, variable summary, and then data frame name df comma overall. Okay, let's run this. Okay, it's loading here. It's loading. Yeah, you can see this is our bar plot and this is our pie chart. So like this is overall. From overall you can say that column. So like percentage bar and that bar plot. So this is how our like pie chart and bar chart looks like. I hope you guys understand till here. If you have any questions or any query regarding any code, okay, like any code, any sort of code, so just put as in comments. Our team will shortly provide you the correct solution. So moving forward, our goal is to rank the comments by the sentiment analysis, so we don't get hung up on the other details. I have sorted this dataset according to certain rules before. So moving forward, we want to clean our data. So let's see the sample data for cleaning. So df dot review text, okay, dot head. Let me run this. So this is our sample data looks like. So let's see like data, full data for this. Okay, let me see for this, I guess. Okay. For like any particular row, you can say I can take. Okay. So I will write review underscore example equals to df dot review text. I will take a random 2031, I guess. Okay. So review underscore example. So this is like at 2031 there is one review text. Okay, so in that the whole data is here. Like so my lovely wife bought me a Samsung Galaxy Tab for father, this, like to find the exact model number. This is a long, comment. I got the this, it works like a charm. Okay, so after seeing this data, what we're gonna do is like we will clean it from punctuation and numbers using regex. Regex what? A regular expression. Okay, so here I will write review underscore example. Okay, equals to re dot sub, and what I will do is, okay, I will explain. Don't worry. Small a to capital A to Z, okay, comma, then space, comma, review underscore example, add, sorry, yeah, review example. So here we used RE for regular expression, okay, and so all the punctuation and numbers are removed from particular data. So let me check first. Okay, this A to Z, then A to Z. Okay, fine. So like all the punctuation and numbers are removed from particular data. I will now convert the text to all lowercase. Our machine learning algorithm recognize words that start with the capital letters as a different word, and we will convert them to lowercase. So thus our machine learning algorithm will not perceive words that start with a capital letter as a different word. So what I will do is, here I will write review sample equals to review again example dot lower. I will split okay, your example. So here you can see we have converted all the words in the lowercase letter by using lower function. And why they are coming in new lines? Because we are splitting them using split function. Okay, if you see only did lowercase for single row like we did for the like 20, I guess 2031. Okay, yeah. So let's make all rows same in lowercase. So I will write here rt equals to lambda x. Cool. str dr x for df view text is capital text df view text text, okay, equals to df view text, yeah, dot lower df dot head. See, all the data is in like lowercase. So I printed just top 10 rows, and like in reviews text column all the are in the lowercase now. So I hope you guys understand till here. If you have any question or any query regarding any code or question till here, like any code, just put as in comments. Our team will shortly provide you the correct solution. And if you need this full code, you can comment down below. Okay, so now the time is come to do sentiment analysis because all the data is sorted. So what will I write here? Let me do it little bit up. Yeah. So I will write from Vader sentiment dot Vader sentiment import sentiment intensity analyzer. Okay. F polarity subjectivity subjectivity equals to df review text dot apply lambda text pd dot series. Okay, here you will write text blob, then again text dot like sentiment. Let me run for loop for index comma row in df review text dot item items for you sentiment intensity analyzer dot polarity scores row negative score for neutral. I will write score. If for positive if this is something crazy, if negative is greater than positive, then df dot location index comma sentiment equals to negative. Negative. Okay, then else if positive is greater than negative, then in this case df dot log index comma sentiment equals to positive p capital. Else df dot loc index sentiment equals to neutral. Okay, so like this is for sentiment analysis, and text blob this thing like text blob, this blob. Okay, it's blob. A text blob will return polarity and subjectivity. Polarity indicates your mood, that is, whether it is positive or negative or neutral. It returns a value between 0 and 1. The closer to 1, the more positive. And the closer to 0 is more negative. Okay, let me run this. It will take a little bit time because this sentiment. Okay, it is getting error. Like module panda has no attribute series. Okay, which one? Text box. Text. Yeah, sentiment. Okay, here. What is the thing? S is capital. Let me run now. It is executing. Like wait for a while. Wait. So it will take time to run because of this sentiment intensity analyzer. It take times. Again, sentiment intensity analyzer. Okay, spelling mistake again. Why index? Index is not defined. Okay, sorry again. Index. It will run, I guess, because everything seems good. Negative, positive, and this else. Still loading, so I have to wait like for like 2 minutes more, I guess. Still loading, guys. Yeah, it take time. Sentiment intensity analyzer. So let me tell you again, sentiment analysis, like this text blob will return polarity and subjectivity. So polarity indicates your mood, that is whether it is positive, it is negative, or it will be neutral. It returns a value between 0 and 1. The closer to 1, the more positive. The closer to 0, more negative. Okay, I guess it's still running. So it will take time. So let me write code for that. 20 interpretation. I repeat. Moving forward, let's identify the 20 interpretation. Now we can include the positive, negative, and neutral status of the comment. Okay. Then df sentiment equals to positive dot leaves Wilson lower sending equals to false. Okay. Dot head, it's 5. If I will run, it may give errors to me because it's still running here, it's still loading. So let let me write code for that unbalanced data problem. So like we will categorize that data into positive, negative, and neutral. Okay, so categorical variable summary df element. Yeah, it came like this because of this. Wait, I will tell you. Yeah. So here you can see the pie chart distributed in negative, positive, and neutral emotions. Okay. Or you can say ratings. And here you can see the bar chart also. So, and you can see the percentage distributed in each, like in positive, negative, and neutral one. So, I hope you guys must understood the concept of sentiment analysis, how we can implement it using Python.
If you want to become an AI expert and gain handsome salary packages, look at the wide range of AI/ML courses by Simplilearn in collaboration with top universities across the globe. So, what are you waiting for? Hurry up and enroll now. Find the course link in the description box.
So, in today's session, we will discuss what fake news is, and at the end, we will do a hands off lab demo of how to detect fake news using machine learning. Before we move on to the programming part, let's discuss first what fake news is and proceed further for the same. What is fake news? False or misleading information that is reported as news is called fake news. A common goal of fake news is to harm someone or something reputation or to profit through advertising. The term fake news was first used in 1890s, a time when dramatic newspaper reports were common. Even though incorrect information has always been disseminated throughout history. However, the phrase has no clear definition and is often used to refer to all misleading information. High profile individuals have also used it to refer to any news that is not favorable to them. So, dear learners, if you want to upskill your AI and machine learning skill, so give yourself a chance to simply learn professional certificate program in AI and machine learning, which comes with a completion certificate and in-depth knowledge of AI and machine learning. Check this course details from the description box below. Now let's move to our programming part. So first we will open a command prompt to write a command to open Jupyter Notebook. So here we will write Jupyter Notebook. Center. And here I have to select new Python kernel file. Okay. So this is how the kernel look like. So first we will import some major libraries of Python. So here I will write import pandas as pd and import numpy as np. Then import cborn as sns. Okay. Then import sklearn dot model selection import train underscore test underscore split. Before that, I will import matplotlib dot pyplot as plt. Okay, then I will write here from sklearn dot matrix import accuracy score. Then from sklearn dot matrix import classification report and import re, then import string. Okay, then press enter. So it is saying, okay, here I have to write from. Everything seems good. Loading. Let's see. Okay, till then, NumPy is a Python library used for working with arrays. It also has function for working with the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. Pandas. So Panda is a software library written for Python programming language for data manipulation and analysis. In particular, it offers data structure and operation for manipulating numerical tables and time series. Then, Seaborn. An open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization. With data frames and the Pandas library, Seaborn functions with ease. Then Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform for the data visualization and graphical charting package. As a result, it presents a strong open source suitable for MATLAB. The APIs for Matplotlib allow programmers to incorporate graphs into GUI applications. Then this train test split. We may build our training data and the test data with the aid of sklearn train test split function. This is so because the original dataset often serves as both the training data and the test data. Starting with a single dataset, we divide it into two datasets to obtain the information needed to create a model, like hone and test. Accuracy score. The accuracy score is used to gauge the model's effectiveness by calculating the ratio of total true positive to total true negative across all the model prediction. This RE, regular expression. The functions in the model allow you to determine whether a given text fits a given regular expression or not, which is known as RE. Okay, then string. A collection of letters, words, or other characters is called a string. It is one of the basic data structure that serves as the foundation of manipulating data. The str class is a built-in string class in Python. Because Python strings are immutable, they cannot be modified after they have been formed. Okay, so now let's import the dataset. We will be going to import two datasets, one for the fake news and one for the true news, or you can say not fake news. Okay, so I will write here ef underscore fake equals to pd dot read underscore csv, or what can I say, df fake. Okay, data underscore fake. Okay, then fake dot csv. You can download this dataset from the description box below. Then data dot true equals to pd dot read underscore csv. Sorry, csv. Then fake news. Sorry, true. True dot csv. Okay. Then press enter. So these are the two datasets. You can download these datasets from the description box below. So let's see the board dataset. Okay. Then I will write here data underscore fake dot head. So this is the fake data. Okay. Then data underscore true dot head. And this is the true data. Okay. This is not fake. So if you want to see your top 5 rows of the particular dataset, you can use head. And if you want to see the last 5 rows of the dataset, you can use tail instead of head. Okay. So let me give some space for the better visual. So now we will insert column class as a target feature. Okay. Then I will write here data underscore fake class equals to 0. Then data underscore true and class equals to 1. Okay. Then I will write here data underscore fake dot shape and data underscore true dot shape. Okay. Then press enter. So the shape method returns the shape of an array. The shape is a tuple of integers. These numbers represent the length of the corresponding array dimension. In other words, a tuple containing the quantities of entries on each axis is an array shape dimension. So what's the meaning of shape? In the fake world, in this dataset, we have 2, 3, 4, 8, 1 rows and 5 columns. And in this dataset, true, we have 2, 1, 4, 1, 7 rows and 5 columns. Okay, so these are the rows, column for the particular data set. So now let's move and let's remove the last 10 rows for the manual testing. Okay, then I will write here data underscore fake, let's go manual testing equals to data underscore fake dot tail. For the last 10 rows, I have to write here 10. Okay, so for I in range 2, 3, 4, 8, 1, sorry 0, comma 2, 3, 4, 7, 0, comma -1. Okay, then df underscore not df data underscore fake dot drop 1. Yeah, instead of 1 I can write here I comma axis equals to 0 in place equals to true. Then data not here data underscore same I will copy from here and I will paste it here and I will make the particular changes. So here I can write true, here I can write true. Okay, then I have to change a number 21416. Write 21406 -1 same. So press enter. X is equals to 0. Valid syntax. Maybe you mean 00 or show of this. Okay, we will put here double equals. And I'm putting this Fake dot drop ix is equal to 0. अच्छा, in place. Okay. You're also right. Equals to equals to. Yeah. So okay, axis is not defined. So now it's working. So let me see now. Data underscore fake dot shape. Okay, and data dot true and data underscore true dot shape. As you can see, 10 rows are deleted from each dataset. Yeah. So I will write here data underscore fake underscore manual testing and class equals to 0 and data underscore true underscore manual underscore testing class equals to 1. Okay. Just ignore this warning. And let's see data underscore fake underscore manual testing dot head. As you can see, we have this, and then data dot underscore true underscore manual testing dot head. Done. Okay. This is the true data set. So here I will merge data underscore merge equals to pd dot concat. Concat is used for the concatenation. Data underscore fake data underscore true, comma axis equals to 0. Then data underscore merge dot head the top 10 rows. Yeah, as you can see, the data is merged here. Okay. First it will come for the fake news and then with the for the true news. And let's merge true and fake data frames. Okay, we did this, and let's merge the column. Then data dot merge dot columns, or let's see the columns. It is not defined, but I did data underscore merge. These are the columns name, title, text, subject, date, class. Okay, now let's remove those columns which are not required for the further process. So here I will write data underscore or equals to data underscore merge crop title we don't need, then subject we don't need, then to 1. So let's check some null values. It's giving error where because of this. That's good. Then data dot is null dot sum center. So no null values. Okay. Then let's do the random shuffling of the data frames. Okay. For that we have to write here data equals to data dot sample 1. Then data, okay, data dot hat. Okay. Now you can see here the random shuffling is done, and 1 for the true data set and 0 for the fake news one. Okay. Then let me write here data dot reset underscore index place equals to true. Data dot drop comma axis equals to 1, then comma in place equals to true. Okay. Then let me see columns now. Data dot columns. So here we have 2 columns only, rest we have deleted. Okay. So let me see data dot add. Yeah, everything seems good. Let's proceed further and let's create a function to process the text. Okay. For that I will write here but okay, you can use any name text, and text equals to text dot lower. Okay. And text equals to re dot for the substring remove these things from the datas. Okay. So for that I'm writing here comma okay, then text equals to re dot substring comma comma text. Okay. Then I have to write text equals to re dot substring www dot s plus comma comma text. Okay, then text equals to re dot substring, then dot, comma, okay, then text equals to re dot substring, then percentage as again percentage for re dot escape function, right here string dot punctuation, okay, comma, then text, right? Then text equals to re dot substring and n, comma, text equals to re dot substring, right here, and again d, then again, okay, then comma, then again text here, okay, then at the end I have to write here return text. So everything like this these type of special character will be removed from the data set. Okay, let's run this. Let's see. Yeah, so here I will write df, sorry, not df, data, then text equals to data, okay, dot apply to the function name word opt, okay, then press enter. Yeah, so now let's define the dependent and independent variables. Okay, x equals to data text and y equals to data class. Okay, then splitting training and testing data. Okay, sorry. So here I will write x underscore train, comma x underscore test, then y underscore train, comma y underscore test equals to train underscore test underscore split, then x comma y comma test underscore size equals to 0.25. Okay, press enter. So now let's convert text to vectors. For that I have to write here let me z, it's x, so here I will write from sklearn dot feature extraction dot text import t vectorizer. Okay, then vectorization equals to tfid vectorizer Okay, then xv underscore train equals to vectorization or ZATION vectorization dot fit, then transform x underscore train. Okay, then xv underscore test equals to vectorization dot transform x underscore test. Okay, then press enter. So now let's see our first model, logistic regression. So here I will write from sklearn dot linear underscore model. Okay, import logistic regression. Okay. Then lr equals to logistic regression, and I have to write here lr dot fit, then xv dot not dot xv dot train comma xv underscore test. Okay, press enter. L dot xv dot train. Okay, here I have to write y train. Okay, then press enter. Will work. So here I will write prediction underscore linear regression equals to lr dot predict xv underscore test. Okay, let's see the accuracy score. For that I have to write lr dot score, then xv underscore test comma y underscore test. Okay, let's see the accuracy. So here as you can see accuracy is quite good, 98%. Okay, now let's print the classification port y underscore test comma prediction of linear regression. Okay, so this is, you can see precision score, then f1 score, then support value, accuracy. Okay, so now we will do this same for the decision tree gradient boosting classifier, random forest classifier. Okay, then we will do model testing, then we will predict the score. Okay, so now for the decision tree classification. So for that I have to import from sklearn dot tree import decision tree classifier. Okay, then at the short form I will write here, I will copy it from here, then okay, then I have to write the same as this, so I will copy it from here and here. Just change linear regression to decision tree classifier. Okay, then I will write here same. So dt equals to dt dot predict xv underscore test. It's v still loading. It will take time. Okay, till then let me write here for the accuracy dt dot score v underscore test comma y. Okay, let's wait. Okay, let's run the accuracy. So as you can see, accuracy is good than this linear regression. Okay, logistic regression. Okay, so let me show you the. Let me predict print. Okay, so this is the accuracy score. This is the all the report. Yeah. So now let's move for the gradient boosting classifier. Okay, for that I've write from sklearn dot ensemble port gradient boosting classifier. Classifier. I will write here GB equals to, let me copy it from here. Okay. I will give here random underscore state equals to 0. Wait. So I will write here GB dot fit xv underscore train comma y underscore train. Okay, then press enter. Here I will write predict underscore GB equals to GB dot fit, sorry, predict xv dot test, not dot underscore test. Till then it's loading, so I will write here for the score, then I will add GB dot score, then xv underscore test comma y underscore test. Okay, so let's wait, it is running this part. Till then let me write for the printing this. Okay, it's taking time. Still taking time. What if I will run this? It's not coming because of this. Yeah, it's done now. So you can see the accuracy is uh, not good than decision tree, but yeah, it is also good, 99.4 something. Okay, so now let's check for the last one, random forest. First I will do, for the random forest we have to write from sklearn dot ensemble import random forest classifier. Okay, then here I will write rf equals to, right, I will copy it from here. Then random state equals to 0. Then rf dot fit v underscore train comma y underscore train. Okay, then press enter and predict underscore rc or f equals to rf dot predict v underscore test. Okay, till then I will write here, it's still loading, it will take time. So till then I will write for the score accuracy score xv underscore test comma y underscore test. Okay, then I will write here till then print classification port and y underscore test comma it will take time little bit. So it run, the accuracy score is 99, it is also good. So now I will write the code for the model testing. So I will get back to you but after writing the code. So I have made two functions, one for the output label and one for the manual testing. Okay, so it will predict the all the from the all models from the repeat. So it will predict the news is fake or not from all the models. Okay, so for that let me write here news was to string put. Okay, then I will write here manual underscore testing. Okay. So here I will, you can add any news from the, you can copy it from the internet or whatever, from wherever you want. So I'm just copying from the internet. Okay, from the Google, the news which is not fake. Okay, I'm adding which is not fake because I already know, I searched on Google. So I'm entering this. So just run it, let's see what is showing. Okay, string input object is not callable. Okay, let me check this first. Okay, I have to give here str only. Yeah, let's check. Okay, I have to add here again the script. Yeah, the manual testing is not defined. Let me see manual testing. Okay, I have to edit something. It is just GB and it is just RF. Still GBC is not defined. Okay, okay. So what I have to do? I have to remove this. Okay. Everything seems sorted now. So as I said to you, I just copied this news from the internet. I already know the news is not fake, so it is showing not a fake news. Okay. So now what I will do, I will copy one fake news from the internet, and let's see it is detecting it or not. Okay. So let me run this, and let me add the news for this. So all the models are predicting right it is a fake news, or you can add your own script like this is the fake news. Okay. I hope you guys understand till here. So I hope you guys must have understand how to detect a fake news using machine learning. You can copy any news from the internet and you can check it is fake or not. Okay.
If you want to become an AI expert and gain handsome salary packages, look at the wide range of AI/ML courses by Simplilearn in collaboration with top universities across the globe. So, what are you waiting for? Hurry up and enroll now. Find the course link in the description box.
Hello everyone, welcome to this session. I'm Mohan from Simplilearn, and today we'll talk about interview questions for machine learning. Now, this video will probably help you when you're attending interviews for machine learning positions, and the attempt here is to probably consolidate 30 most commonly asked questions and to help you in answering these questions. We tried our best to give you the best possible answers, but of course what is more important here is rather than the theoretical knowledge, you need to kind of add to the answers or supplement your answers with your own experience. So the responses that we put here are a bit more generic in nature, so that if there are some concepts that you are not clear, this video will help you in kind of getting those concepts cleared up as well. But what is more important is that you need to supplement these responses with your own practical experience. Okay, so with that, let's get started. So one of the first questions that you may face is, what are the different types of machine learning? Now, what is the best way to respond to this? There are three types of machine learning. If you read any material, you will always be told there are three types of machine learning. But what is important is you would probably be better off emphasizing that there are actually two main types of machine learning, which is supervised and unsupervised. And then there is a third type, which is reinforcement learning. So supervised learning is where you have some historical data and then you feed that data to your model to learn. Now, you need to be aware of a keyword that they will be looking for, which is labeled data. Right? So if you just say past data or historical data, the impact may not be so much. You need to emphasize on labeled data. So what is labeled data? Basically, let's say if you're trying to train your model for classification, you need to be aware of, for your existing data, which class each of the observations belong to, right? So that is what is labeling. So it is nothing but a fancy name, you must be already aware, but just make it a point to throw in that keyword labeled, so that will have the right impact. Okay, so that is what is supervised learning, when you have existing labeled data which you then use to train your model. That is known as supervised learning. And unsupervised learning is when you don't have this labeled data. So you have data, it is not labeled. So the system has to figure out a way to do some analysis on this. Okay, so that is unsupervised learning. And you can then add a few things like what are the ways of performing supervised learning and unsupervised learning, or what are some of the techniques. So supervised learning, we perform or we do regression and classification, and unsupervised learning we do clustering. Okay? And clustering can be of different types. Similarly, regression can be of different types, but you don't have to probably elaborate so much. If they are asking for just the different types, you can just mention these and just at a very high level. But if they want you to elaborate, give examples, then of course I think there is a different question for that. We will see that later. Then the third, so we have supervised, then we have unsupervised, and then reinforcement. You need to provide a little bit of information definition around that as well, because it is sometimes a little difficult to come up with a good definition for reinforcement learning. So you may have to a little bit elaborate on how reinforcement learning works. Right? So reinforcement learning works in such a way that it basically has two parts to it. One is the agent and the environment. And the agent basically is working inside of this environment, and it is given a target that it has to achieve. And every time it is moving in the direction of the target, so the agent basically has to take some action. And every time it takes an action which is moving the agent towards the target, right, towards a goal. A target is nothing but a goal. Okay? Then it is rewarded, and every time it is going in a direction where it is away from the goal, then it is punished. So that is the way you can a little bit explain. And this is used primarily, or very, very impactful for teaching the system to learn games and so on. Examples of this are basically used in AlphaGo. You can throw that as an example where AlphaGo used reinforcement learning to actually learn to play the game of Go, and finally it defeated the Go world champion. Right? This much of information that would be good enough. Okay. Then there could be a question on overfitting. So the question could be, what is overfitting and how can you avoid it? So what is overfitting? So let's first try to understand the concept, because sometimes overfitting may be a little difficult to understand. Overfitting is a situation where the model has kind of memorized the data. So this is an equivalent of memorizing the data. So we can draw an analogy so that it becomes easy to explain this. Now let's say you're teaching a child about recognizing some fruits or something like that. Okay, and you're teaching this child about recognizing, let's say, 3 fruits: apples, oranges, and pineapples. Okay, so this is a small child, and for the first time you're teaching the child to recognize fruits. Then, so what will happen? So this is very much like that is your training data set. So what you will do is you will take a basket of fruits which consists of apples, oranges, and pineapples. Okay, and you take this basket to this child, and there may be, let's say, hundreds of these fruits. So you take this basket to this child and keep showing each of this fruit, and then first time obviously the child will not know what it is. So you show an apple and you say, hey, this is apple. Then you show maybe an orange and say this is orange, and so on and so forth. And then again you keep repeating that, right? So till that basket is over. This is basically how training works. In machine learning also, that's how training works. So till the basket is completed, maybe 100 fruits, you keep showing this child. And then in the process, what has happened, the child has pretty much memorized these. So even before you finish that basket, right, by the time you are halfway through, the child has learnt about recognizing the apple, orange, and pineapple. Now what will happen after halfway through? Initially you remember it made mistakes in recognizing, but halfway through now it has learned. So every time you show a fruit, it will exactly 100% accurately, it will identify. It will say, the child will say this is an apple, this is an orange, and if you show a pineapple, it will say this is a pineapple, right? So that means it has kind of memorized this data. Now let's say you bring another basket of fruits, and it will have a mix of maybe apples, which were already there in the previous set, but it will also have, in addition to apple, it will probably have a banana or maybe another fruit like a jackfruit. Right? So this is an equivalent of your test data set, which the child has not seen before. Some parts of it probably has seen, like the apples it has seen, but this banana and jackfruit it has not seen. So then what will happen? In the first round, which is an equivalent of your training data set, towards the end it has 100% it was telling you what the fruits are. Right? Apple was accurately recognized, orange was accurately recognized, and pineapples were accurately recognized. Right? So that is like 100% accuracy. But now when you get a fresh set which were not a part of the original one, what will happen? All the apples maybe it will be able to recognize correctly, but all the others like the jackfruit or the banana will not be recognized by the child. right? So this is an analogy, this is an equivalent of overfitting. So what has happened during the training process, it is able to recognize or reach 100% accuracy, maybe very high accuracy, okay, and we call that as very low loss, right? So that is the technical term. So the loss is pretty much zero and accuracy is pretty much 100%. Whereas when you use testing, there will be a huge error, which means the loss will be pretty high and therefore the accuracy will be also low. Okay, this is known as overfitting. This is basically a process where training is done. Training process it goes very well, almost reaching 100% accuracy, but while testing, it really drops down. Now, how can you avoid it? So that is the extension of this question. There are multiple ways of avoiding overfitting. There are techniques like what you call regularization. That is the most common technique that is used for avoiding overfitting. And within regularization, there can be a few other subtypes like dropout in case of neural networks and a few other examples. But I think if you give example or if you give regularization as the technique, probably that should be sufficient. So there will be some questions where the interviewer will try to test your fundamentals and your knowledge and depth of knowledge and so on and so forth. And then there will be some questions which are more like trick questions that will be more to stump you. Okay, then the next question is around the methodology. So when we are performing machine learning training, we split the data into training and test, right? So this question is around that. So the question is, what is training set and test set in machine learning model and how is the split done? So the question can be like that. So in machine learning, when we are trying to train the model, so we have a 3-step process. We train the model and then we test the model, and then once we are satisfied with the test, only then we deploy the model. So what happens in the train and test is that you remember the labeled data. So let's say you have 1,000 records with labeling information. Now, one way of doing it is you use all the 1,000 records for training, and then maybe, right, which means that you have exposed all these 1,000 records during the training process, and then you take a small set of the same data and then you say, okay, I will test it with this. Okay, and then you probably, what will happen, you may get some good results. Right? But there is a flaw there. What is the flaw? This is very similar to human beings. It is like you are showing this model the entire data as a part of training. Okay, so obviously it has become familiar with the entire data. So when you're taking a part of that again and you're saying that I want to test it, obviously you will get good results. So that is not a very accurate way of testing. So that is the reason what we do is we have the label data of this 1,000 records or whatever. We set aside, before starting the training process, we set aside a portion of that data and we call that test set, and the remaining we call as training set, and we use only this for training our model. Now, the training process, remember, is not just about passing one round of this data set. So let's say now your training set has 800 records. It is not just one time you pass this 800 records. What you normally do is you actually, as a part of the training, you may pass this data through the model multiple times. So this 1,000 records may go through the model maybe 10, 15, 20 times till the training is perfect, till the accuracy is high, till the errors are minimized. Okay, now, so which is fine, which means that that is what is known as the model has seen your data and gets familiar with your data. And now when you bring your test data, what will happen is this is like some new data, because that is where the real test is. Now you have trained the model and now you are testing the model with some data which is kind of new. That is like a situation, like a realistic situation, because when the model is deployed, that is what will happen. It will receive some new data, not the data that it has already seen, right? So this is a realistic test. So you put some new data. So this data which you have set aside is for the model, it is new. And if it is able to accurately predict the values, that means your training has worked. Okay, the model got trained properly. But let's say while you're testing this with this test data, you're getting a lot of errors. That means you need to probably either change your model or retrain with more data and things like that. Now, coming back to the question of how do you split this, what should be the ratio? There is no fixed number. Again, this is like individual preferences. Some people split it into 50-50, 50% test and 50% training. Some people prefer to have a larger amount for training and a smaller amount for test, so they can go by either 60-40 or 70-30, or some people even go with some odd numbers like 65-35 or 63.33 and 33, which is like 1/3 and 2/3. So there is no fixed rule that it has to be something, the ratio has to be this. You can go by your individual preferences. All right, then you may have questions around data handling, data manipulation, or what do you call data management or preparation. So these are all some questions around that area. There is again no one answer, one single good answer to this. It really varies from situation to situation, and depending on what exactly is the problem, what kind of data it is, how critical it is, what kind of data is missing, and what is the type of corruption. So there are a whole lot of things. This is a very generic question, and therefore you need to be a little careful about responding to this as well. So probably have to illustrate this again. If you have experience in doing this kind of work in handling data, you can illustrate with examples saying that I was on one project where I received this kind of data. These were the columns where data was not filled, or these were this many rows where the data was missing. That would be, in fact, a perfect way to respond to this question. But if you don't have that, obviously, you have to provide some good answer. I think it really depends on what exactly the situation is. And there are multiple ways of handling the missing data or corrupt data. Now, let's take a few examples. Now, let's say you have data where some values in some of the columns are missing, and you have pretty much half of your data having these missing values in terms of number of rows. Okay, that could be one situation. Another situation could be that you have records or data missing, but when you do some initial calculation, how many records are corrupt, or how many rows or observations, as we call it, has this missing data. Let's assume it is very minimal, like 10%. Okay. Now, between these two cases, how do we? So let's assume that this is not a mission critical situation, and in order to fix this 10% of the data, the effort that is required is much higher, and obviously effort means also time and money, right? So it is not so mission critical, and it is okay to, let's say, get rid of these records. So obviously one of the easiest ways of handling the data part or missing data is remove those records or remove those observations from your analysis. So that is the easiest way to do. But then the downside is, as I said, as in the first case, if let's say 50% of your data is like that, because some column or the other is missing. So it is not like in every place, in every row, the same column is missing, but you have in maybe 10% of the records, column 1 is missing, and another 10% column 2 is missing, another 10% column 3 is missing, and so on and so forth. So it adds up to maybe half of your data set. So you cannot completely remove half of your data set, then the whole purpose is lost. Okay. So then how do you handle? Then you need to come up with ways of filling up this data with some meaningful value, right? That is one way of handling. So when we say meaningful value, what is that meaningful value? Let's say for a particular column, you might want to take a mean value for that column and fill wherever the data is missing, fill up with that mean value, so that when you're doing the calculations, your analysis is not completely way off. So you have values which are not missing, first of all, so your system will work. Number two, these values are not so completely out of whack that your whole analysis goes for a toss. Right? There may be situations where if the missing values, instead of putting mean, maybe a good idea to fill it up with the minimum value or with a 0. So, or with a maximum value. Again, as I said, there are so many possibilities. So there is no like one correct answer for this. You need to basically talk around this and illustrate with your experience. As I said, that would be the best. Otherwise, this is how you need to handle this question. Okay, so then the next question can be, how can you choose a classifier based on a training set data size? So again, this is one of those questions where you probably do not have like a one size fits all answer. First of all, you may not, let's say, decide your classifier based on the training set size. maybe not the best way to decide the type of the classifier. And even if you have to, there are probably some thumb rules which we can use, but then again, every time. So in my opinion, the best way to respond to this question is you need to try out few classifiers irrespective of the size of the data, and you need to then decide on your particular situation which of these classifiers are the right ones. This is a very generic issue, so you will never be able to, just by, if somebody defines a problem to you, and somebody, even if they show the data to you or tell you what is the data or even the size of the data, I don't think there is a way to really say that yes, this is the classifier that will work here. No, that's not the right way. So you need to still test it out, get the data, try out a couple of classifiers, and then only you will be in a position to decide which classifier to use. You try out multiple classifiers, see which one gives the best accuracy, and only then you can decide. Then you can have a question around confusion matrix. So the question can be explain confusion matrix, right? So confusion matrix, I think the best way to explain it is by taking an example and drawing like a small diagram. Otherwise it can really become tricky. So my suggestion is to take a piece of pen and paper and explain it by drawing a small matrix. And confusion matrix is about to find out, this is used especially in classification learning process, and when you get the results, when our model predicts the results, you compare it with the actual value and try to find out what is the accuracy. Okay, so in this case, let's say this is an example of a confusion matrix, and it is a binary matrix. So you have the actual values, which is the labeled data, right? And which is, so you have how many yes and how many no. So you have that information, and you have the predicted values, how many yes and how many no, right? So the total actual values, the total yes is 12 plus 1, 13, and they are shown here. And the actual value no's are 9 plus 3, 12. Okay, so that is what this information here is. So this is about the actual and this is about the predicted. Similarly, the predicted values, there are yes are 12 plus 3, 15 yeses, and no are 1 plus 9, 10 no's. Okay, so this is the way to look at this confusion matrix. Okay, and out of this, what is the meaning conveyed here? So there are 2 or 3 things that needs to be explained outright. The first thing is, for a model to be accurate, the values across the diagonal should be high, like in this case, right? That is one. Number 2, the total sum of these values is equal to the total observations in the test data set. So in this case, for example, you have 12 plus 3, 15 plus 10, 25. So that means we have 25 observations in our test data set. Okay, so these are the 2 things you need to first explain, that the total sum in this matrix, the numbers, is equal to the size of the test data set, and the diagonal values indicate the accuracy. So by looking at it, you can probably have an idea about, is this an accurate model? Is the model being accurate? If they're all spread out equally in all these 4 boxes, that means probably the accuracy is not very good. Okay. Now, how do you calculate the accuracy itself, right? How do you calculate the accuracy itself? So it is a very simple mathematical calculation. You take sum of the diagonals, right? So in this case, it is 9 plus 12, 21, and divide it by the total. So in this case, what will it be? Let me take a pen. So your diagonal values is equal to, if I say D is equal to 12 plus 9, so that is 21, right? And the total data set is equal to, right, we just calculated, it is 25. So what is your accuracy? It is 21 by, so your accuracy is equal to 21 by 25. And this turns out to be about 85%. Right, so this is 85%. So that is our accuracy. Okay, so this is the way you need to explain, draw a diagram, give an example, and maybe it may be a good idea to be prepared with an example so that it becomes easy for you. You don't have to calculate those numbers on the fly, right? So a couple of hints are that you take some numbers which add up to 100. That is always a good idea, so you don't have to really do this complex calculations. So the total value will be 100, and then diagonal values you divide. Once you find the diagonal values, that is equal to your percentage. Okay. All right. So the next question can be a related question about false positive and false negative. So what is false positive and what is false negative? Now, once again, the best way to explain this is using a piece of paper and pen. Otherwise, it will be pretty difficult to explain this. So we use the same example of the confusion matrix, and we can explain that. So a confusion matrix looks somewhat like this, and when we just take it looks somewhat like this, and we continue with the previous example where this is the actual value, this is the predicted value, and in the actual value we have 12 plus 1 13 yeses and 3 plus 9 12 no's, and the predicted values, there are 12 plus 3 15 yeses and 1 plus 9 10 no's. Okay, now in this particular case, which is the false positive, what is a false positive? First of all, the second word, which is positive, okay, is referring to the predicted value. So that means the system has predicted it as a positive, but the real value, so this is what the false comes from, but the real value is not positive. Okay, that is the way you should understand this term, false positive or even false negative. So false positive, so positive is what your system has predicted. So where is that system predicted? This is the one. Positive is what? Yes. So you basically consider this row. Okay, now if you consider this row, so this is all positive values. This entire row is positive values. Okay, now the false positive is the one where the actual value is negative. Predicted value is positive, but the actual value is negative. So this is a false positive, right? And here is a true positive. So the predicted value is positive and the actual value is also positive. Okay, I hope this is making sense. Now let's take a look at what is false negative. False negative. So negative is the second term. That means that is the predicted value that we need to look for. So which are the predicted negative values? This row corresponds to predicted negative values. All right. So this row corresponds to predicted negative values. And what they are asking for? False. So this is the row for predicted negative values, and the actual value is this one, right? This is predicted negative and the actual value is also negative. Therefore, this is a true negative. So the false negative is this one. Predicted is negative, but actual is positive, right? So this is the false negative. So this is the way to explain, and this is the way to look at false positive and false negative. Same way, there can be true positive and true negative as well. So again, positive, the second term you will need to use to identify the predicted row, right? So if we say true positive, we need to take for the predicted part. So predicted positive is here. Okay, and then the first term is for the actual. So true positive. So true in case of actual is yes, right? So true positive is this one. Okay, and then in case of actual, the negative. Now we are talking about, let's say, true negative. True negative. Negative is this one, and the true comes from here. So this is true negative. Right? 9 is true negative. The actual value is also negative and the predicted value is also negative. Okay, so that is the way you need to explain this, the terms false positive, false negative, and true positive, true negative. Then you might have a question like, what are the steps involved in the machine learning process, or what are the 3 steps in the process of developing a machine learning model, right? So it is around the methodology that is applied. So basically, the way you can probably answer in your own words, but the way the model development of the machine learning model happens is like this. So first of all, you try to understand the problem and try to figure out whether it is a classification problem or a regression problem. Based on that, you select a few algorithms and then you start the process of training these models. Okay, so you can either do that, or you can, after due diligence, you can probably decide that there is one particular algorithm which is most suitable. Usually it happens through trial and error process, but at some point you will decide that, okay, this is the model we are going to use. Okay, so in that case, we have the model, algorithm, and the model decided, and then you need to do the process of training the model and testing the model. And this is where, if it is supervised learning, you split your data, the labeled data, into training data set and test data set. And you use the training data set to train your model. And then you use the test data set to check the accuracy, whether it is working fine or not. So you test the model before you actually put it into production, right? So once you test the model, you're satisfied it's working fine, then you go to the next level, which is putting it for production. And then in production, obviously new data will come and the inference happens. So the model is readily available, and only thing that happens is new data comes and the model predicts the values, whether it is regression or classification. Now, so this can be an iterative process. So it is not a straightforward process where you do the training, do the testing, and then you move it to production. No. So during the training and test process, there may be a situation where because of either overfitting or things like that, the test doesn't go through, which means that you need to put that back into the training process. So that can be an iterative process. Not only that, even if the training and test goes through properly and you deploy the model in production, there can be a situation that the data that actually comes, the real data that comes, with that this model is failing. So in which case you may have to once again go back to the drawing board. Or initially it will be working fine, but over a period of time, maybe due to the change in the nature of the data, once again the accuracy will deteriorate. So that is again a recursive process. So once in a while, you need to keep checking whether the model is working fine or not. And if required, you need to tweak it and modify it and so on and so forth. So net, this is a continuous process of tweaking the model and testing it and making sure it is up to date. Then you might have question around deep learning. So because deep learning is now associated with AI, artificial intelligence, and so on. So it can be as simple as what is deep learning? So I think the best way to respond to this could be deep learning is a part of machine learning. And then obviously the question would be then what is the difference, right? So deep learning, you need to mention there are two key parts that interviewer will be looking for when you are defining deep learning. So first is, of course, deep learning is a subset of machine learning. So machine learning is still the bigger, let's say, scope, and deep learning is one part of it. So then what exactly is the difference? Deep learning is primarily when we are implementing these our algorithms, or when we are using neural networks for doing our training and classification and regression and all that, right? So when we use neural network, then it is considered as deep learning. And the term deep comes from the fact that you can have several layers of neural networks, and these are called deep neural networks, and therefore the term deep learning. The other difference between machine learning and deep learning, which the interviewer may be wanting to hear, is that in case of machine learning, the feature engineering is done manually. What do we mean by feature engineering? Basically, when we are trying to train our model, we have our training data, right? So we have our training labeled data, and this data has several, let's say if it is a regular table, it has several columns. Now each of these columns actually has information about a feature, right? So if we are trying to predict height, weight, and so on and so forth, so these are all features of human beings. Let's say we have census data and we have all this. So those are the features. Now there may be probably 50 or 100, in some cases there may be 100 such features. Now all of them do not contribute to our model, right? So we as a data scientist, we have to decide whether we should take all of them, all the features, or we should throw away some of them. Because again, if we take all of them, number one, of course, your accuracy will probably get affected, but also there is a computational part. So if you have so many features and then you have so much data, it becomes very tricky. So in case of machine learning, we manually take care of identifying the features that do not contribute to the learning process, and thereby we eliminate those features and so on. Right? So this is known as feature engineering, and in machine learning we do that manually. Whereas in deep learning, where we use neural networks, the model will automatically determine which features to use and which to not use, and therefore feature engineering is also done automatically. So this is an explanation. These are two key things probably will add value to your response. All right. So the next question is, what is the difference between, or what are the differences between machine learning and deep learning? So here, this is a quick comparison table between machine learning and deep learning. And in machine learning enables machines to take decisions on their own based on past data. So here we are talking primarily of supervised learning. And it needs only a small amount of data for training, and then works well on low-end systems, so you don't need large machines. And most features need to be identified in advance and manually coded. So basically the feature engineering part is done manually. And the problem is divided into parts and solved individually and then combined. So that is about the machine learning part. In deep learning basically enables machines to take decisions with the help of artificial neural networks. So here in deep learning we use neural nets. So that is the key differentiator between machine learning and deep learning. And usually deep learning involves a large amount of data, and therefore the training also requires, usually the training process requires high-end machines because it needs a lot of computing power. And the machine learning features or the feature engineering is done automatically. So the neural networks takes care of doing the feature engineering as well. And in case of deep learning, therefore, it is said that the problem is handled end to end. So this is a quick comparison between machine learning and deep learning in case you have that kind of a question. Then you might get a question around the uses of machine learning or some real life applications of machine learning in modern business. The question may be worded in different ways, but the meaning is how exactly is machine learning used, or actually supervised machine learning. It could be a very specific question around supervised machine learning. So this is like give examples of supervised machine learning, use of supervised machine learning in modern business. So that could be the next question. So there are quite a few examples or quite a few use cases, if you will, for supervised machine learning. The very common one is email spam detection. So you want to train your application or your system to detect between spam and non-spam. So this is a very common business application of supervised machine learning. So how does this work? The way it works is that you obviously have historical data of your emails, and they are categorized as spam and not spam. So that is what is the labeled information. And then you feed this information or all these emails as an input to your model, right? And the model will then get trained to detect which of the emails are to detect which is spam and which is not spam. So that is the training process. And this is supervised machine learning because you have labeled data. You already have emails which are tagged as spam or not spam. And then you use that to train your model, right? So this is one example. Now, there are a few industry-specific applications for supervised machine learning. One of the very common ones is in healthcare diagnostics. In healthcare diagnostics, you have these images and you want to train models to detect whether from a particular image, whether it can find out if the person is sick or not, whether a person has cancer or not. Right? So this is a very good example of supervised machine learning. Here, the way it works is that existing images, it could be X-ray images, it could be MRI or any of these images are available and they are tagged saying that, okay, this X-ray image is defective or the person has an illness, or it could be cancer, whichever illness, right? So it is tagged as defective or clear or good image and defective image, something like that. So we come up with a binary, or it could be multi-class as well, saying that this is defective to 10%, this is 25%, and so on. But let's keep it simple. You can give an example of just a binary classification, that would be good enough. So you can say that in healthcare diagnostics, using image, we need to detect whether a person is ill or whether a person is having cancer or not. So here, the way it works is you feed labeled images and you allow the model to learn from that, so that when new image is fed, it will be able to predict whether this person is having that illness or not, having cancer or not, right? So I think this would be a very good example for supervised machine learning in modern business. All right, then we can have a question like, so we've been talking about supervised and unsupervised, and so there can be a question around semi-supervised machine learning. So what is semi-supervised machine learning? Now, semi-supervised learning, as the name suggests, it falls between supervised learning and unsupervised learning, but for all practical purposes, it is considered as a part of supervised learning. And the reason this has come into existence is that in supervised learning, you need labeled data. So all your data for training your model has to be labeled. Now, this is a big problem in many industries or under many situations. Getting the labeled data is not that easy because there's a lot of effort in labeling this data. Let's take an example of the diagnostic images. We can just let's say take X-ray images. Now there are actually millions of X-ray images available all over the world, but the problem is they are not labeled. So the images are there, but whether it is defective or whether it is good, that information is not available along with it, right, in a form that it can be used by a machine, which means that somebody has to take a look at these images, and usually it should be like a doctor, and then say that, okay, yes, this image is clean and this image is cancerous and so on and so forth. Now that is a huge effort by itself. So this is where semi-supervised learning comes into play. So what happens is there is a large amount of data, maybe a part of it is labeled. Then we try some techniques to label the remaining part of the data so that we get completely labeled data, and then we train our model. So I know this is a little long winding explanation, but unfortunately there is no quick and easy definition for semi-supervised machine learning. This is the only way probably to explain this concept. We may have another question as what are unsupervised machine learning techniques? Or what are some of the techniques used for performing unsupervised machine learning? So it can be worded in different ways. So how do we answer this question? So unsupervised learning, you can say that there are two types, clustering and association. And clustering is a technique where similar objects are put together. And there are different ways of finding similar objects. So their characteristics can be measured, and if they have, in most of the characteristics, if they are similar, then they can be put together. This is clustering. Then association, I think the best way to explain association is with an example. In case of association, you try to find out how the items are linked to each other. So for example, if somebody bought maybe a laptop, the person has also purchased a mouse. So this is more in an e-commerce scenario, for example. So you can give this as an example. So people who are buying laptops are also buying a mouse. So that means there is an association between laptops and mouse. Or maybe people who are buying bread are also buying butter. So that is a association that can be created. So this is unsupervised learning, one of the techniques. Okay. All right, then we have very fundamental question. What is the difference between supervised and unsupervised machine learning? So machine learning, these are the two main types of machine learning, supervised and unsupervised. And in case of supervised, and again here, probably the keyword that the person may be wanting to hear is labeled data. Now, very often people say, we have historical data, and if we run it, it is supervised, and if we don't have historical data, yes, but you may have historical data, but if it is not labeled, then you cannot use it for supervised learning. So it's very key to understand that we put in that keyword labeled. Okay. So when we have labeled data for training our model, then we can use supervised learning. And if we do not have labeled data, then we use unsupervised learning. And there are different algorithms available to perform both of these types of trainings. So there can be another question, a little bit more theoretical and conceptual in nature. This is about inductive machine learning and deductive machine learning. So the question can be, what is the difference between inductive machine learning and deductive machine learning, or somewhat in that manner, so that the exact phrase or exact question can vary. They can ask for examples and things like that, but that could be the question. So let's first understand what is inductive and deductive training. Inductive training is induced by somebody, and you can illustrate that with a small example. I think that always helps. So whenever you're doing some explanation, try as much as possible, as I said, to give examples from your work experience or give some analogies, and that will also help a lot in explaining as well, and for the interviewer also to understand. So here we'll take an example, or rather we will use an analogy. So inductive training is when we induce some knowledge or the learning process into a person without the person actually experiencing it. Okay, what can be an example? So we can probably tell the person or show a person a video that fire can burn his finger, or fire can cause damage. So what is happening here? This person has never probably seen a fire or never seen anything getting damaged by fire. But just because he has seen this video, he knows that, okay, fire is dangerous, and if fire can cause damage. Right? So This is inductive learning. Compared to that, what is deductive learning? So here you draw conclusion, or the person draws conclusion out of experience. So we will stick to the analogy. So compared to the showing a video, let's assume a person is allowed to play with fire. Right? And then he figures out that if he puts his finger, it's burning, or if he throws something into the fire, it burns. So he is learning through experience. So this is known as deductive learning. Okay, so you can have applications or models that can be trained using inductive learning or deductive learning. All right, I think probably that explanation will be sufficient. The next question is, are KNN and K-Means clustering similar to one another, or are they same? Right, because the letter K is kind of common between them. Okay, so let us take a little while to understand what these two are. One is KNN, another is K-Means. KNN stands for K nearest neighbors, and K-Means, of course, is the clustering mechanism. Now, these two are completely different, except for the letter K being common between them. KNN is completely different. K-Means clustering is completely different. KNN is a classification process, and therefore it comes under supervised learning, whereas K-Means clustering is actually unsupervised. Okay, when you have KNN, when you want to implement KNN, which is basically K nearest neighbors, the value of K is a number. So you can say K is equal to 3. You want to implement KNN with K is equal to 3. So which means that it performs the classification in such a way that, how does it perform the classification? So it will take 3 nearest objects, and that's why it's called nearest neighbor. So basically based on the distance, it will try to find out its nearest objects that are, let's say, 3 of the nearest objects, and then it will check whether the class they belong to which class, right? So if all 3 belong to one particular class, obviously this new object is also classified as that particular class. But it is possible that they may be from 2 or 3 different classes. Okay, so let's say they are from 2 classes, and then if they are from 2 classes, now usually you take an odd number, you assign an odd number to. So if there are 3 of them and 2 of them belong to one class and then 1 belongs to another class, so this new object is assigned to the class to which the 2 of them belong. Now, the value of K is sometimes tricky, whether should you use 3, should you use 5, should you use 7. That can be tricky because the ultimate classification can also vary. So it's possible that if you're taking K as 3, the object is probably in one particular class, but if you take K is equal to 5, maybe the object will belong to a different class, because when you're taking 3 of them, probably 2 of them belong to class 1 and 1 belong to class 2. Whereas when you take 5 of them, it is possible that only 2 of them belong to class 1 and 3 of them belong to class 2. So which means that this object will belong to class 2, right? So you see that? So the class allocation can vary depending on the value of K. Now, K-Means, on the other hand, is a clustering process, and it is unsupervised, where what it does is the system will basically identify how the objects are, how close the objects are with respect to some of their features. Okay, but the similarity, of course, is the letter K, and in case of K-Means also we specify its value, and it could be 3 or 5 or 7. There is no technical limit as such, but it can be any number of clusters that you can create. Okay, so based on the value that you provide, the system will create that many clusters of similar objects. So there is a similarity to that extent that K is a number in both the cases, but actually these two are completely different processes. We have what is known as naive Bayes classifier, and people often get confused thinking that naive Bayes is the name of the person who found this classifier or who developed this classifier, which is not 100% true. Bayes is the name of the person, Bayes is the name of the person, but naive is not the name of the person, right? So naive is basically an English word, and that has been added here because of the nature of this particular classifier. Naive Bayes classifier is a probability based classifier, and it makes some assumptions that presence of one feature of a class is not related to the presence of any other feature of maybe other classes, right? So which is not a very very strong or not a very, accurate assumption, because these features can be related and so on. But even if we go with this assumption, this whole algorithm works very well, even with this assumption. And that is the good side of it. But the term comes from there. So that is the explanation that you can give. Then there can be question around reinforcement learning. It can be paraphrased in multiple ways. One could be, can you explain how a system can play a game of chess using reinforcement learning? Or it can be any game. So the best way to explain this is again to talk a little bit about what reinforcement learning is about and then elaborate on that to explain the process. So first of all, reinforcement learning has an environment and an agent, and the agent is basically performing some actions in order to achieve a certain goal. And these goals can be anything, either if it is related to game, then the goal could be that you have to score very high, score a high value, high number. Or it could be that your number of lives should be as high as possible. Don't lose lives. So these could be some of them. More advanced examples could be for driving. In the automotive industry, self-driving cars, they actually also make use of reinforcement learning to teach the car how to navigate through the roads and so on and so forth. That is also another example. Now, how does it work? So if the system is basically there is an agent and environment, and every time the agent takes a step or performs a task which is taking it towards the goal, the final goal, let's say to maximize the score or to minimize the number of lives and so on, or minimize the deaths, for example, it is rewarded. And every time it takes a step which goes against that goal, right, contrary or in the reverse direction, it is penalized. Okay, so it is like a carrot and stick system. Now, how do you use this to create a game of chess or to create a system to play a game of chess? Now, the way this works is, and this could probably go back to this AlphaGo example where AlphaGo defeated a human champion. So the way it works is in reinforcement learning, the system is allowed, for example, if in this case we are talking about chess, so we allow the system to first of all watch playing a game of chess. So it could be with a human being or it could be the system itself. There are computer games of chess, right? So either this new learning system has to watch that game or watch a human being play the game, because this is reinforcement learning is pretty much all visual. So when you're teaching the system to play a game, the system will not actually go behind the scenes to understand the logic of your software, of this game or anything like that. It is just visually watching the screen and then it learns. Okay, so reinforcement learning to a large extent works on that. So you need to create a mechanism whereby your model will be able to watch somebody playing the game, and then you allow the system also to start playing the game. So it pretty much starts from scratch. Okay. And as it moves forward, it's right at the beginning, the system really knows nothing about the game of chess. Okay, so initially it is a clean slate. It just starts by observing how you're playing. So it will make some random moves and keep losing badly. But then what happens is over a period of time, so you need to now allow the system, or you need to play with the system, not just 1, 2, 3, 4 or 5 times, but hundreds of times, thousands of times, maybe even hundreds of thousands of times. And that's exactly how AlphaGo has done. It played millions of games between itself and the system, right? So for the game of chess also, you need to do something like that. You need to allow the system to play chess and then learn on its own over a period of repetition. So I think you can probably explain it to this much, to this extent, and it should be sufficient. Now, this is another question which is again somewhat similar, but here the size is not coming into picture. So the question is, how will you know which machine learning algorithm to choose for your classification problem? Now, this is not only classification problem, it could be a regression problem. I would like to generalize this question. So if somebody asks you, how will you choose? How will you know which algorithm to use? The simple answer is there is no way you can decide exactly saying that this is the algorithm I'm going to use. In a variety of situations, there are some guidelines. Like for example, you will obviously, depending on the problem, you can say whether it is a classification problem or a regression problem. And then in that sense, you are kind of restricting yourself to, if it is a classification problem, there you can only apply a classification algorithm, right? To that extent, you can probably, let's say, limit the number of algorithms. But now, within the classification algorithms, you have decision trees, you have SVM, you have logistic regression. Is it possible to outright say, yes, so for this particular problem, since you have explained this, now this is the exact algorithm that you can use? That is not possible. Okay, so we have to try out a bunch of algorithms, see which one gives us the best performance and best accuracy, and then decide to go with that particular algorithm. So in machine learning, a lot of it happens through trial and error. There is no real possibility that anybody can, just by looking at the problem or understanding the problem, tell you that, okay, in this particular situation, this is exactly the algorithm that you should use. Then the questions may be around application of machine learning, and this question is specifically around how Amazon is able to recommend other things to buy. So this is around recommendation engine. How does it work? How does the recommendation engine work? So this is basically the question is all about. So the recommendation engine again works based on various inputs that are provided. Obviously, something like Amazon, a website or e-commerce site like Amazon collects a lot of data around the customer behavior, who is purchasing what. And if somebody is buying a particular thing, they're also buying something else. So this kind of association, right? So this is the unsupervised learning we talked about. They use this to associate and link or relate items. And that is one part of it. So they kind of build association between items, saying that somebody buying this is also buying this. That is one part of it. Then they also profile the users, right? Based on their age, their gender, their geographic location. They will do some profiling, and then when somebody is logging in and when somebody is shopping, kind of the mapping of these two things are done. They try to identify, obviously if you have logged in, then they know who you are and your information is available, like for example your age, maybe your gender, and where you're located, what you purchased earlier, right? So all this is taken, and the recommendation engine basically uses all this information and comes up with recommendations for a particular user. So that is how the recommendation engine works. All right, then the question can be something very basic, like when will you go for classification versus regression, right? When do you do classification instead of regression, or when will you use classification instead of regression? Now, yes, so this is basically going back to the understanding of the basics of classification and regression. So classification is used when you have to identify or categorize things into discrete classes. So the best way to respond to this question is to take up some examples and use it. Otherwise, it can become a little tricky. The question may sound very simple, but explaining it can sometimes be very tricky. In case of regression, we use, of course, there will be some keywords that they will be looking for. So just you need to make sure you use those keywords. One is the discrete values, and other is the continuous values. So for regression, if we are trying to find some continuous values, you use regression. Whereas if you're trying to find some discrete values, you use classification. And then you need to illustrate. What are some of the examples? So classification is like, let's say there are images and you need to put them into classes like cat, dog, elephant, tiger, something like that. So that is a classification problem. Or it can be, that is a multi-class classification problem. It could be binary classification problem, like for example, whether a customer will buy or he will not buy. That is a classification, binary classification. It can be in the weather forecast area. Now, weather forecast is again combination of regression and classification, because on the one hand, you want to predict whether it's going to rain or not. That's a classification problem. That's a binary classification, right? Whether it's going to rain or not rain. However, you also have to predict what is going to be the temperature tomorrow, right? Now, temperature is a continuous value. You can't answer the temperature in a yes or no kind of a response, right? So what will be the temperature tomorrow? So you need to give a number, which can be like 20 degrees, 30 degrees or whatever. Right? So that is where you use regression. One more example is stock price prediction. So that is where again you will use regression. So these are the various examples. So you need to illustrate with examples and make sure you include those keywords like discrete and continuous. So the next question is more about a little bit of a design related question to understand your concepts and things like that. So it is, how will you design a spam filter? So how do you basically design or develop a spam filter? So I think the main thing here is he is looking at probably understanding your concepts in terms of what is the algorithm you will use, or what is your understanding about difference between classification and regression and things like that, right? And the process, of course, the methodology and the process. So the best way to go about responding to this is we say that, okay, this is a classification problem because we want to find out whether an email is a spam or not spam so that we can apply the filter accordingly. So first thing is to identify what type of a problem it is. So we have identified that it is a classification. Then the second step may be to find out what kind of algorithm to use. Now, since this is a binary classification problem, logistic regression is a very common algorithm. But however, right, as I said earlier also, we can never say that, okay, for this particular problem, this is exactly the algorithm that we can use. So we can also probably try decision trees or even support vector machines, for example, SVM. So we will kind of list down a few of these algorithms and we will say, okay, we would like to try out these algorithms. And then we go about taking your historical data, which is the labeled data, which are marked. So you will have a bunch of emails, and then you split that into training and test data sets. You use your training data set to train your model or your algorithm that you have used, or rather the model actually. So, and you actually will have three models. Let's say you are trying to test out three algorithms, so you will obviously have three models. So you need to try all three models and test them out as well, see which one gives the best accuracy, and then you decide that you will go with that model. Okay, so training and test will be done, and then you zero in on one particular model, and then you say, okay, this is the model we will use, and then go ahead and implement that or put that in production. So that is the way you design a spam filter. The next question is about random forest. So what is random forest? So this is a very straightforward question. However, the response, you need to be again a little careful. While we all know what is random forest, explaining this can sometimes be tricky. So one thing is, random forest is kind of, in one way, it is an extension of decision trees, because it is basically nothing but you have multiple decision trees, and trees will basically you will use for doing, if it is classification, mostly it is classification, you will use the trees for classification, and then you use voting for finding the final class. So that is the underlines. But how will you explain this? How will you respond to this? So first thing, obviously, we will say that random forest is one of the algorithms, and the more important thing that you need to, probably the interviewer is waiting to hear, is ensemble learner, right? So this is one type of ensemble learner. What is ensemble learner? Ensemble learner is like a combination of algorithms. So it is a learner which consists of more than one algorithm or more than one maybe models. Okay, so in case of random forest, the algorithm is the same, but instead of using one instance of it, we use multiple instances of it, and we use. So in a way, that is a random forest is an ensemble learner. There are other types of ensemble learners where we have, like, we use different algorithms itself. So you have one maybe logistic regression and a decision tree combined together, and so on and so forth. Or there are other ways, like for example, splitting the data in a certain way, and so on. So that's all about ensemble. We will not go into that. But random forest itself, I think the interviewer will be happy to hear this word ensemble learner. And so then you go and explain how the random forest works. So if the random forest is used for classification, then we use what is known as a voting mechanism. So basically, how does it work? Let's say your random forest consists of 100 trees, okay, and each observation you pass through this forest, and each observation, let's say it is a classification problem, binary classification 0 or 1, and you have 100 trees. Now, if 90 trees say that it is a 0 and 10 of the trees say it is a 1, you take the majority. You may take a vote, and since 90 of them are saying 0, you classify this as 0. Then you take the next observation, and so on. So that is the way random forest works for classification. If it is a regression problem, it's somewhat similar, but only thing is, instead of vote, what we will do is, so in regression, remember what happens? You actually calculate a value. right? So for example, you're using regression to predict the temperature, and you have 100 trees, and each tree obviously will probably predict a different value of the temperature. They may be close to each other, but they may not be exactly the same value. So these 100 trees. So how do you now find the actual value, the output for the entire forest, right? So you have outputs of individual trees which are a part of this forest, but then you need to find the final output of the forest itself. So how do you do that? So in case of regression, you take like an average or the mean of all the 100 trees, right? So this is also a way of reducing the error. So maybe if you have only one tree, and if that one tree makes an error, it is basically 100% wrong or 100% right? But if you have, on the other hand, if you have a bunch of trees, you are basically mitigating that error, reducing that error. Okay, so that is the way random forest works. So the next question is, considering the long list of machine learning algorithms, how will you decide on which one to use? So once again, here there is no way to outright say that this is the algorithm that we will use for a given data set. This is a very good question, but then the response has to be like, again, there will not be a one size fits all. So we need to, first of all, you can probably shorten the list in terms of by saying, okay, whether it is a classification problem or it is a regression problem. To that extent, you can probably shorten the list, because you don't have to use all of them. If it is a classification problem, you only can pick from the classification algorithms, right? So for example, if it is a classification, you cannot use linear regression algorithm there. Or if it is a regression problem, you cannot use SVM, or maybe, no, you can use SVM, but maybe a logistic regression, right? So to that extent, you can probably shorten the list, but still you will not be able to 100% decide on saying that this is the exact algorithm that I'm going to use. So the way to go about is, you choose a few algorithms based on what the problem is. You try out your data, you train some models of these algorithms, check which one gives you the lowest error or the highest accuracy, and based on that, you choose that particular algorithm. Okay. All right. Then there can be questions around bias and variance. So the question can be, what is bias and variance in machine learning? So you just need to give out a definition for each of these. For example, bias in machine learning, it occurs when the predicted values are far away from the actual value. So that is a bias. Okay. And whereas they are all the values are probably, they are far off, but they are very near to each other though. The predicted values are close to each other, right? While they are far off from the actual value, but they are close to each other. You see the difference? So that is bias. And then the other part is your variance. Now variance is when the predicted values are all over the place, right? So the variance is high. That means it may be close to the target, but it is kind of very scattered. So the predicted values are not close to each other, right? In case of bias, the predicted values are close to each other, but they are not close to the target. But here they may be close to the target, but they may not be close to each other. So they are a little bit more scattered. So that is what in case of a variance. Okay, then the next question is about, again, related to bias and variance. What is the trade-off between bias and variance? Yes, I think this is an interesting question, because these two are heading in different directions. So for example, if you try to minimize the bias, variance will keep going high. And if you try to minimize the variance, bias will keep going high. And there is no way you can minimize both of them. So you need to have a trade-off saying that, okay, this is the level at which I will have my bias, and this is the level at which I will have variance. So the trade-off is that pretty much that you decide what is the level you will tolerate for your bias and what is the level you will tolerate for variance, and a combination of these two in such a way that your final results are not way off. And having a trade-off will ensure that the results are consistent, right? So that is basically the output is consistent, and which means that they are close to each other, and they are also accurate, right? That means they are as close to the target as possible, right? So if either of these is high, then one of them will go off the track. Define precision and recall. Now again, here I think it would be best to draw a diagram and take the confusion matrix, and it is very simple. The definition is like a formula. Your precision is true positive by true positive plus false positive, and your recall is true positive by true positive plus false negative. Okay, so that's, you can just show it in a mathematical way. That's pretty much that can be shown. That's the easiest way to define. So the next question can be about decision tree. What is decision tree pruning and why is it? So basically, decision trees are really simple to implement and understand, but one of the drawbacks of decision trees is that it can become highly complicated as it grows. Right? And the rules and the conditions can become very complicated, and this can also lead to overfitting, which is basically that during training you will get 100% accuracy, but when you're doing testing you will get a lot of errors. So that is the reason pruning needs to be done. So the purpose or the reason for doing decision tree pruning is to reduce overfitting or to cut down on overfitting. And what is decision tree pruning? It is basically that you reduce the number of branches, because as you may be aware, a tree consists of the root node, and then there are several internal nodes, and then you have the leaf nodes. Now if there are too many of these internal nodes, that is when you face the problem of overfitting, and pruning is the process of reducing those internal nodes. Alright, so the next question can be, what is logistic regression? So basically, logistic regression is one of the techniques used for performing classification, especially binary classification. Now, there is something special about logistic regression, and there are a couple of things you need to be careful about. First of all, the name is a little confusing. It is called logistic regression, but it is used for classification. So this can be sometimes confusing. So you need to probably clarify that to the interviewer if it's really, if it is required. And they can also ask this like a trick question, right? So that is one part. Second thing is, the term logistic has nothing to do with the usual logistics that we talk about, but it is derived from log. So that the mathematical derivation involves log, and therefore the name logistic regression. So what is logistic regression and how is it used? So logistic regression is used for binary classification, and the output of a logistic regression is either a 0 or a 1, and it varies. So it's basically, it calculates a probability between 0 and 1, and we can set a threshold that can vary. Typically it is 0.5. So any value above 0.5 is considered as 1, and if the probability is below 0.5, it is considered as 0. So that is the way we calculate the probability, or the system calculates the probability, and based on the threshold it sets a value of 0 or 1, which is like a binary classification, 0 or 1. Okay, then we have a question around k nearest neighbor algorithm. So explain k nearest neighbor algorithm. So first of all, what is a k nearest neighbor algorithm? This is a classification algorithm. So that is the first thing we need to mention. And we also need to mention that the k is a number. It is an integer. And this is variable, and we can define what the value of k should be. It can be 2, 3, 5, 7, and usually it is an odd number. So that is something we need to mention. Technically, it can be even number also, but then typically it would be odd number, and we will see why that is. Okay. So based on that, we need to classify objects. Okay, we need to classify objects. So again, it will be very helpful to draw a diagram. If you're explaining, I think that will be the best way. So draw some diagram like this, and let's say we have 3 clusters or 3 classes existing, and now you want to find for a new item that has come, you want to find out which class this belongs to, right? So you go about, as the name suggests, you go about finding the nearest neighbors, right? The points which are closest to this, and how many of them you will find, that is what is defined by k. Now let's say our initial value of k was 5. Okay? So you will find the 5 nearest data points. So in this case, as it is illustrated, these are the 5 nearest data points. But then all 5 do not belong to the same class or cluster. So there are one belonging to this cluster 1, the second one belonging to this cluster 2, 3 of them belonging to this third cluster. Okay. So how do you decide? That's exactly the reason we should, as much as possible, try to assign an odd number so that it becomes easier to assign assign this. So in this case, you see that the majority, actually, if there are multiple classes, then you go with the majority. So since 3 of these items belong to this class, we assign, which is basically in this case, the green or the tennis or the third cluster, as I was talking about. Right? So we assign it to this third class. So in this case, it is that's how it is decided. Okay. So k nearest neighbors. So first thing is to identify the number of neighbors that are mentioned as k. So in this case, it is k is equal to 5. So we find the 5 nearest points and then find out of these 5 which class has the maximum number in that. Okay. And then the new data point is assigned to that class. Okay, so that's pretty much how k nearest neighbors work. All right.
And with that, we have come to the end of NLP Machine Learning course. I hope you found it valuable and entertaining. Please ask any questions about the topics covered in this video in the comment box below. Our experts will assist you in addressing your problems. Thanks for watching. Stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.